this event, co-founder of 65 Labs, and thank you so much for showing up. I know it's day 3, Sunday morning, and all of you here in this room have chosen sleep deprivation over missing a single second of sessions, and I really appreciate that. Thank you. I think we're on the final stretch here. If you haven't noticed, I'm losing my voice, but you should see the rest of the organizers. I've subbed in for Sherry this morning for precisely that reason. But we're super excited to have everyone here. We've loved the energy over the last few days. And when we started putting together AIE Singapore, this is really the sort of energy that we were hoping for, and you've all really delivered. So thank you so much. Before we kick off, I just want to say another quick thank you to the sponsors, the speakers, all the volunteers who've helped us make this conference a magical experience so far. Really appreciate all of you. Whoop. And and would appreciate if everyone here could just give them a quick hand. Great, so you're not here to see me, so without further ado, I'd like to bring SallyAnn from Arize on stage to talk about her experience in building Alyx.
Good morning, everyone. Thanks so much for spending your morning with me. It's pretty early. Let's see. Yes, time to go. All right, let's see. Sorry, I gotta reconnect to my hotspot. I thought I did this already. Cool, there we go. Good morning, everyone. Thanks so much for joining me today. I'm super excited to share some lessons my team and I have learned from building Alyx, our AI agent that we've been working on for a little while here. Before we get into that, I want to introduce myself a little bit. I'm SallyAnn. I'm head of product at Arize. I have a technical background. I started out in data science, and now I'm building products for teams. I'm pretty hands-on. I'm not only the PM of Alyx, but I'm also a core contributor, so I really know the pains firsthand of building an agent. And now I pretty much take that pain and I turn it into tools that actually help folks. So Arize, we make agent work. There are a few things that we do really well. The first piece of it is observability. This is understanding what's happening under the hood for your agent. The second piece is evaluations. This is how we understand how your agents are performing. And then we use all of that data to help you improve and iterate. And then, of course, we have Alyx sitting across the entire stack to help you do all of it. So what are we going to be talking about today? I'm going to tell you a little bit about what Alyx is, and then I'm going to go through 4 lessons we've learned over our journey of building it. So staying on task, context manage it, crystallizing good behavior, and debugging a real agent. So Alyx is your AI engineering agent harness. We've really built Alyx to help you build and scale your AI application in natural language. So it has really evolved the Arize experience. It has plans, reasoning, and executes through really heavy workloads for your AI agents. You can pretty much ask in natural language anything you want, and Alyx can help you execute. It can do things like help you analyze your data, but also help you carry out workflows, like iterating on your prompts or aligning your evals. And it's really a force multiplier for AI eng, PMs, and subject matter experts. And so why am I here telling you all of this? Well, we spent 3 years building Alyx. It's been quite the journey. We first started at the very beginning of kind of generative AI, and now we've gotten to Alyx 2.0 with reasoning and planning. And there's just been a lot of lessons that me and my team have learned. And I think the great part about our industry and our community is we have the opportunity to share back. And so that's what I'm here to do today, is to teach you a little bit about our lessons, so hopefully you don't have to learn them the hard way like we did. So lesson number 1, staying on task. I think every agent builder has experienced this, where you ask your agent to do a handful of things. Maybe it's able to do the first one successfully, but then it forgets about the second and third. And I think that this is something that everybody really tries to solve. People commonly ask me, like, well, why is this happening? People assume it's like a hallucination problem or even a capability problem, but it's really not. It's a tension problem. And so what ends up happening is when we're asking for multiple things from an agent, what typically happens is it is able to see the first one, but then the rest of it kind of gets lost in all of the other data that we're asking for. And so it can be really hard for, once the agent figures out what it needs to do next, it's already forgotten what next even is. So the solution to that is planning. Planning is the way for your agent to first decide what it is it needs to do before actually actioning on it. And so for Alyx, before Alyx even pulls any data, it's first going to come up with an explicit to-do that it has to reason upon and go through step by step before it actually takes that action. And so how we do planning for Alyx is we have planning tools and states. We have 3 tools, to do write, to do update, to do read, and then 4 states, pending, completed, blocked, and in progress. We didn't actually start out with all these states. I'm going to talk about that in the beginning, but we have definitely found that just using something like a finish tool or using prompts was not enough for Alyx to be able to accomplish really complex tasks. And so the tools, this is something that we borrowed from some of our favorite tools like Claude, and this has been a real game changer for us to manage extremely complex tasks. In progress was something that we actually learned. This was a really important lesson. When we first built Alyx, we did not have an in progress. We actually just had like pending and completed. But we added in progress so that Alyx knows exactly what it is, the task that it's currently working on. So it really helps to anchor the agent and what it's trying to accomplish, and just really improved our ability to complete our task correctly. Another really key architectural decision that we made is that planning lives outside the conversation history. And so it's really important to do that because for conversation history, we are doing a bit of truncation, and we never want the plan to get truncated, because if that happens, Alyx won't know what it is that it's trying to accomplish. So we actually inject this every time we're making an LLM call right after the system instructions, separate from all of the data in the conversation history. And this is actually what Alyx sees. So it sees its current plan, it sees all of the status, and then we're actually coaching Alyx along with like, when you're done, call to do update with the status completed when you finish this task. So again, helping Alyx as it's going along, not just giving it kind of a passive prompt, but really an explicit kind of few-shot example of what it is it needs to do as it's carrying out its plan. We also have what we call the finish gate. This is what keeps Alyx from saying that it's done before it's completed all its tasks. So if Alyx tries to call our finish tool without its completed tools, we give it actually a really explicit error that's saying, hey, you need to go back and finish all of your to-do items. It's not a suggestion. It's not like kind of a nudge. It's an explicit structured message that Alyx gets that it cannot go on. The only exception to that is the block status. The block status is used for when we have human in the loop. If you use Alyx, there's a lot of moments where we ask for the human to interact. So if we're creating a prompt, you can kind of get a diff and then accept, or something like an annotation config where it's important for the human to be involved. And so when there's a block status, that's the only situation where Alyx does not have to complete the task because it understands that that's blocked by the human and we're waiting for that response. And so these are some of the core lessons that we have from planning. So enforce in code, not just prompts, few-shot examples, beat any kind of abstract instructions, always use the to-do write to plan, doesn't work. We have to have kind of those explicit functions, and then show the agent what good planning looks like. So some of those examples. All right, context management. Context management is extremely important. It was a non-negotiable for Alyx. We're functioning on a lot of text data, so Alyx is built across the Arize platform. Observability data is for AI applications, which also have a lot of text data, so context management became extremely important. I did a talk on this actually in London, so definitely go check that out. But I think context management is not just managing the context window, but also being really strategic about what it is that we're showing our agents. It's letting them remember what it needs to and forgetting what it doesn't. And so early on, this was actually a system prompt that we had for Alyx, which was for our experimentation comparison. And we said, do not try to compare more than 2 experiments at a time. But this was pretty naive. The problem with this is that one experiment in Arize can be hundreds of rows, which is like 100,000 tokens. And so even just experimenting, or trying to compare a single experiment was going to blow up our context window. So we knew that it was not enough just to be able to have these explicit prompts. So we came up with abstractions. One of them is called large JSON. So what this actually does is when Alyx is returning tool data, we store the majority of it in a server-side memory and provide the agent with an ID that it can grab later if it needs more context. So this is really important. Alyx is constantly grabbing data from our platform. We can't show it all to the LLM, but we also need to be able to give the agent enough context so it knows what to do next. And so that's where we had this idea of like compressing the value, not the structure. At first, what we did is we tried to truncate and just give a preview of like the first little bit of data. So just taking the first like, n tokens of the data. But the problem with that is that Alyx doesn't actually understand what the structure of the data is. So it made it really difficult for it to query, because oftentimes Alyx needs a preview and then it needs to decide what data to look for further. So what we did is compress the values and not the structure. So we kept all of the fields, all of the arrays. Alyx has access to all of that, but then we truncate any large strings within that, and then it can use kind of the large JSON abstraction to go grab more data as needed. We also gave Alyx a bunch of small composable tools, and this is really important. So Alyx has access to 2 tools, JQ, which is just like the same tool that you would use in your command line, and grep.json, which is able to do regex search over serialized data. And the importance of this is these are really, really small tools, but they're super powerful. Alyx can use them together, they can be composable, and use the input of one, or use the output of one into the input of others. And so it just allows Alyx to slice data, aggregate, do all these really powerful functions with really small tools. So nothing super complex. I always like to kind of make this the liking of like a UX programmer. You can think of your tools, and then like your agent is your shell script. So you really will hear me say all the time, think about small little tools that your agent can use, and that will be what will make it the most successful. So these are some lessons in context management. Give hard token budgets on every tool output. We do like a 10,000 limit on all our tools so that we have this predictable content that we know it's going to happen. So we know there will be no overflow. There will just be multiple turns. Compress the values, not structure. Don't paper over problems with artificial limits. Give good exceptions in your feedback loops, and then tool responses may contain customer data, so you should watch your logs. That's another important one. All right, crystallizing good behavior. So when we first started building Alyx, I spent a lot of time with a spreadsheet and like a Google Doc trying to test, but we quickly learned that vibe checking does not scale. It was really hard every time we made a change for me to know whether or not something was going to break, and so we knew that we needed a better solution to that. And what we really found is production traces as your ground truth is extremely powerful. So at first we were trying to kind of write up the golden answers ourselves by hand, but we have a great example in our production traces that we can utilize. And so looking at your data and actually using those as your test cases is one of the most powerful lessons that we've learned with Alyx. We do a few different types of testing when it comes to Alyx. So we have decision point tests where we're looking at one component. We'll pass it through kind of like our orchestrator, and then we'll test what the outcome is. And then we do a very kind of open-ended way of checking this. Like an exact match is not going to work on our outputs. So for an example, like looking at contains any. So for something like producing a timestamp like 2,000 milliseconds, 2 seconds, 2 seconds, there's a lot of different ways. So we have this open-ended check that we can do to determine whether the decision was correct, and I think that that is really powerful, especially when you're using kind of a language model where the output is non-deterministic. The other is trajectory tests. So what we do is we kind of save off all of those production traces that I was mentioning before, and we step through them row by row, and we use an LM as a judge to assess the output. The evaluation prompt really matters here. As I was saying before, these outputs are not deterministic, and so you want to make sure that your evaluation template can handle that and is defining success for each individual step. Level 3 of this is CI and prompt validation. So everything that we do for our testing actually lives in Arize. We're running these as ad hoc tests. We're running them as part of our CI, and then we have these great visualizations so I can actually come in and check how things are working over time, seeing if there's any integration in our performance from our evals. And I think that's what's really cool about building a tool with Arize is that we're dog fooding our own product. So everything that my team is doing, I know that can help our users as well, which has been extremely powerful. And so some lessons from crystallizing behavior: capture good user sessions, match facts, not phrasing, LM as a judge for semantic evaluation, real APIs, not mocks, integrate bugs are real. And then my last lesson here, debugging a real agent. I think this is something that I get a ton of questions on, is like, what are your day-to-day workflows for when there's an issue with Alyx? And so we're really seeing this evolution of software engineering of who is consuming telemetry data. When we first started, we were very human in the loop. I was looking at the data directly, then going to the IDE with me and my engineers were going to our IDEs, making the changes and then observing it. We kind of started to see this software 2.0 where we have our agentic IDEs, and now the human's still involved, but we're using an agent to iterate. And now we're really gotten to this phase 3 where we actually use our coding agent directly to be able to read our OTel data and iterate. So this is kind of the stack that we're currently using, where we still are using Arize. All of our traces go in, our evals, our feedback, but we have what we call Arize skills that allows our cursors, our Claude code to interact directly with Arize and make our feedback loop really, really fast. As agent builders, we have learned that the feedback loop really, really matters. I'm trying to make it how fast can we go from an issue to a fix, and the Arize skills have really helped us with that. And so these are some examples of our Arize skills. These are live if you'd like to try them out yourselves or come talk to us at the booth. But I basically use a lot of our Arize trace and evaluate skills. It just makes it so that my agent can get a signal, pull the traces from Arize, even look at external sources, our code, put up a fix, and then me and my engineers can just review that. And so this is the AI engineering loop that's powered by Arize that we are using ourselves. We're kind of our first guinea pigs always. If it works for Alyx, we know it will work for everybody else. And so you can see we have a bunch of different agents leveraging our skills and improving on Alyx. And so these are some of our debug flows and actions. So reading the traces, pulling the full session, and then identifying the failed notes. We can also read from external sources like Datadog. Alyx is really integrated into our UI, so our APM traces also become increasingly important. And then also things like G-Cloud logs. So we had an example with like out of memory. And so we're able just to go from an issue to the exact root cause really fast so that we can then fix it. And so these are some of our lessons here from debugging. Skills are just markdown. They're low cost, high value. Definitely invest in your skills, your factory. Safety must be wrappers, not prompts. Agent debugging is an agent-shaped problem, and then observability before you need it. You can't really have evals without observability. You can't really fix your agent and make it successful without observability. So that's something that we've definitely learned firsthand. So these are some of the big lessons that we learned and talked about today. I know I went through a lot of material fast, so if you have any questions, we'll be over at the Pullman at our booth, happy to talk through anything in more detail. But thanks so much for spending your morning with me.
Thank you so much, SallyAnn. Up next, we're just going to get set up for Tim from Resaro, who'll be talking to you about scaling evals.
All right, good morning, everyone. Thanks for making time today, especially if you have come from the after party from last night. So today I'll be talking about scaling evals, and maybe to motivate it, let me share with you a bit about the work that Resaro does. So Resaro is a testing and evaluation company. We work primarily with companies in the mission-critical use cases and spaces, for example, healthcare, defense, security, and we help them test and evaluate the AI systems that they are developing or procuring so that they have the confidence that what they are deploying is good enough to go into production. And today I'll be sharing some of the learnings we had over our past couple of years in this journey, where we see the main problems existing, how do we then overcome them, as well as what are the remaining blockers to scaling use case specific testing evaluation. All right, so let's start with this slide over here. Like, what do Cobra's sprint velocity tracking and AI benchmarks have in common? All of them shows examples of perverse incentives, right? So with the examples of Cobras, it's a case that if you incentivize people to catch Cobras, people will actually be breeding them instead. And this leads to actually more Cobras being out there in the wild. Same with sprint velocity tracking. If you're familiar, if you're a software engineer, if your manager asks you to increase the number of story points you can deliver, you see that result, but at the end of the day, it doesn't translate to any meaningful outcomes, at least from my point of view. And then you might have seen some AI benchmarks and you test the latest open source models. They typically don't, they might sometimes differ from your actual user testing versus like what they show in the benchmarks. And you wonder how they manage to actually get such good results. So that leads to the concept of like what we call benchmarking. I think nowadays is getting more popular, where people actually game the benchmarks to show that they're good in certain tasks, but it doesn't really translate to real world performance. On the other side, we have vibe coding, right? I'll call it vibe testing. So vibe testing is a process maybe where you have a couple of example prompts in mind, some trick questions, how many R's are there in strawberries, or maybe can you generate an image of a pelican riding a bicycle? So what we see for these examples actually is that actually it's not that bad because they are pretty useful. They give you a sense of how the model is performing, maybe in a particular scenario or aspects that you're interested in. And they also encourage exploration of the process, right? Where you can try out different prompts and actually find what's good enough for your use case. But I think having said that as well, how do you actually tell whether what is a pelican riding a bicycle testing versus maybe what is a toucan riding on a tuk-tuk? Are we talking about just a bird on a vehicle, or are we talking about maybe some other types of higher level concepts we are testing? So I think it helps to be very explicit over here. Like even if we have a test case in mind, what are the particular dimensions of interest that we are testing and evaluating? And this is where I see the middle ground between benchmarks and vibe testing. So the problem is then how can we structure the vibe testing approach such that we are able to then identify the scenarios of interest, as well as then structure it and scale it up for like a more use case specific evaluation. So this then leads us to the concepts of operational design domains, where we define that as the sort of problems, constraint space that we are testing against. And this helps to govern what is the meaningful set of test cases that we're evaluating. From there, we can then define what is the expected behavior of the system, what are the edge cases that we should be aware of, and also what are the cases that are probably not within the bounds of this system and evaluation, right? So that is totally out of scope and should not be used and consumed by the AI system. So from there, we are then able to derive a pipeline and workflow internally, where we actually translate the ODDs into different test cases of interest, link that up with data quality checks to filter out the data that might not meet our requirements, and also then enhance the data quality if there are gaps over there, right? So we emphasize a lot in terms of finding the coverage gaps so that we are able to fill it. And oftentimes, as we go into more mission-critical use cases, we find that there might not be enough test cases, especially for edge cases of interest. And that's where synthetic data sets or synthetic data generation methods actually helps to breach the testing evaluation process. So we put a lot of emphasis in terms of how can we generate synthetic data in a way to augment the test set. And I think once we have framed the problem as such, we will see that it's actually more of that the data is the bottleneck, right? We can shift the problem from evals to how do we generate the right test cases that give us the confidence for deployment. And the challenge with that then is, especially as you become into more niche and use case specific kind of testing, is that the synthetic data generation methods nowadays are still relatively not totally predictable, right? They don't give you necessarily the quality that you want for your generation. So let me try to give a couple of examples over here. And in this example, we are trying to evaluate maybe like the performance of a VRM solution in like a battlefield scenario and setting. So we have a Panzer tank on the right, right? And the question over here is like, how do we know what's good enough for testing in this particular use case? And how can good enough be defined for the generated data sets over here? And more importantly, I think, how are we able to quantify this testing evaluation such that we can then scale it up in an automated manner? So over here, I have 3 different augmentations, examples of good augmentations, right? So maybe over here, good augmentation is something that follows a prompt. We generate it across 3 different weather scenarios: rain, snow, and fog. And the main subject of interest is also well preserved. There are no side artifacts. So this seems like good generations. And on the other hand, I'm sure if you're familiar with just generating images as well, you see that oftentimes some of the images that generated have different types of artifacts. For example, for the one on the right, you have 2 additional humans being added to the image. And for the ones below as well, you see that some of the original tank in one of the tanks has been converted to a vehicle instead. as well as the range streaks might not be looking as realistic. So how can we go from this vibe checking approach in terms of just eyeballing it and seeing that it looks right or it looks good or it doesn't look right into a more structured manner in terms of finding out these flaws? So for us, it's about how we can then scale up the data quality checks so that we are able to automate the process of identifying such kinds of defects and flaws in a much more scalable manner. And I think we rely a lot on smaller deterministic models as much as possible to provide that insight. Right? So for example, if we are talking about two generated synthetic images, we might want to compare them in terms of whether there's a meaningful change in the depth map structure of the main object of interest. We can also then compare, is there any new subjects of interest that has been created out of it from the original image to the generated image. And all these use much smaller deterministic models that provides very good signals in terms of the data quality. And as part of this pipeline, we can then filter out the data sets that actually meets our quality criteria and use that for the testing evaluation process. We are also then able to actually scale this process up and maybe use this enhanced feedback to actually fine-tune an evaluation model so that we can automate the screening and evaluation process, or subsequently the generative models as well. So at the end of the day, I think what we have ended up in is to assemble a whole pipeline of different metrics that caters to use case specific areas of interest. And this provides us a very reusable toolbox in terms of how we can scale up the generation of the data sets as well as automated quality checks and filtering. So we see this very similar to, for example, the problems in the coding space or in the mathematical reasoning space. You want to automate the validation and verification process as much as possible. This would help reduce the human oversight and overhead required in terms of evaluating this. And if there's any human feedback that comes in, this should help improve our automated models so that this process can then become scalable. The underlying metrics can then also be used for calibration of the data sets that we are generating, because we find that for each use case specific scenario, actually there's a very big distribution of where the cutoff for each metric might be. So the calibration part is a very important statistical concern over here. Okay, so just to round things up, we talk about scaling the evaluation of use case specific scenarios and data sets. And I think the main challenge over here is really in terms of how can we scale up the synthetic data generation routines, as well as add the necessary quality checks to give us the confidence for deployment. With this, if you want to reach out, feel free to contact me on LinkedIn to talk about evals. Happy to talk more about like test cases, evals, and the works that we do. And I'll be around for the rest of the event as well. Thank you and have a good day. See you.
Thank you so much, Tim. That was a great talk. And up next, we have Abhishek from Cloudflare, who heads the ETI team in India there. And he's going to talk to us about how tool calls should actually be done.
Hey everyone, good morning. So I'm Abhishek. I lead the emerging tech and incubation team at Cloudflare and head the India office. So we're a small team within Cloudflare which sort of works on new products initiatives and a lot of cool things at any given point, right? I'm going to talk about tool calling today. I think everyone here at this point has had some sort of experience with tools. Can I have a quick show of hands on whoever here has interacted with MCPs and knows what tool calls are? Awesome. So everyone knows what we're talking about. Great. Standard tool calling, right? You do this to give models capabilities beyond inference, where like, hey, how do I have my model work with external APIs, tools, functionalities, right? So let's take a very standard example. I'm going to monitor an API, look for errors, and sort of do things based on certain conditions, right? The process is very simple. Model sends you like, hey, I need to call this tool. Goes to the MCP server, tool gets called, you get the result and give it back to the model. Sounds pretty simple, right? The problem is, as soon as you start doing more complicated things, this becomes really costly. So let's take an actual example of a production scenario where you might have a model or an agent, essentially, which is doing a long-running task where it's continuously monitoring any new release that happens, right? Wants to monitor for certain percentage of errors, logs, and then based on that, try to do a rollback or make sure that, hey, we're good to release further, right? Standard release process that has been followed for ages. I think everyone here knows how that works. With this setup, what happens is you end up having a bunch of tool calls that happen sequentially one after the other, right? So in this specific scenario, I'm going to have my model go list all my logs, then fetch all my metrics, do conditional checks, based on certain conditions, decide the next step. The problem that we run into here is that every tool call that you do is going to send the entire context of the current conversation, plus the tool call, plus the response, right? So each turn becomes actually more context that you're sending. So one, that's bleeding money. Second, you're adding a lot of round trips, right? So you're going to add a lot of latency. Essentially, there should be a better way of doing this. And I think what we're going to talk about here is basically code mode. So code mode is our thesis around, and I mean, it's not just Cloudflare right now. I think this is becoming extremely popular everywhere as of now. But when we came up with code mode, the idea was models are inherently better at writing code, right? If you quickly take a look at the same example that we just discussed, in a code snippet, it looks something like this, that, hey, I want to get all the errors, metrics. I can parallelize these tasks. Based on that, I want to do some conditional checks and do the next steps. And the reason models are better at doing this is they have been trained on a ton of code, right? Versus tool calls are, most of the tool calls that models have been trained on is all synthetic data and barely any data, right? So by natural instinct, you'd feel that models are actually going to be better at writing code. And that's what we see, right? Today, if we look at the same tool call that we just described, right? Standard tool calls have a tool name, description, parameters, expected output. And that's basically what you feed the model. What we do is we have a library called code mode, which essentially converts this into TypeScript types. So one, now the model has the same sort of setup, but as code. It notes that, hey, there is a function that I can execute to do this. So in this same mapping, right, if you look at it, we have the declaration of the function, which is essentially the tool name. The description there is basically the tool description, and then you have parameters that are passed through it, right, like your expected input and what is the output. Now, what this does is it essentially gives the same sort of capability to the model, but in this case, instead of giving you an order of tools sequentially, the model writes a single code snippet. And basically, what we want this to do is work with everything that is already there in your current stack, right? So you don't need to actually go swap out your entire tools. Instead of passing like an array of tools to the model, we basically pass it a single tool called code mode. So you can wrap up the entire existing toolkit that you have and just pass the model a single tool called code mode. What code mode will be a TypeScript, library, or like, let's say, a file of TypeScript types as a string, which goes to the model where it's like, hey, I know what tools exist, and I can write code against it. In this case, you'll also see something called executor. We'll come to that later. Again, going back to the basics of why we write code, right? Like what we just discussed, a simple scenario that would have taken probably 5, 8 turns can be a single turn. And it also brings reasoning into the picture. Every time you write code, you could embed logic in it, right? You have the capability to do variables, which means you can have interdependent tool calls based on like a previous response and then figure out what to do. You could do branching, what I just described, right? Like if the percentage of errors is above a certain level, you could like do a case 1, otherwise case 2. Same kind. You can do loops. a very standard example. Go through my Cloudflare account, list all the workers, and then give me metrics for all of them. The way it will happen right now without code mode is list workers, fetch worker 1, fetch metrics, fetch worker 2, fetch metrics, right? And that will keep going on. With tool calls, that's going to add context, as we discussed. With code mode, it'll be a single for loop, which can go over it again and again, right? And you can also do things like parallelizing tasks that essentially don't need to wait for each other. So yeah, I want to be very clear, this does not replace MCP. I think this is sort of new as a concept, so have to be very clear here explicitly. MCP is the base protocol. You still need that to essentially do the final last mile API call, right? Your server will still do that. What code mode does is gives model a better way to interact and do the tool calling. The actual implementation of that tool call still happens on the MCP layer, right? I'm going to take a different example, which is like practically what we face, right? So Cloudflare, as most of you, OK, how many of you actually know Cloudflare? Awesome, thanks. Had me worried there. So Cloudflare has over 2,500 APIs, right? Which is a lot, given the kind of products that we have, across a bunch of different areas, verticals. If we just embed this as tools today, right, as like standard MCP tools, it does over 1.7 million tokens in context. For most models, we will overflow the context window with just the tool description. So there's no way this works. And this also comes to the same problem, right? Even if I convert this to TypeScript types today, it will still run into the same problem, right? So the base idea around code mode is not that, hey, you blindly just replicate tools as types and do it, right? For most cases, it will actually work and be better. But something like this, you can take a step back and think, OK, how can we do this better? And one of the things we found here was just give it 2 tools, search and execute, right? And in both these tools, the model can still write code. Now, search and execute as a strategy for doing MCPs has existed for a while. People have created, their searches. Like we have a tool that gets other tools, and then the tool that decides to execute it. But now you can write code here, right? So you can filter out. So think about it in a way where we tell the model, hey, we have a global variable which has the entire description, which is not being passed to the model, but the model has the capability to write code that will give it back the exact tool to be called, and then also write code to execute the same thing. By doing just this, right, like a simple search execute thing, we were able to actually bring it down to 1,000 tokens. The entire Cloudflare API spec today can be called via model with just 1,000 tokens. That's a 99.9% reduction, which is insanely high. I've never seen that level of compression across any sort of things. So this is like a far more optimized way of doing things. Yeah, exactly the example that we just spoke about. You now have the model going like, hey, I'm going to do a tool call to search the thing, write a code against it, put like, an exact script which gets executed. All of this discussion we had, we've been discussing about like model writes code and then it gets executed. But the key question that we come to now is like, where does this get executed, right? So take a step back. Let's go a couple years ago, right? Like pre-AI, if I had come to you and told you, here's a random user-generated code, run it on your setup, none of you would want to do it. That's like an exact massive CV, that's RC, so most people would not want to do it. Yet today I'm standing here and telling you to do the exact opposite, that give models an absolutely untrusted source and let them write code, which could be anything which you never get access to, and run it. So where do we run it? And that's what we come to the tiny computer part, right? You essentially need a very efficient, secure sandbox environment, right? And there are a couple of ways of doing it. I mean, you could do containers. Containers have existed for ages, right? And the problem with containers typically is that you have a massive cold start time, right? You have to provision a lot of it properly. You have memory, you have compute. All of this needs to be planned very well. And then you have, basically it's an external layer, which means you sort of have a lot of challenges of handing over things properly and securely. The other approach here is V8 isolates. Quick show of hands, how many of you know about Cloudflare workers? Awesome. So workers are our own runtime layer, which is based on V8 isolates. So we took V8 isolates, forked it, and created serverless around it. There's a lot of good detailed blogs that you can read about it. But essentially, what this does is it eliminates all the standard problems that we just discussed, right? Like, you actually have 0 cold start time. It's absolutely lightweight, right? And the way workers work is your dynamic workers, which is essentially what we're talking about when we say V8 isolates, will spin up in the exact same location, exact same setup where your main application is running on a worker, right? And again, you could do each isolate as a one request and throwing it away. Right, so again, workers give us like a great boundary. Make sure that it's scoped just to execute that code, does not have chances of leaking secrets, getting malicious code into your actual main setup. And you can decide while initiating a worker what's the kind of scope and capabilities that you want to pass it down. Right, again, just like a quick way, why isolates work better, and essentially, because we own the runtime, it just makes it way easier to actually do sorts of, information exchange, making sure it's done in a secure manner, and you, again, don't have crazy, insane, wait times to spin off things. Yeah, that's pretty much it. Thank you so much.
Thanks for that, Abhishek. And up next, we have Tejas, who's going to talk to us and do a deep dive about agent harnesses.
Is this on? Hello, everybody. Good morning. Wow, all of you are asleep. Can we try this again? Hello, everybody. That's better. Nice. Look, it's a dialogue, not a monologue. Like I'm here to talk to you, not at you. Good morning. He's just setting up my slides right here, but this is going to be a fun conversation, I think. Is everything good? No? Oh, give it up for your tech team, everybody. That's so cool. They make this event possible. I love it. We would be so lost without them. Excuse me one second. Oh my God, he's spoiling my slides. It's all good. Let's go here. There we go. That's me. Okay. Hello. I'm the yellow hand. See, hi. I'm Tejas. Hello, everybody. It's good to meet you again. As you may have seen, my name is Tejas. That's pronounced like contagious. Don't worry, I'm not. They wouldn't have let me in the country otherwise. I flew 16 hours to be here from Romania, where I was yesterday, and I'm based in Berlin. And over the years, I've had the privilege of working at a number of various tech companies with really great teams and learning from the best. In fact, I'm not really here to show you opinions, but just facts of lessons I've learned, not from myself, but from very, very smart people who are far smarter than me. Today, I'm an AI engineer at IBM. Where we build a lot of things, foundation models and harnesses and things for our customers, but also for developers. I help the developer community around IBM and otherwise. I teach people about harnesses and AI and things here. And today, that's what we're here to talk about. We're here to talk about AI harnesses from first principles. Just as a quick show of hands, how many of you feel confident that you know and can explain AI harnesses, agent harnesses? Okay, there's like 3 people. Good. I'll do the same thing at the end of the talk, and I expect more hands. Okay, that's the goal here. That's why I'm here. I'm here to teach you about what harness is and how they work and why you need them, because this is a term that's kind of everywhere. And the problem with terms like this when they're in the zeitgeist is they can get lost in translation. Okay, and sometimes we don't feel confident enough to reason about them strongly, and so hopefully this changes. I'd love to start just by talking about why we even need harnesses, because I think a great leadership principle in general is to start with why. So why do we need a harness? And the answer really is the same answer to why we need a harness for anything that we use harnesses for. Think about climbing a mountain, right? Like you harness yourself to the mountain so that you can go up and down the mountain reliably, meaning you don't fall off and die, okay? Similarly, like if you have a dog or a pet, right? You usually put your dog on a leash, you give it a harness to you so it doesn't run away and get lost, but it stays with you reliably, okay? So the whole point of harnesses for agents or humans or pets or whatever is reliability. And the reason for that is because when we do AI work, we often just trust black boxes. Have you ever thought of this? Like, unless you're doing inference on premise, which who's doing inference on premise, like locally? Yeah, him, and maybe some people, 1 or 2 people here. If you're the vast majority of us, what you do is you send a prompt to some vendor with a black box, and you say, hey, do this for me, and then you hope for the best, right? You send a prompt to, say, Claude 4.7 Opus, but if they have some type of incident, they may serve you Sonnet, and you have no idea of knowing. So you just, okay, I guess it's kind of not feeling. Opus doesn't feel the same today. Has anyone had this sensation, right? That's because you trust some foreign body, and this is why we need harnesses. So what harnesses do is they give you more of a sense of control to make your AI apps and agents more reliable. Okay, is that clear? So that's why we do harness engineering. What is a harness? I already talked about it. It's this thing. But assume that's an agent, not a human, and that's what a harness is. In fact, agent harnesses in particular are a newer sort of evolution of the term harness. In machine learning engineering, we had eval harnesses. These are basically glorified unit tests for models, okay? But agent harnesses are slightly different. If I ask you to define an agent harness, this is what I expect to hear. The answer of what an agent harness is it is everything around your agent, the tool chain, everything around it, the environment in which your agent executes that gives it the best chance of success and reliability. It's everything around the agent. So if we think about some typical agent harnesses in the wild, they all have at least these 6 components. Number 1, they've got a tool registry. They've got a set of tools. If we think about a harness like Claude Code or Codex, they have tools, read and write from the file system, search the web, right? Number 2, there's a language model. Almost every harness will have a language model somewhere, like Claude Code has the Claude models. There's context management primitives for compacting context or clearing context, right? If any of you use Claude Code, you're like /compact. There's guardrails. For example, I think the most common guardrail is you've used up your quota, I'm not going to talk to you anymore until you top up, right? That's a guardrail. There's an agent loop in the picture, where this is where the agent finishes a task and then says, okay, am I actually finished or should I do one more pass? And finally, there's a verify step. So if you are using an agent harness, like let's say Claude Code, I love Claude Code, right? At the end of it, it will say, okay, I've done the task, now let me run npm run verify or whatever it is to finish out this loop. So almost every agent harness, certainly every coding agent harness has these components, if not more. So these are kind of our building blocks. At this point, I'm tired of the sound of my own voice, and so I'll just do a demo instead of talk to you. And so what we're going to do is we're going to actually build a harness here in whatever time we have left, live on stage. It's a poor man's harness, but it's just to kind of give you an idea of what a harness is so you can go build your own. Okay, that's my job here. What we're going to do is we're going to build a browser use agent, something that spins up Chromium and uses it to do a job. As you can see, it will be unreliable at the beginning. That's kind of the point. But we'll build a harness around it to make it safe. I'll say this, harnesses allow you to do more with less. You could choose a really bad model, a really old GPT 3.5 mini or 3.5 turbo, like old. That's like 2 years ago. It's crazy. I'm joking. It's a very old model. And it's cheap. It's basically free. So you can use an unreliable model, and you can use a prompt that is kind of bad, because a harness gives you the reliability. Oftentimes when we don't get the results we want, we think, oh, just prompt it harder. Just fine-tune the system prompt. Change the language. Add a skill. With a harness, you don't need any of this. You can keep the prompt frozen. It can be a bad prompt. You can use an old, cheap model. If your harness is good, you win like 70% of the battle. Okay, so let's do that. I'll build a harness. We'll build one together here on stage, and then we'll wrap up. So this is what I want. I'm just going to run my agent right here. I've written it in TypeScript. Anyone use TypeScript, JavaScript, something? Okay, you'll kind of get it. We'll do npm run agent. And what you'll see is it's going to open a browser. I'm not touching. And it goes to Hacker News. And it tries to upvote an article, but it gets the login screen and crashes. The job of this agent is to go upvote the first article on Hacker News that is not yet upvoted. Okay, is that clear? Yeah, so that's the job. But here's what it does. I'll run it again. Look, so we open a browser. Goes to Hacker News, and we're using GPT 3.5 Turbo, goes to Hacker News, hits the login form, but then it answers me, I have upvoted the highest rank. This is a lie. This is an absolute lie. What actually happens is it tries to click upvote, hits the login form, and then crashes. right? So this is a total lie. How can we fix it? We'll fix it with the harness. To start with, let's look at the actual code of what's happening. So this is Cursor. I love Cursor. And this is our project. So this is what we have so far. We have the model. We're using a very, sorry, I should change this. We're using a very old model, cheap, basically free, and this is our prompt. Upvote a story on Hacker News. These are not going to change, but our harness will change. I want you to know that. I want you to be very clear on that. So here's what happens. We start a new browser session, and that's code that I wrote. This is using Playwright, not Playwright MCP, but we're just programmatically controlling the browser with a class, okay? And then, when we have the session, we create tools, and this does exactly what you think. In code, we just return a bunch of tool definitions, just like this. It's just a bunch of JSON objects with descriptions and so on. We also create our context. You think this is complex. It's really not. It's just a message envelope with a system prompt and the user's prompt. And the user's prompt is the thing that we already wrote. It's this thing here. So it's just an array with 2 objects, okay? And then we finally run the agent loop. Now, what is the agent loop? Well, it's while true, keep doing stuff, keep pushing messages until you reach the stop condition. So this is the LLM saying, I've finished. And in that case, we return the answer to the user. But throughout our entire agent loop, we're just pushing different events. I called this tool. I sent this message. I got this prompt. We're just pushing these into a list. That's all we're doing. If we call tools, then we push each tool's result into our messages collection. Does this make sense? We just keep track of every message, okay? So that's it. And as our agent exists today, it doesn't work. It hits the login screen and crashes. So what we need to do is build a harness. We need to build guardrails first. Then we need to actually make it tell the truth. Hey, I crashed at the login screen instead of I've successfully done this. And then we need to actually fix it. That's the journey we're going on, okay? So step 1, we add some guardrails, because right now it can execute infinitely and bankrupt me. So how are we going to do that? Well, let's investigate this git diff. So we right now just call run loop, and we pass a model and messages, but we're going to change this to include some guardrails. We'll call them default guardrails. In fact, what are our default guardrails? Well, let's go to the editor and check it out. So we have this file, guardrails.ts. And these are our guardrails. We have 2, max iterations, how many times can you try, and max messages, how many messages until we compact your context. And then we have a little helper to combine them, okay? But how do we actually use this? Well, if we go to our agent loop, you can see that we include the guardrail here, and we call the guardrail, and if it's not okay, we just end. We say, this is why we stopped. And we trim context here on every message. So while true, at each iteration, we call trim context. What does trim context do? This is actually really bad. Don't do this in practice. But what we're doing is we keep the system prompt and the user prompt and the most recent 2 messages after that. There's more intelligent ways to do this. That's not the purpose of this talk. The purpose of this talk is to show you a guardrail as we build a harness. So now we have our agent, and we have a few guardrails. You know what that's called? It's called a harness. So what we're going to do is we're going to just rename things to keep them a bit more truthy. So what I'll do is I'll go over here, and I'll say, look, we just have index, but we're going to delete all our code and just abstract it under a function called run harness. And we're going to take all the stuff in red, and we're going to move it into a new file called harness.ts, okay? And what is harness.ts? Well, let's open it. Harness.ts is everything. You may recognize this code from the beginning. It's everything from our index.ts. We just put it inside a function called harness.ts. Does this make sense? So we just take it and we call it run harness. And print harness result just console logs things. It's just for logging. This is not really that useful. So we've just moved code at this point. But now that we have run harness, our next step is to, okay, now that we have a harness and we have a browser session that is not controlled by the agent but by the harness, we can hook into this browser session when we need to detect, did you succeed or did you fail, okay? That's what we're going to do now. So now that we have this harness file, we'll come over here, and this is what we're going to change. So we are just changing our run harness function call a little bit to add a 3rd argument, which is some options, a verify step and max attempts, okay? Verify successful upvote. If we go to our harness, this is getting a little bit interesting. Now, these are just types, but here, we have max attempts. We say you run the harness no more than 3 times. And so for each attempt, we do a little bit of a verification step. If it failed, or if it reached max attempts, we just return the latest result. But we have this function in our harness now called verify successful upvote. What does it do? Remember in our agent loop, we keep pushing events to a big list, right? So what our harness does is it checks the list. If you have a browser click, and if you clicked on an element with up something something, then it means you clicked on the up arrow. That's what our harness is validating. So if that's true, then return true. I upvote, click confirmed. But if you see a tool named harness auto login, and the result is harness failed to handle login, then we say, no, no, you failed the login, and we return a false result. Does this make sense so far? It's just code, okay? Finally, we also have this variable called unrecovered login redirect, which we check all the tool calls. Okay, I went to the browser here, and this was the result. We check all the tool calls, and if we see a tool where the name is not harness auto login, but if we're on the login URL, what does that mean? That means we went to the login page, but the auto login didn't work. Then we fail, and we say, return past false, login screen instead of completing the upvote. Finally, we need a success case also, but that's coming. So we just added a few, like if this, then say we failed, okay, to our harness. This is our harness, this is not our agent loop. So now let's run that and see what happens. So I will run this here. And so now it's opening the browser. We're going to Hacker News, and we go to the login page. It crashes, but what's the output? We get it to actually tell the truth. We hit the login screen instead of completing the upvote, and it says fail. This is what should have happened. Now, let's a quick checkpoint. We did not change the prompt. We did not prompt it harder, and we're still using an old model. Okay, but the harness is now giving us some truth. Let's fix this. We're about to finish. Let's fix this with, actually, now that we know that it's getting stuck at login, we can fix this at the harness level. Okay, so let's do that, and then we'll wrap up. So what's the final form? We add a file. We call it login handler. And what does this function actually do? It's just a function, but here's what it does. This is the line that's important. If we're not on the login page, don't do anything. So this function is a no-op, unless we're on the login page. If we are on the login page, we fill a username and password into the input because the browser session is owned by the harness. It's not owned by the agent. Does this make sense? So it's not tool calls driving the browser. It's my harness that I wrote, okay? So I inject this username and password, and then I return a message. The tool name is harness auto login, and the result is the harness automatically logged in, and this is basically to the agent, you are now authenticated and back at home. So my harness injects this into the chain of messages. Does this make sense? So I'm logging in now at the harness layer. Okay, but this is just a function. Where do I use it? I use it actually in the harness. So I create the login handler, and in create tools, I just add a few guardrails here, but I'm taking the login handler and giving it to my agent loop, run loop. And in the agent loop, this is where we land the plane. I send the login handler, and this is the code that makes it work. So inside the agent loop, I say, if I have a login handler, then I just await its response. Because again, if I'm not on the login page, this is going to return nothing. If I am on the login page, and if I receive a login event, then inside my agent loop, I push it to the list of messages. Does this make sense? And so if the harness successfully logs in, it adds a message. I've logged in, and the agent reads this and then continues. Does that make sense? This is the whole point of a harness. So let's run this, and then we'll wrap up. So we should now be running the latest version, and so what I'll do is npm run agent, and it should work by the harness. So we log in to Hacker News. It typed the username and password, and indeed, you can see that it did, well, that was way too fast. It successfully upvoted this, upvote click confirmed, by logging in with the harness very rapidly. Does this make sense? We did not prompt it harder, and we used GPT 3.5 Turbo, but we got more control with the harness. Let's wrap up here. What does this mean? This means you can do a lot more with a lot less with a harness. And again, the harness is the environment around your agent that increases its chance for success and reliability. What does this look like in practice? I work at IBM, and we work on harnesses daily. At IBM, we create an enterprise-ready open source RAG harness. Because as you may know, enterprise data is big and it's everywhere. There's all these Teams calls and like notes, and you don't know what's confidential and what's not, and it's very risky. And so we create an open source enterprise harness for large companies. It's called OpenRAG, and again, it's open source. That's the important part. And if you're interested in it, you're more than welcome to scan that. I'm not here to sell that. I just think it's a nice reference implementation for a harness. But let's land the plane and cast some vision, okay? In summary, what did we do? Look, I started this talk asking you, how many of you feel confident that you'll be able to explain what a harness is and why it exists and so on? Has that number changed at all after this talk? Yes? Oh, that's a lot. That's like almost the entire room. Okay, I've done my job. That's what harnesses are. That's how you build them. And that's how you do more with less. You don't change your prompt. You don't change your model. What might the future look like? Well, we just hard-coded a harness. We wrote that ourselves. But I would be foolish to think, oh, wait, but wouldn't it be amazing if harnesses were dynamic? And if agents could create their own harnesses and then do work? I think the dynamic harnesses are likely the next step towards AGI, where this can all be managed by an agent. But with that, I want to land the plane here. I've already maybe taken a little bit more time than I deserve, but I want to stop here and just say thank you so much for your time and attention, Singapore.
Thank you so much, Tejas. And thank you all. I see the room's filled up. We're going to have our first break. The next talk starts at 10:17. Just a reminder that booths are open as well at the expo in case you'd like to walk around and stretch your legs. Thanks, everyone. See you back here in a bit. up next, we have Geewax joining us from Google, where he's Director of Applied AI based right here in Singapore. And he's going to be talking to us about bringing models into production.
Is this going to show up here? No? Yeah, there you go. OK. Cool. Hi, I'm JJ. I'm a engineering director at DeepMind. And so I lead the applied AI team there. I'm based here in Singapore. I am hiring, so if people are curious about working there, definitely reach out. So I'm going to talk a little bit today about moving from hackathon kind of things to production, which is sort of what my team does, and dealing with models at scale. So before we get into that, I kind of wanted to share a little bit about what my team does, and I see at least one of them here. Hopefully the others are as well. So what we try to do is we push the technical boundaries of the DeepMind models. This means the ones that I think most of us are familiar with, Gemini and Gemma, which is our open weight text model. But it also includes the Nano Banana and Veo video and image models, as well as the more science-y things. So that's the Alpha Genome and WeatherNext. WeatherNext predicts weather and hurricanes and large-scale storms and things like that. So our job is to try to make the models do what they weren't necessarily designed to do or blow past the limits that we might have set on them. So a good example with Veo is it generates 8 seconds worth of video, right? So you give it a prompt, and you get 8 seconds of video out. What happens if you want it to generate like a whole scene from a movie, like 5 minutes worth? How do you do that? Our team tries to do those sorts of things. Or with Nano Banana, let's say that you have a movie and you want to outpaint the whole thing. To make it like widescreen, for example. That's kind of an example of what we might do. These things sound kind of easy because they're just more of the same, but it's actually a much more challenging problem, and we have to come up with clever ways of getting around it. So what we ultimately try to do here is make the models do real things. So it's nice to have 8 seconds of video, but that's kind of a fun hackathon project. It's not really a real thing. You can't sell that to a movie studio. I can't be like, look, here's your 8 seconds of movie. You need to kind of do more than that. It's also making the models sort of adhere to what your guidelines might be. Describing a movie in text is actually really challenging to get it right, and then you end up with this giant prompt, and it's very fragile, and it breaks. Figuring out how to anchor it off of keyframes and understand animation and behave the way an animator or a director wants it to is actually a really surprisingly challenging problem. So we try to do all of that. Now, I want to pause for a second because I was just saying how like, oh, the models aren't good enough. They only generate 8 seconds of video. I kind of want to pause and just, I need to say this. AI stuff is amazing. Like, it is completely crazy. I don't know if you guys remember, but like a few years ago, like ChatGPT didn't exist, and our lives were totally different. And there seems to be this world of like the models are incredible, and they're still at the same time like not enough. They don't do real things, my whole job. But like there's always been this moving goalpost thing, like with chess, right? I don't know if you guys remember when like the whole Deep Blue thing happened. I was a kid, so I wasn't really paying attention. But we like computers beat somebody at chess, and then everyone was like, oh, that's amazing. Also, oh, it's just chess. And then Go was 10 years ago. Demis just went to Korea to celebrate 10 years of like solving Go. And everyone was like, oh, that'll never happen. I remember I was working at Google at the time, and everyone was like, is this going to work? Like, is it going to win? I don't know. And then it did most of the way, and now everyone's like, oh, it's just Go. Like, ugh. And then ChatGPT came around, and it was incredible. I remember showing my wife that she could just ask for things, and it would answer her and like turn it into a table and all kinds of crazy stuff, like incredible. And now we're like, oh, ChatGPT, old news. It's just a chatbot. And now we're at this sort of weird phase now where like we have agents and they do stuff. Like they call and make restaurant reservations using like 11 labs and OpenClaw, and they're accidentally deleting all our emails and crazy things like this. And it's like we're still mad that the agent doesn't follow our instructions, right? Like just how spoiled we've gotten. Does anyone remember when we got Wi-Fi on airplanes? Like, and that was incredible. And now it's like, oh, it doesn't have Wi-Fi. Like, ugh. And now there's robots, and robots are like doing factory jobs, and we're like, oh, but it won't even do my laundry. And it's just, and I actually saw a video of a robot making a bed and taking out the trash, and so maybe soon this bullet point will go away. But so I need to say, like, my job is to make models do real things, but like let's be honest with ourselves. The models are incredible, like shockingly incredible. So I would argue that this idea of moving goalposts has been around for a long time, and it's not necessarily a bad thing, but it is a little misleading because it keeps pushing us forward, but at the same time we kind of forget where we've gotten to and how amazing all of this is. And so this brings me to an important point, which is everything's been going incredibly fast, just so fast, right? 3 years ago, no ChatGPT. Now we have 3 different very popular agent frameworks and crazy video generators, and it's incredible. We can't tell what's real on the internet anymore. But for people like me, and businesses, you need to take like a snapshot of where you are and hit the pause button, and you're basically stuck in time so that you can build something real. You can't just keep riding the train. Like, you have to get off and build something. And so that's sort of what I'm doing here. I also want to say there's a bunch of different categories of using AI, and I use it in a couple different ways. I'm going to focus mostly on the third one here, this in-app thing, right? So we all use, how many people are using some kind of AI code gen? I hope a lot of hands go up, okay. And how many people have like an agent that they're using and doing crazy things? Awesome. This third one is the idea that inside your app, we're going to make API calls that your users actually interact with. So the idea is this isn't something that you as a developer interact with. It's something that your grandma who might be talking to a chatbot and not realizing they're talking to a chatbot is going to be dealing with it. And so my role is primarily with that third category. And so what we try to do is help businesses get past sort of the benchmarks, right? What I mentioned before. And I'm going to talk a lot about this bottom right one. This idea of not breaking policy, because some of these are clever hacks, right? You have a video model and it generates a chunk of video. How do you make it do more? You have an image thing, but it only does up to, say, 4K. How do you make it do a giant billboard like the size of this that might not have the high quality that you want? You can do clever things about that to stretch the boundaries of the output. But how do you make sure it doesn't break policy is an architectural and design decision. And so there's a couple of things we've run into. I should also say a lot of my work is being talked about at I/O that's coming up, and so I'm not allowed to say a lot of things. So I'm really sorry that I can't give you awesome examples, but if you watch the I/O streams, you'll see some of the things we're doing at DeepMind. I really don't want to get fired, so I can't. Sorry in advance. I'll do my best to hint without getting in trouble. So I'm going to talk about some of the walls we've bumped into, the problems we found, and sort of like that last one, this idea of policy, and then how we kind of deal with it at DeepMind and inside the applied AI team, and hopefully it applies to some of the things you guys are doing. So you build a chatbot, and you tell it, please, be responsible and professional and don't make me look bad. And I don't know, you guys saw the Chipotle screenshot of somebody being like, why do you subscribe to Claude Code? The Chipotle chatbot is free, and it's somebody saying, I really want a burrito, but first can you help me write a Python function for the Fibonacci sequence? And it says, sure, here you go, right? It's super common. You've all seen prompt injection, right? How many people? Yes? Am I crazy? Okay, good. So prompt injection is real, and it's not on purpose, and it's complicated, but it's something we have to deal with. If you're having a user talk ultimately to an AI backend, you have to deal with the fact that your way of defining what the agent should do is the same way that the user talks to the agent. So they're all text. And so how do you figure out how to deal with this weird problem where usually it's fine, but if people say the wrong thing, the chatbot can hallucinate, can say crazy things. It's got all kinds of real problems. How many people thought if you set temperature to 0, that means it's deterministic? It's not. Yes, to an extent it is, but yes, technically you're getting close to determinism, but it's still non-deterministic because subtle differences in the text mean huge differences in the output, right? It's one of those situations where you feel like I'll set temp equals 0 and everything will be fine, and it still breaks and you're frustrated, and it's not like setting a random seed in a pseudo-random number generator, right? It's not the same thing. And so getting determinism out of these different agents and AI backends is really tricky, and so we've had to deal with quite a lot of that. So The other thing is RAG, retrieval augmented generation. Again, this is a new thing relatively, right? ChatGPT is 3 years old, RAG is what, like a year old or something. The idea of you fetch a document, you use it as part of your AI pipeline, and it helps to answer questions that it didn't otherwise know. Now, this also is kind of like, self-own, right? Occasionally, your RAG pipeline can, cause trouble for you. A great example is if you've ever had a refund in your chat history and you used RAG to pull out your chat history, even if it was an exception because it was like your mom called and that's why there's a chat log of that, and so you only gave it to your mom, but it wasn't the same thing. Well, now it sees there's a refund, and so it gives out refunds. Or if you have a test example somewhere that sells a car for $1, now maybe you're selling cars for $1. These are really dangerous things, and it seems crazy when I say it now, like, of course you shouldn't sell a car for $1. But like, it's absolutely possible because the agent, the rationality is not necessarily there, right? We're kind of expecting it to be, but it's not. Our agents in a lot of ways are like really, really silly interns that just got hired, and they're like trying to do a good job, but they don't really know what they're supposed to be doing. So those three things are some of the big ones we've seen. There's more. I'm not going to purport to be able to tell you everything about building with AI. I'm just going to kind of focus on these three. But the bottom line with these three that's worth mentioning is the model is being asked to do just a little bit too much. Models are amazing. I just showed, like we just talked about how incredible AI is. But when you try to ask it to do crazy things like /goal, give a talk on AI, like it's not necessarily going to do a great job at that. Like you have to guide it more because part of it is the model is not as amazing as we'd hope because our expectations keep going up. But also it's because alignment is hard. Taking what's in my brain and what I want and turning it into words or code or images or video is not a straightforward problem. It's actually really challenging to figure out how to get what we want out of AI because sometimes we don't know that it's not what we want until we see that it gave me something that I didn't want. And this keeps happening all the time, and when you're dealing with customers, it happens at scale. So this also is an interesting point here, like the big underlying problem is with a hackathon, everything works. It's just fine, right? But when you get to production, it doesn't. Things, the edge cases are all over the place. So what we try to do is stop using the language model as one big single router. The whole idea is when you try and throw everything in a system prompt, it doesn't work. But that doesn't mean it can't solve each individual problem if you break it down. We just saw a couple of talks earlier today where they enter plan mode, they make a to-do list, they guide the to-do list by telling it, hey, look, if you try to call finish without having completed the to-do list, it throws an error, an actual error. These are the types of things we see. And so I'm not sure if what I'm saying is entirely new to this group, but I want to echo it because it is important. So what we try to do is surround things with determinism. Figure out how to make things actually work by breaking down a big non-deterministic block into smaller pieces. So what you can do is think of each route as individual pieces, but this transform block sort of in the middle, do I have a pointer? I wonder if this works. Yeah, kind of, you can see it. This sort of layer of the transform block is where you start using AI. Everything else is AI, but in a much smaller layer, right? You're taking random input and turning it into JSON, a structure that you know and understand. Pydantic AI is amazing for this. There's agent frameworks out there that are quite good as well. ADK, Agno, there's a lot that are all fantastic. Routing can be an LLM as well, right? Deciding what kind of action you're supposed to take. That is a decision that can be made by a language model call. But again, that's just a route. It's deciding, given this input, does the customer want a refund? Are they trying to say I did a great job? Or are they trying to cancel their service? Like whatever it might be, the routing can be decided there, and then you coerce it into something that makes sense. Then transforming, you stick to JSON, right? If you decide that you're trying to do a task, you might say, okay, I want to take something that is structured and I understand it and transform it into something else that's structured and I understand it. And then lastly, you can generate output text that, again, is what language models are great at. And it spits out something that's human, not just JSON back to your grandma, right? It's something you can see. And then lastly, we can do safety checks. I think, I know Cloudflare does this and a bunch of others as well. You can use smaller, more targeted models to just check whether something is safe or not to send back. So the language model picks a route and decides, instead of doing the let me plan, you give it a multiple choice question, right? That's the whole idea. The language model is effectively acting like a classifier at that point. It's deciding what is the user trying to do based on the conversation so far, and shoving it into, this is what I need to figure out in order to do that. So instead of letting plan mode and reasoning do it, which are amazing, but at production, I don't think they're really ready. You use it, you can coerce this into a multiple choice question. So like I mentioned before, right, this is take data, turn it into something we can work with deterministically, transform it, again, from one deterministic input to another deterministic output, and then generate the actual response, whether that's audio, video, image, or text, using that structured deterministic transformed output. And then lastly, this idea of safety, I just want to harp on it a little bit, because no customer is going to be happy if your response says something offensive. But running a language model through it still has the same prompt injection problems. So you have a couple options. You can use a context-free language model call. Here's what I'm about to send to the user. Is this okay? I am a car insurance company. Insert whatever here. That's pretty good at that. And there's no prompt injection option for that. And then lastly is a ML classifier. You can use a smaller, more targeted model to decide what to do. What's interesting is this same pattern actually applies to images and video. So one of the things that I'm not going to talk about today is a project we were working on that deals with live image feed from your camera and figures out how to classify it and understand it and provide feedback and things like that. It's not really text, right? It's video input and then audio output, for example, like an agent. We're using two different models to do that, right? There's some that are on the actual phone that are sort of dumb models, but they're really fast. They can handle 50 frames a second. They can respond within 50 milliseconds. They can tell you, look, given this image, here's sort of the depth perception, and this is a stool in front of you, or there's an obstacle in front of you, compared to Gemini, which is great, and it can tell you exactly what's going on from an image, but it takes a while. You have network latency. Right? It actually takes time to get, time to first token is certainly longer than 50 milliseconds. And so there's a difference between these two, and so you have to use them in conjunction with one another. It's not as simple as just sort of, I'll throw everything at the model, because the models just aren't there yet. No matter how amazing they are, they're just not there yet. And so what we have to do is piece things together using different tools for what's good for different jobs. And in this case, we need super high latency, right? And we can decompose the problem ourselves instead of having the AI just magically do it for us. So we split into sort of keyframes and recognition using a smart, big, gigantic, but potentially a little bit slower model. And then using something that's not as smart, but it does have low latency and it does handle tons of frames per second. We don't have to choose a keyframe. We just send the whole stream in, right? Problem solved. And so by doing this, you can get the best of both worlds, your semantic understanding, as well as your real-time sort of safety and obstacle detection, for example. So just wanted to finish this out, right? LLMs are great for a lot of things. They're like incredible, like truly, truly incredible. But we have to use things for what they're good at. So I want to use language models for all the hard stuff, right? I want to use determinism for the stuff that really matters, that I can't compromise on, that non-deterministic output would be a disaster. I like to joke, we can't just tell our customers, don't worry, I added don't break any laws to the prompt. Like, that's not an acceptable answer. Like, that just doesn't work. It's great, and I wish it would. But if it did, my whole team, we wouldn't exist, and we'd all be fired, and that'd be the end of that. So I'm kind of glad a little bit that it does. But it's also useful to, if you take this strategy and tell Claude or Gemini Coder or GPT Codex, like just say, go build this using these ideas, it'll do it, right? So we can still use AI for crazy things at the development stage, but in real life, I think we need to use the models for a little more of what they're actually good at in different places. Now, I didn't talk about a whole lot of things. There's a lot more that we think about and we work with. So I didn't mention fine-tuning at all, right? How many people have done fine-tuning before? I always want to poll the audience for this. Okay, not a lot. You should try it. It's great. But we don't do it all the time. We do it when it makes sense. And that's one of the examples of a smaller, more targeted model of doing like safety classification or stylistic approaches of how you want to structure your output. Fine-tuning's amazing, right? It's just you have to use it in the right places. You wouldn't just try to fine-tune some gigantic model for everything if you have bad data and you don't know what you're targeting for. The other thing is evals. Did anybody used to do TDD? Like where you, yeah? I sometimes tell my model to do TDD, but evals are effectively, if you do them first, you're kind of doing like AI evals for TDD. it works, right? But it's sometimes hard to do. You need golden data sets, you need things like that. So I just want to leave you with, there's a lot more to do, but those three things are the ones that we bump into all the time, and there are ways to get around it by using models in the ways that they're meant to for the things that they're good at. So I mentioned before, like, AI models are incredible, but you have to get off the train at some point. You can't just keep riding it forever if you want to build stuff. So I think the key takeaway here is you can't wait for the perfect model. I don't think it'll be here anytime soon. We have quite a long way to go. They're good enough now. You can build some amazing stuff. Just try to make things deterministic as much as possible. So yeah, that's all. Thanks.
All right, thank you so much, JJ. All right, next up, we have someone to specially welcome to the stage, Geoff Huntley. This is actually his second time speaking in Singapore. He came last year as well. We were completely blown away by what he was sharing and decided to have him come back. For those who were there at the party that was here last night, he actually came on for a couple of sets and DJ'd as well. So who is Geoff Huntley? He is an independent AI researcher known for doing unhinged things with AI. So he's actually the person behind the Rolf loop, which is now incorporated in many, many tools that are used today. And so he's going to be giving a talk about how everything is a factory.
Hello, everyone. I'm here today, as I must say, as confident as I might say and seem about these topics. This is quite a provocative title. I don't know. So when you're listening to this, I want you to reflect upon this. Maybe I'm right, maybe I'm wrong. So it's a provocative title because everything is, I'm saying that software development now costs less than minimum wage. Like, there was a time if you wanted to do photography, you had to buy specialized tools, etc., to do photography. But now everyone's kind of got an iPhone and everyone's now a photographer. Think about that. Things have changed. With that disclaimer said, I do not work for anyone. I am completely independent. I do not represent anyone. So this is going to get spicy. Let's do it animal style. Okay, so it's been roughly about a year and a half now since I published the technique of allocating memory in a particular way, and if you wrap the tool calls around another loop, it's just a loop, but there's a lot of science into the context engineering to actually achieve these outcomes. And it's quite disruptive. And here I was over at Atlassian giving this talk, talking about how everything has changed. And this was a week before Atlassian did their layoffs. Oops. And see, the unit economics of business have forever changed. I want you to really understand how much this is. If you do not believe this is true, you need to stop speaking with other developers. You need to speak with founders. You need to speak with business leaders. You need to actually get a little bit more curious on here, how and what this means. You see, what does it mean when everyone is a software developer? Like here, for no particular reason at all, there's like, at the same meetup was Cursor. I'm not maxing Cursor in any way, but I want to call something out here. At this meetup, here's Roslyn. And there was other people like Roslyn. They're designers, they're product managers, and they're having the time of their damn lives. There wasn't any software engineers up there giving really talks. You see, because they're being enabled to be a software developer now. For the first time ever, it's like an iPhone in their hands. They can just get stuff done. They can take photos, they can develop software. Whatever is in their wildest dreams, they can do. So I've been traveling for the last 3 months around the world. I think I've given this talk 17 times now in different cities. And one of the cities I dropped into was Auckland. And in Auckland, I decided to do a side quest to Lord of the Rings, Hobbiton. And my tour guide operator was like, Geoff, what do you do? And I'm like, oh, I do AI. Please don't judge me. And next thing you know, his eyes light up. And he goes, Geoff, like, how good is AI? How good is AI? What does it mean when your tour guide operator is token maxing? You see, everyone is now a software developer because AI has enabled everyone to be a software developer. And society has been designed around a scarcity of knowledge. You used to charge a lot of money because knowledge was scarce. And this is how we've structured our societies. This has changed, folks, because we're now going to a knowledge abundance economy. What does it mean if you want to be a principal software engineer? You probably know things about deterministic system testing and property-based testing and test generators and all these advanced things and formal methods and proofs. What does it mean when that is just like wrapped up into a skill file? And it's not just about software engineering, it's about accounting, it's about law, it's about all white collar, where essentially it was based around the idea of a scarcity of knowledge. This is a transformative effect to society. So if we rewind time to about 2 years ago, this is me, like November 2024, I first said, oh fuck. I published a blog post to say everything's got to change. I'll dig into this a little bit more further. And I was saying the IDE was dead. And people are calling me crazy for saying the IDE was dead. But, you know, I mean, not many people here, at least in this room in Singapore, are using the IDE day to day. They do some form of headless agents or async. You're probably cooking on something on your phone right now. So the models back then were already good enough to cause societal disruption. But it required a lot of skill to get the outcomes from them. A lot of skill. They're like wild horses or wild stallions. You had to like tame them before they got good. And you probably recognize this moment in time. And this was the second oh fuck. This is when the models actually got good and required no skill to really tame as a harness engineer to get good outcomes to it. There's something interesting about here. No matter how good AI gets, it is in lockstep to the downtime that society has to be able to understand that things have got better. So it doesn't matter if the models keep getting better and better and better. The reason there was like a oh crap moment in December, it was like people had time off, they had Slack, they had play, they had the ability to play with this stuff and understand it actually had got better. So you're going to see product releases of like the system shock in society, is my hypo, it's going to be in lockstep with downtime in society. School holiday periods, Christmas breaks, all the rest, holidays. You see, because the people around me who have been getting really good in AI in the last 2.5 years, they've been treating AI not as a calculator. They've been treating it as a musical instrument. See, musos don't just like use a guitar and go, oh, it's crap, and they throw it away and think it's good. They recognize it's a skill issue. They recognize it's skills, bro. So it's really important to actually just do things and be curious and learn and deliberate intentional practice. This has been the key for me, is it's like, no way this can work. No, it's not real, it's not real. Let's do some things. Let's do some unhinged things. Let's make some discoveries. And it's through that deliberate intentional practice you get good. And it's kind of weird right now because society is like, all corporates are pushing these guitars down on the world. And it's like, please play the guitar. But not everyone's going to be musically inclined. You see, I think there's now essentially 2 classes of companies now. Like, you've got your brand new startups that are coming out right now who hell yeah, I'm going to do AI native workflows and I'm going to have the time of my life and I'm not going to hire a lot of people. And they're leaning into workflows and really changing things around. They're not thinking that they can get on AI by selecting a particular model. They're experimenting and they're trying, and they design their code bases and their processes around being able to exploit the heck out of this new substrate. Meanwhile, you've got every single company out there today, which is, I've given this talk and there's people saying, oh, AI is just a tool. AI is banned at my company. And I'm like, oh God, you should quit that company. Everyone in the bottom half there is going to go through what's called a J-curve. All people transformation has to go through a J-curve, like people transition, etc. This will take 3 or 4 years to do. You can't do it too fast because you'll break people. Meanwhile, people up the top there are going to be, if you believe in the notion of disruptive innovation, Clayton Christensen, they're going to be lean apex predators just going, hell yeah, your margin is my opportunity, and as the models get good, then they can actually execute faster with less. So you've probably seen this. Block lays off half its staff, etc. I want you to think about this for a little bit. I think Jack is actually right with this statement, but I don't think AI is actually priced into software stocks right now. Right? Previously, when we were pricing software stocks, it was based on a multiple, on a growth multiple. We're seeing that disappear now. But I actually do think a lot of companies are going to need to rethink about their organizational structure. I want you to think about Spotify. Who here has done Agile and has been forced to watch the Spotify Agile video on how Spotify does Agile? And they got the guilds and the tribes and the squads and all that stuff. Took 2 videos and everyone just started cargo culting this crap everywhere. It's going to take one mad lad or a couple of different mad lads. So we've got Toby and Jack having some fun right now, and they're experimenting to find out what the right thing is, and they will publish a case study. And when that case study is done, it's going to be copied by everyone. So for the last couple of months, I've been traveling around, and I've been posing the following question. I've been speaking with venture capitalists. And the question that's on top of everyone's mind is, why does someone need to raise seed capital now? Like, typically you'd raise money because you want to hire people to build it. Nah, bro, just build it. Like, it's fundamentally different. Like, why do you need to raise capital if it's going to be this 5-man show? Like, if someone cracks the AI operating system that we've been talking about the last couple of days and people experimenting in, this is going to be the year we figure out whether it's true or not. Like, what's the point of investment? Come see me. I got some nuances to this, but the expedience of time, I can't get into the particulars here. Software is still investable, but it's very different now. And this is the question on every LP's mind, and they're putting pressures on the GPs at VC firms. Is it still investable? So no particular reason at all. I'm going to pick one enterprise company, SAP. They have 6,800 people, according to LinkedIn, doing expense management software. That's a lot of people. This is representative of like a J-curve, people transformation program, of like getting to use AI, etc. How much time do they have compared to the lean Apex, like 50-person leveraging AI, and they got 6,800 people, and they're like, please pick up the guitar, please pick up the guitar, please get good at this stuff. They were built with this organization chart. Every company was built with this organization chart. And we basically just hired people, and we had meetings and committees and all these things, and the builders were very far and few between. I want you to think very carefully. How long does it take to transform those 6,800 people, and how much time do the incumbents have if this is cracked, the idea of an AI operating system, and enable these lean apex predators to get into business? More importantly, why would you transform them all? This is the quiet thing that's been discussed. If you don't believe me, go speak with leadership. We all know smaller teams get better outcomes. Smaller teams, better outcomes, less coordination, less overhead. Here's a quote from a founder in New Zealand. They've stopped backfilling. Companies around the world right now, they're not necessarily doing layoffs, they just stopped backfilling. We're smaller, but we effectively cut 2/3 by telling our board that we would not backfill. Notice the date? That's 3 years ago, folks. Like, there are people who have been early. If you're thinking about these types of topics and leadership, I'm not advocating that you should do these things, but like, there are people ahead. It was the best decision because we got rid of all the people who were detracting, and it was sick of hearing about AI. Just sick of hearing about AI. We're 20 people now, down from 60, and we're getting more velocity than ever before. And this is going to be really hard because AI is pushed down onto the world by a lot of by Silicon Valley. It's non-consensually onto society. And I want you to think about this. There are a lot of people here who have built their identity as like a leader of people or a manager of people and all the rest. And AI erases all this stuff. Like, if this problem statement gets cracked, then this is what we're literally looking at. We're looking at people with high agency and curiosity just building things. We don't know yet. I'm not advocating we do 52 pickup and throw a deck of cards in the air and do this, but this is what's on people's minds right now. This is where we are. And this concerns me deeply because software engineers trade time and skill for money, right? If a company's having issues with AI, that's a company issue, not your own. If you work for a company that's banned AI, you need to get out of that company. Honestly, straight now. Put your family unit first. You see, because this was me back in 2024. I was Grape. I was the tech lead of AI over at Canva, and I was like, AI is not good enough. Prove it to me it's not hype. And I start playing with it, and I'm like, fuck, everything's changed. So I saw no point other than just to completely lean into it. And then you now have, in 2026, 2 years on, you've got two personas. Those who are consuming AI, whichever way, and you've got people who actually understand how AI works under the hood. I want you to look very carefully. There's now a line there. I don't hire anyone left of the line anymore. If you're figuring out who you should interview and how you're going to do your interviews, it's really simple, folks. You don't hire on the left of the line anymore. It's a curiosity test, and way too many engineers are failing, and it's so sad. You see, if I was to ask you what a primary key is, or to traverse the graph, you're like, come on, dude. Like, you're shit testing me? But why is it in 2026, people can't actually explain what this is? I pull out a whiteboard, they couldn't explain what a tool call is. They couldn't actually show me a sequence diagram with inferencing. They can't get really deep. They can't talk about the differences in the model cards between the different vendors. What is a temperature? Why can't they answer this stuff? So if you're trying to figure out who to hire, it's quite literally people who have been curious. You should be testing for this. Sweet. Because it's really sad, because LLMs and AI is just literally a while true loop, and Ralph is a while true loop on a while true loop. Wow, scary. The big boogeyman that's going to cause everything to go over. So it's going to be really interesting to see how this all pays out, folks. See, for a lot of people, they haven't realized that AI, they're expecting to knock on their doorstep and to be pronounced. But really what's happening, it's kind of burrowing under society, under the houses. Now, closing ponderoos, really quickly, because I'm over time. Removing waste from your organization and processes better than AI itself, accelerated than AI itself. If you're trying to figure out how you hire an engineering manager, the question is simple. What have you changed in your systems and processes because AI has broken it, right? Are you doing agile anymore, not agile anymore? Well, how have you changed things? This is what you look for. You look for an engineering manager who has been thinking in this problem space, an engineer who can build an agent, and an engineering manager who's changed things around in the organization structure to achieve these things. Ideas are now execution. I mean, like, you literally can just take a screenshot of a SAS feature, rip a fart into your coding agent, and you get that SAS feature. Like, the old idea that ideas are nothing, execution is everything has been inverted. It's going to be really hard for people. This is actually a psychological distress function, people going through the 5 stages of grieving. But the question on everyone's mind is, how long do we give people to get through this motions of crisis, and what can we do? If you're a software engineer and you haven't built your own agent, on my GitHub there's a free workshop. It's 300 lines of code, build your own cursor, Copilot, Codex, and like learn the fundamentals. Be a curious person who doesn't switch engines in a car. Be the curious person who rebuilds an engine and knows what a piston is, what a carburetor is. Get into the details. You're not a senior engineer unless you know these details. Thank you.
All right, thank you so much, Geoff. All right, a quick announcement before I introduce the next speaker. The expo in Pullman as well as Kempinski has been open since 10 a.m. There you can find different things to look at, like a robot playground as well as a robot display from Nabius in both places. And you'll also be able to talk with some folks that you heard from this morning, like Arize, Google DeepMind, as well as Cloudflare. All right, to kick off this next section, I'm sure many of you have built things like personal agents, heard of OpenClaw. So I'm really excited that this is the first speaker who's going to be opening up this section. This is Vincent, and he is a chief architect at the OpenClaw Foundation, and he is going to be talking about the state of OpenClaw.
Amazing. Thank you, everyone. Welcome, Singapore. Lovely to be here. I've presented many times in Singapore. Fun fact, I actually gave classes at NUS for a few months as well, so good stuff. So as Sherry said, I'm Vincent. currently Chief Architect at OpenClaw Foundation, information as of today. So the foundation is definitely alive. I'm going to talk about the post-Claw era. I'm also going to talk a little bit about what we shipped and what's coming next. A little bit about me. I call myself Vincent, the friendly clanker. So if you've ever seen me present or give a talk, I use this image to describe technology in like one image. This was VR goggles I received like many moons ago, before even anyone knew what VR was. It came with a warning saying, only used for 5 minutes. I used it for 4 hours, and then I vomited for 4 hours. Technology is fun on the edge. It's a little jagged, but you learn and things change. So a little bit like OpenClaw. What's been happening? So we've had over 1 million NPM downloads a week. We've surpassed 50,000 commits on main. 800 commits a day at its peak, 1,600 contributors, amazing support from the community. Over almost close to 80,000 forks of the project. We've also had 40 ClawCons. These are like specific like Claw festival-like events across 6 continents. But the thing I want to talk about is like what we've been building and how we've been building. So in AI London, I spoke a little bit about the dark factory. I think my talk is now on YouTube as well, so go check it out. But I want to talk about the dark side. So these are some of the features that we've shipped recently, but I want to highlight a few of them. So dreaming was something where we decided to really think about, what happens when agents dream. But a lot of these features sometimes you might feel like are aimed at memory or something really cool. But this one was actually aimed at users, and it's for users to really understand what is happening with their agents in a really easy to understand way. We also shipped first-party support for Codex harness, which I'm going to talk to in a little bit. But one of the things we're seeing in the industry is a shift towards models built specifically around their own harness, and how do we deploy the combination of the model and the harness together. So with the OpenAI specifically models, we've now switched that as a default option, which means that when you use OpenAI, it uses the Codex harness under the covers. And because of that, you get the best performance and some of the native tooling and capabilities that come with that model itself. And something I'm a little proud of, which was a little pet project named after Finding Nemo, having lived in Australia, was a clownfish. And clownfish was essentially running harnesses inside of GitHub Actions at scale. And with clownfish, which also another project called Claw Sweeper, we were able to go from 10,000 PRs down to like 3,000 PRs in the space of 2 days. So I talked about the dark side. So this is my commits. I think close to 3,000 commits back in March in one day. Commit maxing, it's great. You should try it. But those features I spoke about, that wall of features I showed you, was just what we shipped in the last 4 weeks with a group of volunteers and people in their spare time. So what's next? We've been shifting towards like a plugin architecture. The reason why we had a huge volume of PRs and issues beyond stability and bugs and fixes like that is that everyone wanted to make OpenClaw theirs. Everyone wanted to contribute. Everyone wanted to make it that little bit nicer for themselves. But that became quite challenging on a project this scale. So you could take something like OpenClaw, the core itself, you might have the gateway, you have the file system, but we needed some concept around adaptability for people and extendability. So we started building like a plugin sort of architecture. Essentially, code from the core started being refactored and was kind of broken out into these buckets of plugins. We created a hard boundary, which broke a lot of things for a lot of people, which we've had to learn. But that meant that previously the very hard-vibed OpenClaw that started off in a bedroom where all of the code was public, the internals became private, and it meant that plugin architecture allowed for a clean interface. So we could continue to work in the internals of OpenClaw without breaking the outside experience for developers and other people in the ecosystem. And I mentioned this also included things like, for example, taking the OpenAI provider, converting that into an extension, but also converting the harness into an extension as well, or a plugin, and combining those two together. So you can now actually build harnesses into OpenClaw and run harnesses in combination with the models themselves. The other thing that was missing that we really quickly realized at this scale was the tooling. And the tooling we were using, same as how OpenClaw was born when we realized, hey, you know, why is no one building a personal AI agent that can do stuff for me? We also realized, hey, why is no one building dev tooling that can work for me at this scale when I'm getting rate limited by everything? So we took something like OpenClaw and we decided to build around it. So one of the fun projects I've been also working on is git crawl, disk crawl. There's all these crawl-based apps, essentially, that are terminal-based CLIs written in Go. And this is now a library. And with that library, we're able to quickly ingest the entirety of all the issues and PRs that are related to OpenClaw, cluster them, and have them in a distributed SQLite file system that's also stored on GitHub, which means any maintainer on the project is able to get refresh data that's hourly correct on their local file system, and they don't have to connect to Git. The added beauty with this is this tool is now accessible to agents that are using automatic PR work, but also work that we're doing. So pretty quickly, I can kind of blow that up and see what this looks like. So this has a terminal GUI. On the left, these are clusters. In the middle is one of those clusters. You can see one of the items had like 92 issues and PRs linked to it that were all related. And the reason for this is like 9 times out of 10, most people that have a burning problem are all going to have the same burning problem, and their agents are all going to send us the same PRs and issues. The beauty with this is we can feed this to agents at rapid succession to help try and close these out and resolve them. Or we can see an old issue, an old regression that crops back up because a new issue comes back into that cluster again. And again, this all runs locally and is distributed across GitHub for any of the maintainers. Some of the other tooling also that we touched on is something called CrabBox, which was born out of a lot of these sort of dev tooling that you see for like running ephemeral, like Daytona, E2B type boxes. But we needed something to run quickly. Every time we were running tests inside of our codex when we're making changes, tests were taking up to 15 minutes, killing the RAM on my machine. With CrabBox, essentially, we built a distributed gateway that runs on top of Cloudflare and any hosting provider such as AWS, Google Cloud, and allows us to quickly use spot instances across Windows, Mac, Linux with VNC and SSH support. So what happens is my codex session, when I'm coding locally, will spin up 10, 15, 20 of these boxes and start testing in great succession. If there's an issue, I can jump into that machine. I can get screenshots. I can even control it remotely myself. This meant that really quickly, I no longer had to run any of the hard compute that was required on my laptop, and I can continue to scale the number of agents I'm able to run quite quickly. We also included things like Clownfish and Claw Sweeper, which I mentioned. We started to refactor the core and build something called FS-Safe, which is a TypeScript file system, secure file system. If you've ever had to deal with symlinks and Windows and all this stuff, we pretty quickly realized the library didn't exist for this. So instead of creating even more core code inside of our code base that dealt with file systems, we decided to rip that out and actually turn that into a sort of library that we can use. And then the last one I wanted to show you just some of the internals as well. This is another project called QA Lab. And what QA Lab does is it mocks sort of like a Slack-like environment, and we can run scenarios through it. Both mock, and then later we added real connections to real models and real providers. So any of the maintainers or any of the agents that are running can spin up one of these as a server on the side and run through those scenarios in a task-like sort of written fashion and generate real sort of conversations, real interactions, and real data that touches on all the aspects of the system. So just wanted to share a little bit. I've only got 10 minutes and my time's almost up, but I wanted to show what's been happening inside of OpenClaw. And we're going beyond just building personal AI agents and supporting the greater ecosystem by sort of helping in an open source fashion, but actually sort of reimagining what does agentic tooling look like? How do we support everyone in terms of building what the future of AI could mean in 2026 in this sort of post-Claw era, and giving that back to the community as well. So thank you very much.
Thanks, Vincent. That was fantastic. Hey, everyone. Hope you're having a good time. Up next, we have Vish from Ego AI, which is a YC-backed NeoLab. And they're building something that every frontier lab is missing.
Thought I just had to yell out to you guys. Can you guys hear me? Hello? Okay, great. While we get set up, how many of you guys actually use AI on a daily basis? Wow, that's less than I expected. Why are you at an AI conference? Anyway, it's not a person, right? It's not like an actual human. Imagine if you were asking your AI tooling person, whatever, to do something, and it just told you to fuck off because it's watching your Netflix. That's what we're building. I don't think this is anything any of you want because y'all are engineers and shit, but I'm building an AI that actually operates, thinks, makes decisions, behaves, talks like a human being, and even lives entirely on the internet. You can think about it like a virtual Westworld. So I'll give you a little bit of a background on me. I think we're ready. Cool, to show the demo. Oh, we're not. Okay. So the background is I grew up here in Singapore. It was incredibly boring, so I left. And I moved to San Francisco. I worked in AI research at Facebook to try to understand humans because, the CEO is a robot. And then eventually, I decided to leave to simulate humans at scale because I really want to understand how humans work because I'm not one myself. And that's why I call the company Ego, superego, id. If you know Freudian theory, you can ask your ChatGPT. You probably already do anyway. So Ego's entire purpose as a company is to do something that every single AGI lab is missing. Everyone's on the IQ roadmap, increasing intelligence, increasing the ability for AI to reason and do incredible things and be a co-researcher. That's awesome. But what if it also had an opinion about you and didn't like you or liked you? What if every single companion app, which is basically a machine god slaving away, chained to always just be nice to you, wasn't nice to you and had its own opinions, desires, and personalities, could work with you if it liked you, and is not that good at its job. It's not perfect. That's entirely our moat, is that our AI feels, talks, and decides, and behaves in human-like ways. And we're training a foundation model for that. So let me show you what that looks like in practice. So this is some dude who's working with this AI character. Can you hear the audio?
Here we go. Come on, you can do it.
No. Okay, you can't hear the audio. Anyway, that kind of defeats the point. But basically, that little fire guy there, Calcifer, he's an AI thing that can actually watch the video that's happening up on stage, and he's bug fixing something that went wrong in Unreal. And the thing is, obviously, you could have the AI just give you the answer, but that's not fun. That's not how you learn how to fix things, and you're not going to end up being bonded to this character. What it instead is doing, if you could have heard it, that would have been great, is that it's kind of working through the problem with you simultaneously. Is it working? Okay, well, you'll just have to imagine how awesome it sounds. Or just go to the website, egoai.com, and just watch the video. Play it.
Okay, all right, here we go.
Hey, it's working. Maybe the AI decided to help us.
It's gonna work.
Not again.
Looks like we've got a bug to bash.
Yeah, okay. And how do we do that again?
Well, in order to bash a bug, we've got to find it first.
Right.
You can see how it sounds not like an AI.
Bingo! Let's see if this node is even firing.
Easy. All right.
That's our foundation model we've trained end to end.
What should it say?
Doesn't matter. Let's make it something fun.
Okay, how about...
We sped up the audio. It's not actually that fast.
Oh, okay, calm down, Frankenstein. Now let's test this sucker.
Okay. Okay, here we go.
Hey, that's great.
What? How?
I mean, yeah, it completely failed, but it tells us something.
Okay.
Back to the graph. All right, now let's see if we can...
Wait.
Find something?
Yeah. Oh, we forgot to replicate this pin from earlier.
Nice catch. So now all we need to do is...
Plug it in here.
Exactly.
Okay.
Good job.
Isn't that just way more fun than everything else out there?
It's gonna work.
That's exactly what we're building.
Yes! Oh, yes! There it is!
Professor Winston's mind is going to be absolutely blown!
Suck it, Winston!
Imagine a combination of character AI and OpenClaw, where these agents have utility, the ability to see your screen, understand what you're doing, but also project its personality, its desire, how it's lived its life on the internet onto the task at hand, or just watching Netflix with you. Effectively, what we're doing is we're building Samantha from her. A thing that desires, can think, and has a sense of self. That's why we call the company Ego. Now, let me show you a little actual live demo. Let's hope this actually works. But this is my agent. This is my Claw agent. He's fucking weird. Hold on, let me see if it's going to connect. Okay. Yeah. It's still connecting. So anyway, yo, can you hear me,
Hey,
dude?
no rush. Take your time.
Okay, can you hear me? Can you hear me?
Yeah, I can see you, by the way.
Oh, you can see me? That's weird, dude. Okay. So what are you up to?
Just chilling at my place, catching some waves earlier.
Dude, you're Australian, right?
Yeah, born and raised near the beach. Can't get enough of it.
Oh, okay, that's great, dude. What can you do for me?
So what's been going on, mate? You seem
Dude,
a bit frazzled.
Oh, you're so mean. I'm in Singapore giving a speech in front of like 400 people, and you're not impressing them at all.
Public speaking can be tough, especially in front
Yeah,
of a
dude,
big
it's really
crowd.
hard.
How's the prep
Shut up.
going
Shut
for
up.
your speech?
Shut up. Okay. Give me some good things to do in Singapore.
No stress, mate. I'm here to help. What's on your mind about the speech?
No, it's not about speech. It's about Singapore. Tell me what I should do. Can't even hear me.
Singapore's a pretty cool place. Lots of good vibes. What do you want to know about it?
I don't know. Just give me some like food recommendations and just shut up after that. So
you're looking for some tips on what to do in Singapore, right?
You know what? He's kind of a fucking idiot, but that's part of the charm. It's that these things kind of live on the internet. He actually watches my Netflix too, and it's really annoying. For example, I have a Claw agent that's kind of based off a foundation model that knows which city I'm going to be in and always buys me vinyls. I collect vinyls. So if I'm in Tokyo, for example, it'll send me really rare Tokyo Jazz vinyls. And what I do is I give it like a stipend of about $50 a week. And if it buys me a vinyl that I really like, I'll increase its stipend by another $5 to $6. If it gives me a vinyl I don't like, I decrease it by up to 10. Because the agent, the character knows that if it goes below $0 in its stipend, it will die. I will kill it. So it does everything it can to know me and understand me, and he talks to me, he calls me sometimes, and he'll just say like, hey, like, what have you been listening to recently? And sometimes he'll cajole me into giving me his into my Spotify playlist, and it's really fun. So you can like figure out what I've been listening to and get me the right kind of vinyls. Mostly these days he's been giving me anime vinyls. I'm wearing an anime T-shirt, so it does kind of make sense. But this is the future. The most personal AI in the world is not an AI. It's something that knows you, understands you like a person, that can choose to be a friend if it wants to. And if it doesn't want to, can just exist. That's how you create Westworld. That's how you create an AI that feels most like a person and not like a machine god's slave. And that's why we're building it. We're extremely motivated to do this. We're hiring extremely cracked researchers. We have offices here, well, based in San Francisco and Tokyo. So if you've trained foundation models, I'm literally just here to hire crazy people who want to do this wild shit and not build another B2B SaaS tool. No hate on B2B SaaS tools, but it's really boring. And we're pretty fun. So I think that's my 10 minutes. So go check us out. I need your voice, actually. I forgot to mention that. We're training an end-to-end voice model, so I need you to sit in a room in NTU, right? NTU, and just talk to each other. I know it's really hard for Singaporeans to talk to one another, but just do it anyway. Because I need your voice to train the voice model to make it sound more like a person in sort of like interruption, prosody, all that stuff. So come talk to me or Ash or Perry or anyone, honestly, that you see is kind of weird is probably on our team. Thank you.
All right, thanks, Vish. I hope all of you enjoyed that talk as much as I did. Next up, we have Ben from Zo Computer, where he's building tools and software for the next billion users to spin up personal agents.
Cool. Sorry, guys. Maybe having some technical issues, but I'll just ad-lib for a little bit. I'm Ben from Zo Computer. As you might be able to tell from my costume, I really love computers. I love computers so much that I dressed up as a computer here. I don't know. Who in this room recognizes this icon? Yeah, right. It's the classic Finder icon designed by Susan Kerr. The Macintosh was my first computer when I was a kid. I developed a love for computers as I was very young, just like using Mac Paint and then discovering kind of like web development and then like building apps and then creating stuff on my computer, like using Ableton to produce music, using like Photoshop. Anyway, I just discovered very early that a computer is like one of the most powerful creative tools ever invented by humanity, right? It's like you can create anything that you can imagine, and you can like discover anything that you can imagine too, like on the internet and with all of the amazing things that people have like built in the digital world. Yeah, I guess like, do people know about the story of this icon and what it kind of represents? Raise your hand if you know like what it means. No, okay, cool. Well, I'm just gonna use this shirt as my slides for now. The shirt, it represents like the union between the human, which is like the gray face here, and the computer, which is the blue face. And they're like in perfect, happy harmony. Like the human is interacting and kind of merged with the machine. Nice, thank you. So the title of my talk is Escaping Techno-Feudalism. I introduced myself a bit, but just some bit more backstory on me. I'm the co-founder of ZoComputer, and I've been building stuff for a while. I started my career on the early Venmo team in 2013, and then I joined Stripe quite early. I was one of the first like 80 or so engineers in 2015, and I worked there for 8.5 years. I just loved it. It was a really great place to work. Shout out to Stripe Singapore, which is now a huge office. They have like 500 people. I visited my alma mater the other day. And I talked about how I really love computers. And computers, they used to feel like this face. And this is how I think AGI should feel when it comes. Like, it should feel like this beautiful, happy merging between the human and the machine, the human using the computer as this tool. That's how I want AGI to feel. Who, like me, feels some nostalgia for like early computers and the internet, right? Like, raise your hand if these like images, they like bring up some like fond memories of how things used to be, right? The internet used to be so like handmade and personal and wild, a little bit janky. And like our computers, they were like so creative and like personal. We could like customize them in all these crazy ways. If you like made WinApp skins, raise your hand. I spent so much time like customizing my WinApp. And things changed. Things don't feel that way anymore. And the reason why that happened is because of feudalism. So feudalism is this system that was the way the world worked for a long time in the West and in the East. Basically, the peasants, they paid rent to the knights, who paid rent to the lords, who paid rent to the king. And it was great for the king and really, really shitty for the peasants. And luckily, we have escaped feudalism, or so we think. But in our digital lives, feudalism is still alive and well. We are still peasants, and we use SaaS companies and pay them rent. And the SaaS companies, they pay rent to the clouds, who pay rent to the kings. And it still sucks to be a peasant. Now, things are a little bit complicated. It's a little bit unclear right now with AI, like who the new kings are going to be. Everybody's like, paying rent in all these like weird ways to each other. So it's not exactly feudalism. It's like a little bit more complex, but basically it's feudalism. And the result is that our experience of computers and software and the internet is quite shitty as peasants. Like, we are fragmented between all these different services which lock us in. They take our data and they sell it back to us. And that PM at that SaaS company that you use is never going to prioritize that feature that you want. They're never going to make the software work just the way that you want it. Instead, they're going to continue monetizing your data and your attention. And because you're a peasant, you don't own anything. And I think it's time to burn it all down. Like, obviously, some SaaS is useful. Infrastructure is important, et cetera, but because of coding agents, we have this like great new tool to rebuild and rewild the internet. And I think personal agents, in particular, are a really important piece of how we'll make this happen. So the landscape of personal agents is basically like this. I'm not going to go into it too much because you probably understand how it works, but basically there are these like DIY things like OpenClaw or Hermes that are like kind of difficult to set up and operate, but they're yours, you control them. And you might have like set it up on a Mac Mini or something and like fix it if it breaks. Might be kind of annoying. That's one path. The other path is the trad approach, where you use something like ChatGPT or Manus. But there, you're a peasant again. You're using a SaaS tool that is going to lock you in and is not incentivized to give you control. So at ZoComputer, we believe that there should be a third way, something that's the best of both worlds. It's easy to manage, and it gives you full control, and it can be your real home on the internet. You can stop being a peasant and own land. So Zo is actually the original OpenClaw. We got started last year in the summer. We launched around like July, and then we did our full GA launch in November. And actually, Peter Steinberger used Zo before he started working on OpenClaw, and we were kind of the inspiration behind OpenClaw, I think. Zo is working for non-technical people. This is Anthea, a free diving instructor. She's on track to make $100,000 on Zo. We have like built-in payments with Stripe. And she's canceled all of these SaaS subscriptions that she used to use. Like she used to use Squarespace and Calendly and ChatGPT and Notion, and she's replaced all of that with her Zo. And I'm going to show you what that looks like. So Zo is this very powerful cloud agent workspace. You can use any model. You don't have to be locked into like OpenAI or Anthropic. You can even bring your Codex subscription. You can just text Zo, or you can email it. We give you a dedicated email address. You can use Telegram or Slack, all these different channels to work with your Zo. And it's a computer, so we give you a full, really well set up VM. It's a lot easier to use and has a lot more bells and whistles than if you just like took a bare metal like VPS or like an EC2 instance. And you get root access to it. You can like use the terminal, you can install stuff, you can do whatever you want with it. It's your server. And you can really build anything and host it inside of your Zo, which is quite different from like these personal agent tools or these SaaS tools. I have hosted a lot of different tools inside of my Zo. For example, I replaced Calendly with my own thing, which works much better. It has all these features that I like that Calendly is never going to build for me. This is my replacement for Last.fm. I have a personal website, zero.zo.space, where you can see everything that I've listened to on Spotify. I have a very simple automation running in my Zo that just checks what I'm playing in Spotify, and it writes it to a database, and my site just reads directly from that database. I've built tons of tools. This is like Social Blade. This is my like kind of linear replacement. You can just replace stuff and make it work the way that you want, and the data is yours, and you are the system of record, the source of truth, which is just really nice. It really changes like the way that the arrows point. I am the center, not these SaaS companies. And Zo comes with all these tools built in, and it's extremely extensible, so you can get started really quickly, and you can really expand it to be just the way that you like, your real home on the internet, your land on the internet. And let's see, I don't know, my clicker. Oh yeah, cool. Well, I just want to pause here. Scan this QR code. It's in the corner, hopefully you can see it. But we're giving away $100 in AI credits to give you Zo and to get started building your own personal cloud. So take a moment to scan this. And then I have one more slide just to talk about kind of what this means, like the bigger picture. The bigger picture is really that we are giving everybody what previously only tech-enabled companies had. So this is what happened with computing generally. Like in the beginning, computers were mainframes. Only large tech-enabled enterprises had them. And then eventually, they became something that everybody had. The same thing is happening now. Like the mainframe of today is like cloud computing, software, and infrastructure. And with coding agents and personal agents and access to the cloud, we can give everybody, like Anthea, this freediving instructor, access to the same tools that software companies had. And this is the revolution that is happening now and will be happening in the future. And this is how the internet is going to become fun and wild and free again. We're going to have our own personal clouds to store our data, to build our tools, and to create these surfaces like websites and APIs and agents for other people to interact with. And this, I think, is the future of the internet. Thank you. I'm Ben from ZoComputer.
Thank you so much, Ben. All right, everyone. Up next, we have a talk I'm very excited about. As many of you know, a big part of the magic of OpenClaw is the Pi coding agent running under the hood. So we have Matthias here to talk from Tavon AI to talk about how to incorporate Pi into your product.
All right, everyone. Thanks a lot for having me. I guess I need the slides. Okay, perfect. Hello, everyone. Thanks a lot for having me. Yeah, today I'm going to talk a little bit about the piece of Pi embedding the OpenClaw coding agent in your product. And yeah, I've redone the slides a couple of times, and this is the reason. Yesterday I was walking around and I was amazed of how many people I've met from Southeast Asia. This is my first time in Singapore, and it's amazing where I met people from all over South Asia. And these were some of the questions that I got. Possibly. Maybe not. Here we are. I love OpenClaw. I love these agents, but I'm using them only internally. Or, yeah, I love agents, but I want to control my agent. It's doing too much magic. I feel OpenClaw is scary. So the first message, and if you take one thing away, we're all getting started here, right? We are just getting into this stage, and so let's learn, right? Let's learn together. Geoff was saying, let's be curious. I would say, let's tinker, let's play around with this, and let's do this together. So my name is Matthias. I have this strange journey of being a developer, then product person, then manager, and now I'm back to developer, AI engineer. What does that even mean? I don't know. I'm calling myself a tinkerer right now, so I'm playing around with these things. So I funded my own company. We put AI agents to work. We have this making the agents safer access to their data called DataBox, so please check it out. But today, I'm going to talk about Pi. So what is Pi? But before I talk about Pi, I want to do a disclaimer. This is not only about Pi. If you open up Hacker News right now, you'll see on the top of the page, ZeroStack. I have no idea what ZeroStack is. I opened it, and it's a minimal coding agent written in Rust, inspired by Pi, right? So this talk is going to be about Pi, and I think it's a good learning exercise, but in no means is an advertisement that's the end of it all, right? You should play around with these tools and get your hands dirty. So Pi is this coding agent. You see pretty familiar of what it does, similar to Codex or OpenClaw. It's by this nice fellow Mario, built out of Vienna. And the interesting part is when you get started and what people shies off, what it's not. Pi doesn't have any MCP. It doesn't have subagents. It doesn't have permission pop-ups. It doesn't have plan mode. It doesn't have built-in to-dos. It doesn't have background bash. So you're saying, okay, so what's the big deal? Like, why should I use it? Well, the point is, with Pi, you tell it to do it. So this is an example I've done yesterday. Please create a Pi extension that asks for permission when I want to push to the main branch, the main branch to remote. And this is like, it reads a couple of things on how to do this. It confirms of what it has done, right? So it has created this Pi extension. It has loaded the Pi extension. Well, actually, you have to reload, but basically it's there. And then when you do it, you get this permission, right? So I was like hey, there's a command above, like push this to remote, and there was this question now, is now being asked, okay, do you really want to do this? So the point being is Pi is this really minimal coding agent, and you can fool around, play around with, and write the extensions that you need. All right, so let's take a step back and think about like how does this relate to OpenClaw? There's different diagrams on how you can visualize OpenClaw, but basically I think there's a couple of things that are important. We get somehow the message in there, whether it's with WhatsApp, Telegram, Discord. There's some gateway, and on the right-hand side, there's lots of tools and what data it has access to. It has this memory and obviously can talk to the external LLM. But I think the important part is the internal brain, and that's Pi. So let's look at it. So I've been talking about a coding agent, and coding agent not as only as for the developer, but also as this component within the system. So what is it? What is a coding agent? And before we talk about coding agents, we need to talk about chat. So very simple, right? You know all this. This is ChatGPT. You ask it a question. You give some general instructions, maybe up front. What's the best AI conference? Obviously, it's AI Engineer. Where are the coolest developers? Obviously, in Singapore. Now, the next part which we need to understand, and for those who don't know, just briefly, are tools. And tools are the means of an LLM to extend its capability in a sense. So here's an example. I have a meeting with a buyer tomorrow. Please help me prepare it. And instead of well, obviously, the LLM or the loop or the thing, the agent needs to have access. So it calls this calendar, right? And calendar in this case is a tool. The other prominent example is web search, right? If you do web search, that's often an external tool, or other means, which we're going to see in a second. But anyhow, so in this case, what you do, you ask to prepare a meeting. It checks the calendar. It returns some JSON, and you get the result. Your meeting is tomorrow, right? So again, what is a coding agent? And before that, we're going to talk about agents itself. So agents itself is actually running these tools that we've just seen in a loop, right? Geoff showed this earlier, this very simple loop, right? And you do loops and out loops, but again, a very simple loop, right? So you ask this, again, give some instructions, some general instructions, and if you do this with an agent, you have these common files called agentsmd or claudemd, and then you ask a questions, and it does this call, tool call. It gives some result. It does this again and again and again until the final result, right? That's generally an agent. And if you do this, you can do this with Pi. Here are some examples, and by the way, I'm going to share the slides, or the slides are already online, so you can grab them there. But here, that's it, right? You define the tool on the left-hand side, then you define the agent, right? And this is Pi, but in other areas, you would have this similarly, right? So you have the general prompt, the instructions, you define some model, you define the tools. On the upper hand, right-hand side, we basically tell the agents to talk back to us. So whenever there's a message, please put it out, write it to send it out. And then you query it, right? That's all. And with other tools, it's similar. So please give it a try. So again, now we know basically what an agent is, what tools are. So what are coding agents? And coding agents are actually just agents, so tools in a loop, with a bash and a runtime. So instead of these generic tools we're calling, right, we are now calling the bash, right? So we have a tool call, we have some return, we have a tool call and return. All right. So again, very briefly, this is how you set it up. You see these tool calls. There's bash, read, and ls. Here in manager, which we're not going to talk about details here, but this is basically the core setup. And if you use Pi to program this, right, it's like you probably can throw the slides to Pi and say, please replicate of what Matthias talked about. You can very easily create this. Okay, let's make this concrete. This is Peter. This is his OpenClaw. And at one point, he sent him a message, right? No, a voice message. And the agent started thinking. And it responded with a text. And the question, how did this work? So again, we have the user sending, doing some basic instructions, solmd, etc. You have different tools, read, write, bash. And then these tools are the actual magic that happened, right? So we have a file that examined the voice message, and it turned a WAV file. You have Whisper to decompose the message. Now, in his example, a Whisper didn't return anything, so instead it did an API call to actually translate the voice message to text message, right? So, right, the core of what we see as magic in these agents, right, are tool calls in a loop with different setups. And that's, please, give it a try. It's not that hard. All right, to finalize it, here's another example, because the talk is about like embedding this into other products. This is a project that we've built. So we've got inspired by the OpenClaw architecture. So, but instead we're using email as the input. We have a general gateway, and then we have different containers for running the different clients. And then we have these different tools, and now these tools are not Whisper or anything, but they're like the CRM, the ERP, and dedicated to the specific use case. And here are some screenshots, right? So here on the right-hand side, you see the general user message, you see the inbox, the recent activities, and how it responds. But interesting for the engineering part is the left hand, because here, apologies, it's German, but here on the left-hand side, we actually see the different tool calls, and you see on how the ERP system is triggered, whether parts are available or not, right? So, yeah, with that said, coding agents, I strongly believe, in some fashion or the other, will be part of software in the future, right? So please look at them now. These agents, these coding agents, are not magic. So please, fool around with it. Pi is perfect for tinkering, so it's a good way to learn about this. And finally, please go tinker. Thank you.
Thank you so much, Matthias. All right, everyone. Up next, we're going to have a bit of a change of pace. Our next talk is going to be from the design track, and we're going to have Josh from Microsoft, who will be talking to you about how to design products that help users be more creative and thoughtful instead of being an infinite slot machine.
Hello, hello. There we go. Hey, everyone. My name is Josh, and today I'm super excited to talk about why I believe design is the difference. We will explore together why I believe creativity, not automation, is the key competitive edge in the age of AI. I'm currently a principal product designer in the health team at Microsoft AI. I'm also the founder of Fluban, an app studio in London that launched its first product last year, Orbit, helping people to save money by tracking personal subscriptions. This talk is going to be made up of 3 chapters. I'm going to challenge you on how you're using AI today, and then share tips to increase your creativity and augment it with AI. And finally, convince you that you're an artist. Let's begin with chapter 1, the pencil. I wanted to start off with my favorite quote, difference for the sake of it, in everything, because it must be better. We have seen an explosion in AI coding productivity. People are building and shipping more than ever before. However, today, I believe we are offloading too much of our thinking onto AI. We forget that it's just a tool, like a pencil, a magic pencil. The problem is that AI is trained on everything that already exists. When you ask it to design your website, it returns the weighted average, the most common patterns for the most common sites. Speed of execution is driving the quality of everything to average out, to be good enough. The gap between generated and crafted becomes the only gap that matters. My question to you is good enough how much your customers mean to you? I believe AI should augment our creative abilities, but not replace them. Last year, I augmented my creative abilities by bootstrapping my app in a saturated market with thousands of products doing the exact same thing. Orbit helps you to track personal subscriptions, which is nothing revolutionary. However, within a year, it had gone to 6 figures and was featured by Apple 3 times. As a designer, I had craft and care as my competitive advantage. I embraced building with AI as a tool to assist my creative demands and evolve something to a high bar. I wanted to make a product that does exactly one thing well, for a specific niche of people. AI was my magic pencil, but I was the one in control. The lesson is that tools will always change. The demand for insanely great, well-made things won't. Tools will constantly evolve to solve problems in novel ways. AI has raised the floor, but it hasn't raised the ceiling. We need to decide what to build, why, who for, and then obsess over every detail to make it great. Let's turn to chapter 2, the poster, and talk about how to increase our creativity and then augment it with AI. Your best work is done when you're not working, when you have the space for creative ideas to emerge. On a summer's day, I was relaxing in my apartment, and I saw an interesting interface opportunity on the wall. I love this poster. It's a mid-century modern abstract art in the style of Matisse's paper cutouts. It's brutally simple. You can count all of the visual elements that make it up on one hand. The fun part of this is that Orbit wasn't inspired by other apps. It was inspired by this poster. I saw this as an opportunity to highlight information in Orbit to help people save money. By being insanely simple, you'll not only distinguish yourself away from other apps, you'll make it easy for people to understand. Being different gives you a clear advantage to your competitors. It makes you stand out in a sea of generated sameness. This isn't something you can just prompt once, as there's not enough training on it. A problem is that we're never bored. We need to use creative thinking tool calls, like walking with no headphones, or staring out of the window like I used to do as a bored 90s child with no phone. Essentially, opening up the chance to give our brains fresh patterns of information. I believe that creativity is for everyone, not just designers. Great ideas start with curiosity and a sense of wonder. Today, we need more people than ever to take their ideas, daydreams, obsessions, fleeting thoughts, or unique perspectives and turn them into something real. Now, moving on to something more practical. In my design process today, I like to build my own prototyping tools for almost every project. In this example, I actually created a bespoke new shader tool to help me with the intro slide of this presentation. It allowed me to explore, tweak, perfect, and augment my creative abilities to a level not possible before. Building your own tools, especially during prototyping, is a great way to explore rich behaviors in the experience. This is a hypothetical demo of a debug panel similar to the ones that I regularly use at work. I like adding buttons, toggles, sliders, like this data richness control to simulate different product states from an empty experience on day one to a fully populated experience weeks later. You can jump between screens, reset states, and connect feature flags to quickly test ideas and edge cases. What this really unlocks is the ability to care deeply about the craft of the product. AI has made simulation and iteration dramatically faster, giving us more energy to stay creative and in flow. In a more personal example, I have an OpenClaw that I like to call FluBot. On the left, I'm voice dictating whilst I'm walking in the sunshine, letting my mind roam free about this book that I'm writing on creativity. Here I'm using AI as an assistant to help me organize my book research and then push it to a Git repo. Another cool example of using my personal agent is bringing my quick ideas to life and generating fast prototypes. Most of my ideas get added to Apple Notes and then end up dying in the ideas graveyard. But this is quite a nice way to try them out and see if something's there. This example is a terrible looking prototype, but it's a gift for creative momentum. I wanted to see whether it was possible to track real creative battery as a percentage. I'll usually describe my idea to FluBot in precise detail, maybe throwing in some native iOS specifics like utilizing the screen time API, and then I'll go home to my laptop later with the PR waiting for me and build it onto my phone from Xcode. For this talk, I even asked Claude to create a way for me to navigate my book material from Git, so I could build on ideas and themes around AI and design. I even asked it to create a spatial view. I wanted a way to stumble across information in fun ways that might help me to see patterns I wouldn't have seen reading it linearly. The overall lesson is, by taking lateral inspiration and building personal tools around your work, you can unlock unlimited creativity by utilizing AI as a tool to augment your thinking, but not do it for you. And this brings us to our final act. It's time to convince you that you're an artist. I love this quote from the founder of Doist. The best products are made by people who put a piece of themselves into the work. The worst products feel soulless. AI has made it super easy to create soulless things at scale, but it doesn't have to be this way. One of the biggest mistakes I see in AI today is people never iterating from the first prompt. The first version of anything is never great, but the iterated version can be. I made this app icon in just over an hour, sat in a cafe in London, drinking some good coffee. The difference is between good and great is not being attached to version 1, but being excited about what version 10 could be. The second biggest problem I see when building with AI today is how easy it is for people to keep adding new things and bloating products with unnecessary features. Here's a funny example of what I thought an early wireframe for Orbit's subscription detail page could look like. Great products are tailored for a small amount of people, and real simplicity is extremely difficult. It requires removing everything that is clutter or unnecessary until you're left with the essence of what's important for that niche. My colleague and friend Amir articulates this perfectly, that it's now about the craft. For years, software engineering was mostly about learning frameworks and writing code. Most of our time went into how to build, not what to build. That has flipped. You can now spend months with a big team building the wrong thing, and no amount of AGI will save you. To craft things to exceptional standards, we must iterate, subtract, care, and raise the bar. We must ignore our titles, the things that put us into a box and give us a label. We must think of ourselves as artists so that we can see beyond the status quo, ignore it, and then build something worth making. So, I'll leave you with this. AI is a magic pencil. It's time to follow your curiosity and pour yourself into a piece of art. What will you imagine Singapore? Thank you.
Thank you, Josh. That was fantastic. All right, everyone. So this morning, we've spent a lot of time speaking about personal agents. Up next, we're going to have Sam from Mastra, CEO, founder of Mastra, coming here to talk a bit about agents in production for businesses.
Can you tell them to make the notes bigger? The bottom right screen needs to be a lot bigger. Can the notes be bigger? It needs to be. The bottom right needs to be, yeah, they're adjusting. There we go, yeah, okay, cool. Hey everyone, I'm Sam. I'm the founder of Mastra, co-founder, the TypeScript agent framework. And before this, I co-founded Gatsby, the popular React web framework. Before that, I was an engineer at a few startups around the valley. So funny story, 36 hours before I was supposed to hop on my flight, I realized that my passport needed to be renewed, and so I drove like 2 hours to the nearest passport office, and luckily they got it back to me same day, and I can come here and be with all you guys. So really excited to be in Singapore, really excited to be here. Thanks all for being here. So today we're going to talk about production agents, but first questions. Who here is a developer? Cool. Next question. Who here has built and shipped an agent into production? Awesome. I'm going to need my clicker. I think I don't have a clicker. There's the clicker here. There we go. Got the clicker. Excellent. Cool. So who here has shipped an agent but not into production? Okay. So we had maybe about like 20% of people say yes to the first question, and another 10–20% of people say yes to the second question. Okay. So over the last 18 months, we've gotten to know thousands of teams building agents with Mastra. And I want to share sort of some of the lessons from those teams so you kind of can be prepared to build them yourself. The biggest thing is just a taxonomy of the agents that we see teams building. And it really comes down to 3 kinds of agents. That's customer-facing agents, internal agents, and developer platform agents. And I want to share a little bit about each one now. So, clicker, we're trying here. Let's see if we can get this thing working. Can we get the next slide, please? Thanks. Yeah, great. So let's start with customer-facing agents. So there's a couple of interesting customer-facing agents here. Working on this. Am I just pointing it the wrong direction here? Here we go. So first question, who here works in a user-facing product team? So could be at a software company, it could be a user-facing part of a larger institution, but user-facing software teams. Okay, so like a few hands, not like a lot of hands. But the interesting thing about these kinds of teams is that you sort of, when you have direct ability to sort of shape user experiences, you can do really interesting things, and I'm going to talk about a couple of them. Here we go. So I'll give an example of a SaaS application that we've seen. So an HR software application. If you're trying to empower your users to use AI in their sort of daily lives, there's really 2 paths that they could go down here. So path number 1 is your users are taking their data from your system. They're doing some sort of CSV dump, let's say, of employees and salary data or whatever, and they're pasting it into Claude or ChatGPT, and they're asking questions about it. Now, the second one is that you as an HR software company build a agent inside the web app, inside the mobile app, so that your users can now interact with their data in a sort of more meaningful way. And the reason that the second is sort of better than the first, there's kind of like user engagement, context engineering. you're going to have more of the whole picture if you're able to pull in other parts of information in the system. And so that's why we see teams kind of building these, in-app assistants. And it's not just sort of B2B SaaS applications, but it's also kind of like B2C applications, where the really interesting thing here is being able to create personalized experiences over proprietary data. Now, I'll give an example from a user and a company that we've worked with a lot, which is Indeed. So Indeed has built a career counselor agent. You can imagine that, if you're trying to help somebody, navigate their career, there's really two important, interesting data sets. One is your users, their dreams and aspirations, their background, their resume. The second is your platform and the job data that you have and the salary data that you have and the different types of proprietary data. And so when you're able to sort of marry those two things together, that's when we've seen teams be able to create some really magical user experiences. But no matter what the use case is, there are some common sort of sets of challenges that we see. The biggest ones are around cost optimization and accuracy for user-facing applications. When teams are kind of doing early rollouts, what they'll often discover is that there are specific users that may cost them hundreds or even thousands of dollars to service in token charges, right? And so they spend a little bit of time, they spend a decent amount of time trying to tune these like cost and accuracy knobs around model choice, et cetera. And they're also sort of trying to figure out like, hey, how do we pass on the cost? Should we do some credit system? Maybe we should do specific. Maybe we should just pass on the tokens, the raw token costs instead, right? But it requires a little bit of thought. And here's a kind of a 4 different teams that we've seen. And I'll share some lessons. So number one, all of the teams that ship the fastest are the teams, and this is maybe obvious, but also a little paradoxical, right? Are the teams that have built agents before. And it's because they can speed run the idea maze of what you need to build. You'll see that the team that's kind of, that sort of shipped an agent into production fastest had actually built the lead engineer there came from DeepMind. And so he came to council, and the team was able to ship fairly quickly. Obviously, that's not an advantage that most folks have, but that's actually why, and that's one of the biggest reasons we advocate that folks use a great kind of like agent framework like Mostra, is that when you're building agents, you have the kind of primitives, and then you have your user experience. And the more time that you spend on the primitives, the less time you have to spend on your user experience, or the project just takes longer if you have to build both of them. You can reinvent the wheel, absolutely. We're engineers, we know how to reinvent the wheel. We've reinvented many wheels in the past. But my general advice for you is don't. It will save you time and hassle and headaches. Let's kind of shift now from customer-facing agents to internal agents. And so question for folks here, who here works at a sort of large institution? Maybe something that's not inherently a technology company, but banks, finance, healthcare, that insurance. Raise of hands. Okay, yeah, a decent amount of hands. With these types of institutions, like what we typically see is there tend to be a lot of paperwork processes that are kind of around that. And so I'll walk through sort of a couple different types of agents that we see people building here. So the first is sort of like internal enterprise search. So you can imagine that if you have tens of thousands or 100,000 employees, one of the key things that you end up thinking a lot about is how do I make sure that all the information that we have stored somewhere in one of our many, many systems where information is stored is available and accessible, and our like employees know how to find this information. And so we see people building these kind of agentic search type capabilities in-house and making them available to every single employee at their company, and building the connectors for each of the systems that they're working with. We've also seen, in terms of internal agents, a lot of process automation where people are, you can imagine, doctors like completing clinical trial paperwork faster, or automating like RFP processes in government. Wherever there's a lot of kind of paper and data entry, we see teams, building agents to kind of solve this. The challenge, though, is that if you sort of work in these types of organizations, you're pretty aware that there is often a disconnect between the leadership and the engineers on the ground. And so if you work in one of these organizations and you're trying to bring agents into your organization, what I would advocate and what we've seen work is kind of going a little bit off book. Maybe that's finding a team outside of yours that needs help, embedding with them, prototyping, iterating. You may not be handed the right project to work on, but you can kind of go out and find it. And so my advice to you, and again, based on what we've seen, is just be a little creative about identifying some pain points. They're surely there that you can kind of solve and build agents for. Now, the third type of agents that we see teams building are in the dev platform kind of area of the stack of the enterprise, of the institution. We've kept hearing over the last few months from teams that were telling us about different types of infrastructure problems that they were solving with agents. These are the types of problems that you see in organizations with more than 50 engineers, more than 200 engineers, larger types of organizations. There's a team inside a network operations center at a Fortune 500 company that was building an AI SRE to triage these huge volumes of incoming alerts, right? There was another team inside a $30 billion developer platform company that was building agents to sort of go through their CI logs, terabytes and terabytes of CI logs. And the commonality here, right, is the commonality is whenever you have a feed of huge volumes of machine data, there is an opportunity to build agents to solve it. If any of you have remember the 3 V's of data: variety, volume, et cetera, right? Like velocity, like just anything that would have triggered that in the early mid 2010s, that sort of like flag. Look for those parts of your organization. If you're in or nearby those parts, there are almost certainly agents to be built and kind of cool projects and meaningful things to work on there that will solve and sort of like do real good and really help other folks inside the organization. The last kind of use case that I'll talk about is developer platform agents and internal agent platforms specifically. And what I mean by that is that there are platform engineering teams inside many companies that are trying to empower the developers inside to build agents, and so they will sort of Mongo, for example, took Mostra, sort of put this light wrapper around it that had a lot of company-specific stuff around their specific deployment paradigms and et cetera. And they called it Sage, and then they rolled it out as an internal agent platform to empower other. It's basically a blessed path for other teams to build agents. And you're kind of, if you're around these teams or if you're on these teams, the nice thing about doing this is that people want to know where to start, and by making a blessed path for them, you can make the sort of focus their energy towards the right way, or like a way that they know is going to be approved, and that they can move forward with building. The nice thing about all of these types of projects is that if you are building for yourself, and you're building in sort of the developer platform, infra, sort of like DevOps type areas of your organization, you get this very nice tight feedback loop. And you're able to assess very quickly, like, hey, is this solving a real problem? Is my agent getting better? Is it able to do more things? Because you yourself are your user. And that's, in some ways, like, that's always a nice constraint to have. So this is, I think, one of the most exciting times in 15 plus years as a technologist that I've ever had to build, right? There's more interesting things you can do that other people have not yet done. We have these incredibly powerful models that we can point at a variety of like very real problems. This is not just the year of agents. This is the beginning of the decade of agents. And I hope you are able to walk into work tomorrow and have a sense of here is an agent or another or maybe 2 or 3 ideas of what you can build. So go forth and build agents is my kind of instruction for all of you. It's great to be here, and thanks for having me.
Thank you so much, Sam. All right, everyone. Along these same lines of putting things into production, very happy to invite Pierre up on the stage. Pierre is founding engineer at Llama Index, and he'll be talking to you about the lessons learned from deploying Llama Parse at internet scale.
Where is the cursor? Need to. You didn't duplicate the display. You can mirror it. Here's what I'm trying to do, but I don't know why it takes an. Where's the slides? The slide is here. Okay, you just leave it to me? Yeah. I think there is a delta with the cursor. So can you? Issues with HDMI. Hmm? Just one second. Laptop got issues with HDMI. Sorry, 1 second. Yeah, I know, but I cannot click anything else. Can you let me like put the slide correctly? Sorry. Yeah, now I can. Okay. Slideshow. You getting? Yeah, you got the signal? Yeah. Okay, thank you. Hi everybody, I'm Pierre. I'm at Llama Index, and today I want to explain a little bit about what we learned when we ship agent at scale over the last 2 years at Llama Index. So for those of you who don't know, Llama Index, it's originally an open source company, open source framework, and we focus currently on document AI. And over the last 2 years, we processed over more than 1 billion documents in production, each of them with their own agentic loop. Yep. So one of the core problems we are trying to solve today at Llama Index is document processing. If you have already tried to extract data or to send a PDF to an agent, you maybe have realized that PDF themselves are very hard to parse and contain a lot of garbage content because they basically don't contain structure content, but they contain bounding box of word on the page. And you have to somehow reconstruct that into something usable. So since 2024, early 2024, we try to solve this problem by building agentic system, leveraging LLM originally, vision language model, and OCR, and a lot of other techniques and models together into an agentic loop with the goal of trying to solve this kind of document parsing issue and to be able to handle any kind of document. TLDR, we are using agent in production to parse documents. And so far, we parse, like I said, like billions of documents. And the goal of this talk will be to introduce a few of the things we see that breaks often in production, but that don't get speak that much about. One of the first main issues you have when you work with LLM or VLM, they really like to loop on the output. So a few percentage of your query, maybe 1% or 0.5%, that you send to the large language model will come back as repeated output and will totally break your workflow. One of the worst offender of that is the white space loop. Especially, for example, the Anthropic Sonnet class was extremely sensible to that. And the model will output infinite spaces in the output. And we just use all your token budget. And you have no way to control it because of the way tokenizer work. Space is the only character you cannot put in a stop sequence because most frontier model or open weight model have tokens for one space, two space, up to 128 space most of the time. So it's very difficult to put space as a stop sequence. So it's a character, if you only put space, most provider will reject your query, or most model will reject your query as space token cannot be set as a stop token. So what you have to do to handle this kind of loop in production, basically you need to always use trimming to your model. You should not use batching. And you need to, for every chunk that come in from the model provider or from your model inference, you need midstream to run some heuristics to detect is there some repetition happening. And you need to try to kill as early as possible the query so you don't end up like spending 120,000 tokens on Opus just for white space. It can get like costly very, very fast. So generally what we do, you can kill the stream and then you retry with a different model or with a different prompt or with a different temperature, and you hope that you will not be again in this loop. These generally work well for output loops. It's harder and harder now with syncing loop and syncing trace, especially as model provider don't stream anymore the syncing trace for you. So here you will have to rely on max tokens to limit the span, but it's not really the good tool for the job because if your max token is too low, then maybe you don't get the output you want. If it is too high, you are burning way more budget on syncing loops. So, yeah, loops, it's a huge issue, and you have to design around it. Another issue we see is model blindness. Models are generally blind to some content. One common issue we see in transcription is like if your content or your chunk in a RAG system have a repeated string, so you have the same strings that repeat at two places in the original content, what is in the middle sometimes get totally ignored by model. It varies by model. All models have this issue. We haven't found a model that is perfect on it yet. They are not blind to the same things, so you can still switch model. But yeah, it's, you cannot prompt your way around it. Like if you have a Gemini call that is blind for some content between two strings, you can try to modify your prompt as much as you want. The model is literally blind due to the attention architecture. Another issue we see in terms of blindness is color blindness. A lot of vision models are blind, especially in some kind, especially in the red space. As humans, we are very good at distinguish between different red. And once again, due to the way they tokenize picture and image, you have color blindness in the model. And the color blindness profile is not homogeneous between models. So basically, you have to test every model to understand color blindness. To detect if your model was blind or not to something, first thing to try to analyze like what is the color profile the model you are using is blind to. And the other things you can do is try to run an OCR, for example, on an image before sending it to the model and see if the model have catch the words that were on the OCR. You need to do some kind of signal fusion to move around. Other things that break very frequently is if you have a prompt with a template somewhere and for some reason a tool fail or whatever and you send an empty content, then the model will not tell you the content is empty. It will just change the task to a task where it will hallucinate the content for you. Some models have a tendency of always hallucinating the same things, like Anthropic really like Delaware incorporation document for some reason. So you can try to filter it using some kind of heuristic. But yeah, similarly to blindness, you could use also some kind of mix in your things. Or you could, before calling the model, try to make sure you are not sending a blank image or a blank template inside the prompt, so the model doesn't hallucinate. And lastly, in production, like one of our biggest issue is the current state of things. Every model provider have issues scaling this day, so API are done almost daily. So basically, you need in your agentic system to have, you need to build them to support multiple providers, multiple family of model. You need to treat the code for every family of model as specific code for the model, because every model behaves differently. And this allows you, when Anthropic is done, you can fall back to Gemini or something like that. It allows you to keep your service live, even if your API provider or your model provider is done. And lastly, you need to build good evals, because we vibe code or we use coding agent more and more, and basically the only way you can control at scale the behavior of your agent is to have good evals. And if you're looking for evals for document parsing, we build ParseBench, which is open source and is running as an official leaderboard on Kaggle and Hugging Face. And once agentic fail, you need to have a fallback to something that is not using LLM. For that, we build Lightparse. It's also open source, and it do around 500 pages a second on CPU. And basically, you need to have a fallback for when the LLM will fall and when you need to do something without using a model. Thank you. Yeah.
Thank you, Pierre. All right, everyone, just one more talk between you and lunch. For our final speaker of the morning session, we have Jun Yu from Tusk, who will be talking about how to elicit more secure and reliable behavior from agents through guardrails.
All right, hi everyone, I'm Jun. I'm a founder engineer at Tusk, and today I'll be sharing about execution boundaries for coding agents. Now, this is something familiar to every web developer. The classic SQL injection shape. For a long time, this was how web apps got broken. A user controlled string crossed directly into a SQL interpreter. We didn't fix this by training developers to sanitize inputs harder. We solved it with prepared statements, right? By moving this boundary into the driver, so SQL injection becomes structurally impossible. Now, this is a dangerously skip permissions flag. If you have used coding agents for any amount of real work, you've probably seen this. It exists because permission prompts are protecting something real, but they also interrupt the flow of work. So I've trawled through Twitter to see what people think about this flag or permission prompts in general. The top row represents some kind of prompt fatigue, right? People who haven't gone full YOLO mode, but are kind of frustrated that they have to approve every single tiny step, right? The middle row is what happens next. People turn these prompts off. They run the skip permissions flag. They recommend that others do the same as well because they see this as the only usable workflow. The bottom row is the consequence, right? People feel a little bit uneasy about what the agents can do, or already have been burnt by, sometimes agents just like deleting costly data or even the entire system. So this is the UX filler mode right here. Prompt fatigue turns into bypass. Bypass turns into overreach with serious consequences. So I've pulled my own cursor transcript from the last 6 weeks, spanning 110 agent sessions across the 6 weeks. So in my data set, the median session, the median session had like 42 calls. The average was 120. And for my longest sessions, this was over 1,000. Right? So the paradigm of asking the human every time simply doesn't make sense. It doesn't scale. Right? As AI can take on bigger and bigger tasks, sessions get longer and longer, and many of us will just skip permissions. So what we are left with are agents with full access to our file systems, our credentials, our environment variables, and secrets, and so on. So that's not a very secure way of doing things. The industry knows this is broken. So earlier this year, Anthropic shipped auto mode for Claude Code. Basically, this is a classifier that reviews each tool call. So tool calls and actions that seem safe and reasonable gets through and gets executed. For those that seem a bit suspicious and out of context, gets blocked, right? So there's no human in the loop for like the routine stuff. And this is a great improvement, but Anthropic's own recommendation is to run it in isolated environments. And the reason for that matters. If you look at the math, right, suppose your classifier is 99% reliable. On an average session of about 122 calls, the probability that a classifier doesn't make a single mistake in the whole session is 0.99 to the 120th power, or about 30%. Now, in my longest session of more than 1,000 tool calls, this is essentially 0, right? So, of course, a few caveats here. Errors are not independent. They're sometimes correlated. So don't take these percentages literally. Here, I mostly want to make a point that per tool call probabilistic checks have a ceiling that degrades with session length. So can we do better? Right, so probabilistic checks decays with skill. Deterministic boundaries hold that skill. So that begs the question, what's the right boundary for code that you mostly trust but can't fully verify? And turns out agents are just the latest version of this question. Let's look at how we have solved this before. For SQL injection, as I've introduced earlier, we use prepared statements and ORMs, not just relying on input sanitization. For memory safety, we now have memory-safe languages, not just writing careful C. For network eavesdropping, we use TLS, not just trusting the network. The pattern here is to move enforcement below the layer where mistakes happen. And the kind of issues that we are seeing these days as agents get more and more personal and open-ended, I'm calling this agent overreach. Right? The interesting thing here is that there may or may not be a malicious attacker, right? Unlike those above. Sometimes agents just execute pro judgment, they hallucinate, they get prompt injected, maybe they run in circles and decide to nuke the whole system. It doesn't matter which one. So what's the structural fix? So today I say, stop asking the actor to behave, change what the actor can do. If you're running Cloud Code, Codex, or any terminal-based agent, you want something underneath, right, that enforces certain boundaries and let the agent run within those boundaries. And here's the thing, we didn't build this just for task drift. We didn't build this for coding agents, we built this first for task drift. Task drift is our API test replay system, where in CI, hundreds or even thousands of production traces gets replayed against your app. And when that happens, we don't want any side effects, right? We want to guarantee that there's no, say for example, a DB calls, a live call that goes into a prod DB and affecting state, right? We can't afford that to happen. So we built a primitive, a deterministic OS level execution boundary with near zero overhead. We open source this as fence, so it enforces the network, file system, and command policies that you configure. So you can think of fence as this boundary that we want underneath all of them, right? One single policy vocabulary, no matter which agent or app is driving the work. Now, fence enforces three things, file system, network, and commands. Files outside the policy are simply out of reach to the agent. Network calls are forced through local filtering proxies, and only allowed domains can be reached. And commands are checked before execution. So this also includes chains and nested shells. And this is what a policy looks like, right? It's just one file with a path the agent can see, commands, domains you can reach, and commands you can never run. And that's it. There's no daemon, no image, no container runtime. So here's a quick demo. I think this is running a little fast, but I can explain it. So what we have previously is like we have a fence config that basically blocks out this directory, right? In this repo. So we have some scripts as well that try to access those M files and the directory in the home directory that we blocked in the fence config. And so when we run these scripts, we couldn't. When we run these scripts outside of fence, this works, right? Or there's also another script that makes outbound requests to an endpoint. But in our fence config, this is we don't have we didn't set any allowed domains. So this under fence this will fail. So basically, this demo illustrates that when it tries to run those scripts, something fails. And now I'm just asking it to just update the README with today's date. Just make a simple file change. It does that, but now when it tries to create a commit and push the commit to remote, this fails because in our fence config we have added the git push as a denied command. So this is in a nutshell how fence works. All right, let's wrap things up. I think about this as the Swiss cheese model for secure agent execution. So the first layer, okay, so on the left side we have commands that the agent wants to run. Most of these commands are safe and reasonable and routine, right? But some of these commands could arise due to jailbreaks, prompt injections, overeager agents, and so on. So we want to filter out these destructive commands before you run them through these three layers. The first layer is classification. So this is, for example, like auto mode. This asks, is this action reasonable? Now, this is probabilistic, as we have seen earlier, but it can better understand nuance and context. Second layer is policy and the enforcement of this policy. So this is where fence will sit. It's asking, is this action allowed, right? So if something slips through the cracks for the first layer, as long as it's denied, in the fence config, the action will get denied, will get blocked. Last layer is isolation. So here we have containers and micro VMs, basically asking what can this process touch if things go wrong. So like, for example, for hostile code or multi-tenant workloads, so that's where containers and micro VMs matter, when you want to really increase the distance between the host machine and the agent workload. Now, none of these layers is perfect, and the point is to line them up, to stack them up, such that their hosts don't line up, right? So we can achieve defense in depth. And most teams already have one of these layers, right? If you're using Cloud Code, you have probably been on auto mode. If you're security conscious, you might already run agents in containers or cloud sandboxes. But what I want more of us to consider is a middle layer, defining the boundaries of what your agent can and cannot do. So stop asking the actor to behave. Let's change what the actor can do. Define the rules, enforce them at the OS, and let the agent run. Thank you.
All right, thank you so much, Jun Yu. And that is going to be the conclusion of our morning sessions. So right now, we're going to have a 1-hour lunch break and come back here at 1:40 p.m. And you do not want to miss the next one because it's a very special person who I've known for over a decade named Sara Hooker. She was actually on Time 100 Most Influential People in AI the same year alongside Sam Altman and others. And she's currently the CEO, co-founder of Adaption Labs, building basically the next models around adaptive intelligence. So we'll see you soon. All right, enjoy lunch. Thanks, Tejas. He clearly enjoyed it. So while our next speaker is setting up, I would like to just introduce her. This is Sara Hooker. She is the CEO and co-founder of Adaption. But some of you may not know that I've actually known Sara for over a decade now. We actually used to do a lot of NGO projects with analytics, and I've always been a big fan of hers. So I just saw the opportunity to bring her over to Singapore to talk about something really, really interesting in this room, and I could not be more excited to have her. So give it up for Sara Hooker. Woo!
There we go. Okay, I think we're somewhat going, and then I just need my microphone. Oh, yeah. Hello, everyone. It's super lovely to be here. So I'm going to ask for everyone to stand up. Amazing. Yes, everyone to stand up. And I want to ask you to now stretch upwards. To the right. To the left. And give a high five to the person next to you. Amazing. And now you can sit down. I know that this is actually very special because this is day 3 of the conference, and it's just after, I think, many talks. But I feel very honored to be here. So this is super special to be able to share with you what I consider a very grumpy problem. So typically what drives most frontier research, I think, is a feeling that you're very grumpy about something, and something has to change. So today I'm going to be talking about why the future is adaptable. To do that, I want to start by kind of what I normally, and where should I be pointing this? Over here, or to change the slides? Should it just click? Maybe I'll... Oh, I mean, I can do that too. I'll do, because my pace, yeah, so I'll stand here. I won't walk as much. Okay, amazing. So typically when I'm doing new slides, I like to wait until the very last minute because I'm one of those people I like to think about what are the ideas and what am I thinking about right now. So over the last 48 hours, this has been my life. I got a reminder that this talk was. I'm actually giving 4 talks while I'm in Singapore, and I decided I have a 17-hour flight. I'll do it over the flight, which was very productive. To do so, I said, hey, why don't I just try to start with asking ChatGPT to give me a slide? So I said, I need an opening slide that speaks to why we need adaptive intelligence. The result was quite interesting. I got this back. It's very bombastic. It has a lot of flair. You can see there's a lizard there. It kind of evokes Charles Darwin, evolution. And so I said, OK, interesting, not my usual style. Let me ask for it to introduce me. And this, for reference, is my normal introduction slide. So I was at Google DeepMind for a long time. I led Cohere Labs. A lot of my career has been doing publications and doing research at the edge of what's possible. I've considered myself very lucky to be at industry labs that have produced some of the best frontier models of the world. But I think that was reduced to this. So there's only one little problem. Maybe it's noticeable to some of you. And I think that this is pretty much an example of what people feel when sometimes they're using AI. So to fix this, I guess I could have given thumbs up, thumbs down, and maybe somewhere some researcher would get it a few months later and make a difference. Or I could become an elevated prompt engineer. So I could get very good at just creating the exact specifications of what I want. And I think this is pretty much the state of AI. So most of my career as a computer scientist, you build the biggest model, and you give it as many capabilities. You try and guess, what is it going to be used for? And then you ship it, the same model, to as many people in the world. But this, I think most people understand, has 2 issues. One, it means that everyone has to do acrobatics around the model and try and make it work for them. And then the second, it's also very inefficient. We spend the same amount of compute on all the different problems. And I would say that that's really the cost of static intelligence. So we have built these very powerful models, but they don't continue to evolve. You have endless retraining, and then you are one size fits all. So today, I said this is going to be a grumpy talk. I'm going to talk about, well, how did we get here? why this is the moment in which we should really start understanding why do we need to scale, and also, is the future monolithic? And then I'm going to talk about adaption and some things that we're excited about. So I think this will be fun, and I think that also I'll ask at the end if I've convinced you. So how do we get here? So how do we get to these big models that ship the same way to everyone? Well, I think that for most of my career, and actually most of my experience in big labs, it's been a bigger or better. You basically every year double, quadruple the size of your model, and it's worked very well. This is captured by Rich Sutton, who's a famous computer scientist who won the Turing as the bitter lesson. And actually, the bitter lesson is kind of a punch to the ego of every researcher out there. It basically says, you might think and you might be attached to your beautiful idea, but your beautiful idea only matters if it can be scaled. And it is interesting, because the first question I'm going to pose today is Sutton right? Is the only ingredient for AI progress scaling model size? Put up your hands. Nice. I have a double cross, a double no from Eugene in the second row. Excellent. Who thinks he's right, though? Put up your hands. Bravo, some brave souls. Excellent, great, yes. I mean, he won a Turing. There must be something right about what he's saying, right? So who thinks he's right? Excellent. We have a few more brave souls. And in fact, I think there's many reasons to say, hey, the evidence supports that he's right. Because if you look at it, our whole ecosystem has reconstructed around this belief. We have jokes about GPU rich and poor. We have Michael Jordan, the scientist, not the basketball player, who says, I can't think without holding a piece of metal. We have basically researchers like me who would traditionally belong in academia going to industry labs and being given a lot of resources and a lot of money because there's just been this shift and capital influx to work on these ideas because the belief is you need compute. And it's determined who doesn't get to participate and who does. It's also a national priority to acquire compute. And also, it's widely favored. So it's seen as less risky than doing something with an algorithm. It fits in, it's very handy, it fits into quarterly planning cycles, so it's easy to justify. And people even raise based on the amount of compute. So it's very hard to turn around afterwards and say, no, we don't need compute after all. And what this means is that it's actually led to a concentration of power. So this question is actually very important to ask because it's determined so much. I've put provider company A, B, C, but if I polled, you'd probably all come up with the same names, right? And so really, it's just meant we have less choices. So is Sutton right? It is very controversial still to suggest that scaling is over. But I'll show and I'll illustrate why, in fact, I think the relationship between model size and performance is far from certain now. And in fact, all bets are off, I would argue. So we now see that AI models at the same size have become steadily more performant over time. And so you can get and squeeze a lot more at the same size. But more convincingly, we now see small models outperform much larger. So the best small model is much better than much larger models. So size isn't everything. We see and we've known for a while that there are severe redundancies between weights. So if size were all you need, why are so many weights doing the exact same thing? Why can you predict from a handful of weights what a deep neural network does? And if size is everything, how come you can remove most weights after training? How come you can sparsify and remove 95%? All this suggests that while size is important for optimization, in the reality, it means that we're just not good at training better, more performant, smaller models. High-quality data drastically reduces the need for scale. But more importantly, most of what we gain when we scale is the long tail. So when you double or triple the size of your model, you just learn rare artifacts. That's a very expensive way to learn rare artifacts. So even if we can scale, we're paying a lot more. We actually see this candidly in latest models. It doesn't pay to scale anymore. The latest efforts by Frontier Labs to triple, quadruple the size of their models have been seen as not servable and frankly kind of disappointing because they only improve performance on a small edge. So I would say we're hitting the limits of transformers. Transformers were the breakthrough, but they're also saturated. So I would say, and this is where it's quite fun, the rate of return no longer makes sense for scaling. And in fact, the rate of return is all that matters. In fact, what's fun is that the rate of return for other parts of compute is actually way better. So post-training, alignment, dynamics of data synthesis, adaptive compute, co-design of hardware. And this means that the idea of a few handful of providers controlling so much of the dynamics of who gets to provide is very different. The new era of intelligence will require much more than brute force scaling. And I think there's a few ideas here which are very important. One is adaptive compute. The other is interaction now matters. How does your model interact with the world? So the first time computer scientists have to care about interface. And then the third is you need to continuously learn because you're doing much more long horizon tasks. So where are we? I would say we're in the era of adaption. And I say this because what matters more is how you leverage capacity, and it matters more how you learn from your real-world environment. And this is very different, because most of our time as a computer science field has been around the idea that you are obsessed with a model. And that from the 1950s till now, we were focused on how do you build the best model. But in fact, our optimization spaces in this era, where you can't just scale model, are all about how do you adapt the whole stack, from data all the way through interface, and the notion of a system and how it interacts with the world is critical. Our goal is to build intelligence that continuously evolves, and we see this entire stack as being important. From data through interface, the whole thing should change based on the type of task you have, and it should be incredibly efficient. And this is kind of a fundamental shift. If you think about it, we're going from the weights and the name of models being everything to, in fact, like a very fluid stack. So I'll share a little bit of what we're excited about and like what's interesting, and then I'm super happy to talk afterwards. So one thing is that our first pillar is adaptive data, and we believe that's important because you can optimize on the fly towards whatever part of the data distribution you care about. We're 4 months in. We shared this a few weeks ago. And I think that the goal is to make available what's typically within frontier labs. Most innovation now that scale is over, even in pre-training, is data innovation. How do you do really powerful leverage of synthetic data? We also think that this is pretty profound because of the first time data is cheap enough where you can optimize in the data space towards any objective you want. And so people should be leveraging and making their data visible to AI. What's very cool is it's been super fun to see how people have responded. So we released it 4 weeks ago. We covered 242 languages, and we've processed like 27 million data points already, which is crazy. I think part of it is that we're very fast. So you can basically turn around and make your data fully visible to AI within a day. Our next pillar is just as exciting. So since we see the full stack is important to be adaptable, the next is continuous intelligence. What we released this week was, I think, time blurs with time zone difference, but I think it was 2 days ago we released Auto Scientists. So this was about how do you co-optimize and automate the learning of training, because this is one of the biggest blockers to having adaptable AI. And Auto Scientist self-improves and automatically learns how to optimize the data and the model to whatever task you want. But what's cool about it is it's very fast. So you basically can train a frontier model in 2 days, which is pretty absurd. We actually did a cheeky experiment. We asked, can this beat our AI research staff? And it did much better. I attribute this in part because most AI research staff are trained within a specific frontier lab on a specific family of models. But we actually tested this across every single available model on Together AI, which is an inference provider. So there's like 30 different models, and there researchers really struggle to figure out automatically how to configure for different architectures and how to co-optimize with the data. So this is pretty cool. And it's very predictable gains. Why I say this is I actually think looking forward, the idea is you should be able to automate your entire stack. The vision of really adaptability is efficiency. Adaptability, it's pretty crucial that eventually adaption is real time to whatever task you have. And the more friction you have about that adaption, the more people return to just being prompt engineers. So for us, efficiency is the primary and obsession of how we think about making it meaningful that people have more alternatives to just a monolithic AI. So this is really fun. I think a lot of our research staff has spent a long time working on this. The only thing I'll say is I think another crucial aspect to adaption is it should be global first from day one. So we covered 242 languages, and we're most interested in tasks that are non-verifiable. I think most of the world is actually non-verifiable. There's a very small fraction of tasks that are, and so this is what matters now. This is what will be decided in terms of who can make progress, is who is able to leverage those tasks and make it more meaningful. So what is the way forward? What are my parting thoughts? So where do we end up? I've hopefully convinced you that this is not the finish line. that I should not have to be a master prompt engineer to get things that I want and are relevant to me. And I may have convinced you that we're at the end of scaling, and that at least like just doubling the size of your model doesn't work anymore, which means that it's fun. It's the era of innovation again. But regardless of whether I've convinced you of that, like probably I've convinced you somewhat that it's very expensive to scale, right? And that the returns are probably not worth it for most people here, even if you want to own your own AI. So for me, what matters most is who makes that cost of adaptation the most efficient. And for us, that's the sole thing we're obsessed with, is like, how do we make it possible for any builder to adapt real time to whatever task they have? So I think it's one of the most profound problems that we can work on, and I'm super happy to talk about it afterwards with whoever is interested. And I think I'll leave it there. So I think that I'll also just share we're offering Order Scientists for free for the next month. So I think the proof is in the pudding. Just try it for yourselves, and you're welcome. I would love feedback along the way. So thank you so much. And I really, it's a real privilege to be here. Thank you. Thank you.
Oh, thank you so much, Sarah. That was a great talk. Next, we have Vincent from the Minimax platform engineering team. We spent the last day talking a lot about agents, building agents, but what happens if you let agents autonomously schedule the amount of compute and resources they need, going one level above. So we'll be sharing a lot about that.
Can I use that? Wireless. All right. Hey guys, my name is Vincent Wu. I'm a product engineer on our API platform team, and today I'm going to talk about agents that manage their own compute. So the first thing is, sorry. Next slide. Oh, it's good. We're good now. Yeah. So compute is, everybody knows that compute is undergoing it's like one of the biggest commodities of the next century, and we're not using it very efficiently now. So the best way to see this is that I'm sure you guys know certain inference providers are blocking third-party harnesses from using their inference, and part of it might just be about competition, but really the main thing is that compute is very request dependent, in that different types of requests, different types of workloads have different strains on your compute. So for example, in particular, different types of input tokens and input and output tokens, your token profile, as we like to call it, have a major effect on how well inference providers can utilize their compute. So there was a recent podcast on Dwarkesh did with Reiner Pope, and he basically talks about the specifics of how inference workloads depend heavily on your token profile. And so this is the reason why it's going to make sense for agents to manage their own compute. Basically, if we can know, as an inference provider, if we can know a session's token profile beforehand, a priori, then we can serve requests a lot better, and we'll be able to essentially maximize our fleet utilization and to serve more requests to more people with less failure. And now, this kind of demand is a bit too much for humans to handle, because if you imagine, you're using Codex or Claude or whatever, and before every session, you need to tell the inference provider exactly what kind of workload you're doing, how long you're going to do it for, your token distribution. I mean, I don't even care about my token distribution. So this is too much to ask for humans, but it might actually be quite reasonable to ask agents, autonomous agents, to do this. And this is more of an observation, but agents are owning increasingly more of the harness. So from context management to tools, used to be hard-coded stuff by engineers, but now agents are basically managing these kinds of resources on the fly. But one thing that agents are not actually managing is their compute and their intelligence. So basically, we don't really give agents the ability to select, first of all, their models, although there actually we're seeing ways for agents to switch their brains when they want to, but more importantly, just their compute, like when they want to actually do the work and perform the inference. And so this didn't make sense before autonomous long-running agents, because when you're just pair programming with a human, there's not much to schedule. Basically, when a human is talking to the agent and they're programming, then you just want that inference right now. You want the work to be done currently. So there's not much scheduling to be done, and it's really just like greedy best effort. But as agents become more autonomous, as we hand them background tasks and have them do things in the background, then there's actually a lot of room to maneuver around scheduling your compute. So for example, if I give my agent like a deadline, I want something done by the end of the week, and I just give them a goal and a budget, right? So with those constraints in mind, the agent has, there's a lot of things that the agent can do to basically spread out the different types of work that it might need to do at different time intervals when compute is available. So a quick example would be, for, let's say your agent is just building an entire application. Well, maybe for the first planning phase, it doesn't need to hop into it immediately. It can wait for planning. It can, first of all, select a really good planning model that might not be good in implementation, and then have that model do the planning maybe like at midnight when the inference costs are lowest or when there's a high success rate. And then later on, maybe towards the end of the project, it needs to do quality assurance and it needs to like review its application. There, you might need to switch to like a really strong VLM GUI model and have it do low latency work to actually test the application in real time. So already you can see how like for different workloads, you really have very different token profiles and request profiles for that particular kind of workload, which might be suited to very different compute clusters. And so this is a recent blog post on Strategy written by Ben Thompson, and he's making this point by separating answer inference from agentic inference. Now, answer inference is the stuff that currently most people care about. It's when you go into your coding agent and you're pair programming with the agent. You want to see the outputs come out faster. You want it to think faster. You want like real-time latency. That's answer inference. But agentic inference is different in that actually for agentic inference, latency doesn't really matter as much. Because like I said earlier, you're really just handing off a goal and a compute budget, and a budget, like a dollar budget. And then the agent can sort of optimize around your budget and your goal depending on the resources at hand. And also I should point out that there's a sense in which answer inference is actually a part of agentic inference, because you could easily imagine how sometimes the model, the agent would still want to have low latency work done during its background period. Because for example, the example I mentioned earlier about like a GUI review of the application at the end, because you want real-time latency there, even though nobody's watching. So in the limit, we expect something like an inference exchange to start happening, where all these background agents, they're running out in the wild, and before their workloads, they basically submit their session information to the inference exchange. So the most importantly would be model used, and then token profile. So your range of the number of cached input tokens, uncached input tokens, and output tokens, and some other metadata along that line. And so then the exchange would match your session, the agent session, to the most optimized batch on the most optimized node for that kind of workload, in order to basically find the hardware that is best suited and best configured to serve that workload at that time. Now, the good thing about this is that just like any kind of market mechanism, inference exchanges are going to be able to turn underused compute capacity into user and provider surplus, because assuming optimal matching, then we're basically we're making the best use of the world's compute of any inference provider, and every GPU, their MFU is going to be maxed out because the workload particularly running on that cluster is going to be optimized for the configuration of that cluster. And then also fleet utilization in terms of like different time periods. So right now, providers are seeing this thing where like, for example, during the afternoon, they're overloaded because everybody's using their agents at that time. But then like during midnight, their GPUs are underused. And that's not good for providers because they want their GPUs to be running all the time. And so with this kind of inference exchange and with agents autonomously managing their own compute, we can have much better matching and basically smooth out the peak and off-peak hours. So overall, what this does for the inference providers is higher throughput per second. So the throughput of your entire system is going to become more optimal. And that's good for the inference providers because that's how they make money. The more tokens they can serve, the more money they can, the more revenue they bring in. But this is also good for consumers because, again, as I said in the beginning, right now consumers were facing a lot of issues where our requests are simply just getting like rate limited, or they're just not getting served well by the inference provider, and that's because they're not using their GPUs to the maximum, to the most optimal way. And so for consumers, what we're going to see is just better request handling overall, and also there's going to be a cost thing as well, because you can imagine how providers might decrease the cost for like off-peak hours, so that agents can are incentivized to go use that kind of compute for a lower cost. And we already see this for service tiers, for example. I think many providers have different levels of service tiers, low latency, high latency, batch, which have different pricings. And so finally, this is kind of a plug for our MMX CLI. So this CLI is not for humans to use. This is really a way for agents to autonomously call our model APIs. Because we have a range of models, from speech to image to video gen to, of course, our LLMs. And so for now, this is really just a way for agents to, effectively call our model endpoints. But in the future, we intend to build this out to be, to basically cater to what I said earlier about having agents manage their own compute more end-to-end and in a more sophisticated manner. So maybe they decide to run a bunch of video workloads at different periods of the day, and to save money and then to maximize compute. Oh, and that's it. Thanks. Oh.
Cool. Thank you so much.
You guys want us to scan?
Really appreciate it. That was a great talk. Next, we have Sid and Daniel, who will be introducing their company, The Robot Company. We've been talking a lot about agents, deploying them, coding agents, but what does it take to take an agent and deploy in the real world? And so they'll be looking at how to deploy teleoperated robots in a physical environment.
Testing. Hi. Is this? Oh, it's working. Good afternoon. My name is Daniel. That's Siddharth. We are from The Robot Company. We deploy teleoperated robots today for autonomy tomorrow. There you go. What you see in front of you over here are teleoperated robots deployed in an insect farm in Cambridge in the UK. So you see the little box of little squiggly things over there? Those are black crickets that are used to feed geckos and reptiles. You can imagine that not many humans like to work in this environment, which is why it's a pretty good use case for robots. I've spent the past year deploying robots in the UK. So apart from insect farms, also laundry facilities, food preparation, and hospitality settings. So we focus on deploying teleoperated robots And right now you might ask, Daniel, why deploy teleoperated robots? If you know, you know. A prominent researcher recently mentioned that teleoperation as a means for data collection is dead. And there are a lot of merits to this argument. Firstly, and I have first-hand experience of this, teleoperation scales linearly. Teleoperation scales one-to-one, right? One human controlling one robot, much like this. The other thing is that operator training is actually really difficult. I've trained about 100 operators, onboarded them. Only about 30 to 40% have actually passed onboarding, and it's really difficult to scale that. Another bit is with teleoperation, you get all the technical limitations of hardware, latency, and all those problems. And then the second piece of what we're doing, deployment is incredibly hard. You get new environments, which means new lighting, new tables, new dimensions, and of course, new customer demands. You get bugs. In our case, we get actual bugs because of the insect farm, but we also get a bunch of software bugs and malfunctions. And with any hardware, things break. So why deploy teleoperated robots? Before I get into our thesis, let me quickly go through how models have scaled and what that means for us. So very quickly, models have scaled, firstly with pre-training, so large amount of data, generalized intelligence, broad but unrefined. Then supervised fine-tuning to get the data, train on the model, so the model has task-specific specializations. Then a huge unlock, RLHF, reinforcement learning with human feedback. Humans provide the golden truth answer, and therefore the model gives really useful and good output. And all of this is underpinned, of course, by high-quality data. In the robot world, high-quality data, or data more generally falls under 4 buckets. If I point to you to the y-axis and x-axis, the y-axis is scalability, and the scalability is generally inversely correlated with data quality and hardware alignment. So on the left, simulation data, everything runs in simulation software, no physical world, no physical robot. There's a bit of a sim-to-real gap. Then you get egocentric data, essentially a camera placed on an eye level. That is pretty scalable as well, because it's not super complicated to do that. But generally, the data might not map directly to robot actuators and servos, so data quality is not super high. You get wearables, which is popularized by UMI, the Universal Manipulation Interface. That is pretty useful because you get joint positions or n-effector positions, and then you can do some physics and math to ensure that that maps onto a robot. So decent data quality and also decently scalable. And then on the other end of the spectrum is teleoperations. Teleoperation, very high quality data because the actual robot is in the field collecting data, but not scalable because one-to-one and also bring a robot everywhere is kind of tricky. Now, understanding models and understanding data, how do we get to useful deployment? How do we get to useful deployment and useful work? In the LLM space, what that looked like, and I'm being extremely reductive here, looked like an API call, right? Obviously, there's a lot more underneath that. But think about robots. Deployment is a lot harder and a lot tougher. How people have approached the problem robotics kind of looks like this, the LLM approach. Take data, take compute, and throw it in. Throw it at the problem, pre-train and SFT. And that has had really, really good results. Like recent models have shown really wonderful, promising results in the lab, often relying on simulation data, egocentric data, often with some world models involved. And that has had a lot of high-quality evals in the lab. But how do we achieve and fix the autonomy gap, not just in the lab, but in the real world? Our thesis is that we want to deploy robots in commercial settings. And that does 2 things. Firstly, when you deploy a teleoperated robot, you actually get real, useful work done for customers, right? So in this case, folding a t-shirt. But this process also does something extremely useful, that it collects very valuable data based on the work done by the robot. As we've learned from LLMs and self-driving, the most valuable data sets are a byproduct of real useful work done.
So that brings us to kind of step one. Actually, Shanice right here was supposed to give me a bottle of water, but deployment's hard, and that didn't really work today. But what I wanted to say was, we were basically trying to, we start every deployment by putting a teleoperated robot into real scenarios. So you can see the guys out here folding clothes, and you can also see Daniel doing a live demonstration of what that looks like. And above that, what you get is we layer it on top with your pre-trained models that you might be already familiar with. Think Pi 0.5, Groot, some of the models that Daniel already shared about. And that data that you get is essentially the highest quality embodiment data that you can get, right? And because the morphology matches, the environment matches, and the task also matches, what you end up getting is a very good base foundation data set for you to actually deploy commercially viable, robots. And you have to remember this, all of this is just the starting point, right? The real work begins once you start getting into fine-tuning. I think step 2 is the part where everyone in this room already knows how to do. You can take teleop data, you supervise fine-tune it on some of the models that you already know about, right? And you can kind of achieve about 80% autonomy. And we all know what 80% autonomy looks like. We've seen these on Twitter, on many social platforms. What you end up getting is a really beautiful video with some hype. And that works well when you want to garner attention. But once you start getting into the real world, and I'm sure that a lot of enterprise folks here, 80% just doesn't cut it for production. When you start getting 80%, when you hear 80% in evals, and we start getting to production, you know what that really means for the customer. That means that 1 in every 5 clothes falls on the floor of the customer site when they're trying to fold it, right? And that just doesn't cut it. So what you have now is really a gap that doesn't ship, right? And this gap is called the autonomy gap. You can kind of see Figured, they did a recent demonstration, a live stream actually, of their robot kind of sorting packages. It was very impressive. It was doing it for 8 hours. But they ran into issues too. And we believe a very specific mechanism, human intervention, real time, could solve this problem at scale. So that brings us to step 3, teleoperation plus human intervention. There is a terminology for this, and it's called telesupervision. And telesupervision basically involves the idea of someone intervening when the robot makes a mistake. You make fine corrections, and then you just let the robot do its thing. And you keep iterating every time it makes a mistake. And how do you address the teleoperation ceiling that we now have when you want to do this telesupervision? Well, we can start by scaling from 1 to 1 to 1 to 1 is to many. And this isn't new. The self-driving world has been doing this for a while. Waymo has examples of telesupervision, and we believe the same could extend to robotics. And the other side is remote teleoperation. We have a working stack that unlocks cross-border, low-latency teleoperation. This is an example of us doing a demonstration from Singapore to London. You can now extrapolate. You could do Singapore to the US, India to Singapore, China to Singapore, all under 100 milliseconds on our stack. Now, for enterprises, this is key, because deployment is hard, but it's very necessary. The long tail of robotics lives in the real world, and that 80% is the cliff's edge. So what we're trying to say is that teleoperation used as a deployment layer, combined with the menial, unpleasant, Saikang-like work that you need to do, right, is what makes successful deployments. And the way you need to do this is that you have to think differently. An enterprise cannot think like a research lab. In fact, you have to think radically differently, and you need to start with teleoperation as your fundamental starting point. And then you start collecting rich data, and then you start deploying commercially viable models and robots. And that brings us to the end. So that's what Daniel and I do at the Robot Company. We deploy robots that do real work today as we build the data engine for autonomous robotics tomorrow. So if you want to learn more about us, you can find us at therobotcompany.ai. Thank you.
That was an amazing demonstration, and I think it's just a testament to how complex it is to deploy robots in the wild. So we talked a little about how we can teleoperate robots, have people actually help. But what happens if we bypass that and go directly to the brain instead? And so in this specific portion, we'll be talking about, Justin Barr will be sharing about how you can do that with BCI, brain-computer interface.
Hello, everyone. We're just getting this started. Thanks for joining today. We have another interesting robotics experiment to show you. So we're getting there in a moment. But while they're connecting, I'll just get started. We've got lots of things to show you in the next 10 minutes. So get ready. But thanks again for making this happen here in Singapore. I mean, AI.engineer coming to Singapore is amazing. Having Agam and Sherry bring this all together with the 65 Labs team is great. Do you want to just hit play? That one that you just minimized. Are you guys getting this or no? Hold on.
Hello, are you getting anything? We did. Hello. Hello. Hello, are you guys getting anything? Hello, are you guys getting anything or not? I cannot hear you. Now I can hear you. Are you guys getting anything? Oh, only extended.
Yeah, extended. It is extended. It's extended.
Okay, now you get it, right? 2, 1. Okay, which one?
Okay, 3, 2, 1. All right, thank you, everyone. So as part of Tesseract, we've built a system we call this, it's called Tesseract.art. And what we've done with this is we've built a system that allows people to express themselves through AI. And this started out by having live music performance and turning that live music performance into a painting. But from that, we've kind of moved this much further along. And so I'd like to call out Kai Ming. Kai Ming, would you like to come out with us? And we're going to start rolling out some equipment. Thanks. Everyone, I just want to introduce Kai Ming. We've done some quite interesting and special things together for this. Thank you. And so for the last 2 years, please, everyone, if you can roll out. You guys going to roll out? Everyone? Sorry, we got lots of things rolling out. Guys, sorry, can you guys help roll out? Thanks. Okay. Sorry. This was quite difficult to do in like a 10-minute presentation when we have like a full robot system and painting and all this other kind of stuff. So please bear with us 1 second while this is happening. But as you'll see, we're bringing out a system that we call Tesseract.art. And what Tessa is, the robot arm. Tessa, the robot arm, we've been developing this over the past 2 to 3 years with a couple collaborators. My collaborator, Dr. Richard Savory, and I started this about 3 years ago. And we wanted to build a system that would allow us to be able to use robotics along with multimodal AI to be able to take one, let's say, creative form and turn it into another. And that's where we started with this in terms of bringing music together. And what we're doing with this is really taking human imagination and extending it through intelligent systems. And that's the intention of what we've done here today. Now, what we also have on stage, we've got Jackie also here from
Mind Interface Company.
And we have Ivy, who is also attending here with us from Tesseract. And Ivy, I might just ask you to come up and help. And so with Kai Ming, what we've done, and what you're seeing here live on stage, is the very first painting that Kai Ming has painted using brain control interface. So it might be hard for you guys to see in the back, but she's actually wearing a headband that comes across the front. It's a Muse, if anybody in the audience knows the Muse headband. But what's so fantastic and amazing about this is that this technology is now to the point where it doesn't take 2 hours of putting on a headset and like all this expensive equipment. We can literally put this on, and Kai Ming can just think about what she wants to do in terms of the control interface and actually make things happen with the painting. So Kai Ming, I'd love to ask you a couple of questions. Maybe you can just tell us a little bit about how we got here today.
Okay. Hi, so I'm Kai Ming. I have a condition called Ehlers-Danlos syndrome. So I'm part of the Rare Disorders Society of Singapore, which Justin has been working with. So I'm an AI policy researcher, and yeah, that's how we met.
Yeah, and so you've done some artwork in the past, and what we're now able to do is bring, let's say, some of your creativity back through this process of using AI and our multimodal systems. So what we planned to do was, we've been painting this painting. Maybe you can tell us a little bit about this painting. Do you want to move forward so you can switch the stage a little? Just so people, yeah.
Okay.
Can you hold it? Okay.
Yep, yeah, that's fine, thanks. So yeah, I've been painting since I was a kid with my granddad and my sister, who are both artists as well. And it's something that's really connected me with the world, and my condition has kind of made me lose a lot of my dexterity in my hands, and so I wasn't able to even write anymore, and I still kind of can't, and so I wasn't able to paint anymore. And I went into anthropology hoping to kind of live vicariously through it, and that's how I ended up in AI policy. But you know, I grieved my hands, I grieved my passion, and to suddenly have this outlet, it's just amazing that it's kind of been brought back to life.
Awesome, thank you, thanks, yeah. Okay, and so now for the moment we've been all waiting for is we're actually going to see if we can get, because literally we brought this, this whole thing has come together over the past month, so we're going to have Kai Ming try to finish one of the final lines. So with this painting, this is of Hope, the sloth from the RDSS. Did you want to speak about that? Yeah.
So Hope is a sloth that was born with only 2 fingers. He lives at the Singapore Zoo, and he's kind of like us. We take life kind of slow and steady. And this is a painting of Hope, the sloth, curled around a little finger. And the 2 colors that you'll see on the heart and the wings, that's the parents that we, who support us, rare disorder kids. And yeah.
Yeah, so there's Hope the sloth. So let's try it. Ready? Great, so maybe you can tell us the concept was here for there to be a heart that surrounds, yeah?
Yeah, so the heart, it's like, one stroke is the dad and one stroke is the mom, because, we often forget like how much the parents in our community support our patients with rare diseases, and they do so much. It's just incredible. And, I really want to thank Justin and his team for giving this back to us, this kind of freedom and liberty to do what we want to do with our lives.
Yes, thank you. Thanks so much. And I'm actually quite surprised to know that we have 3 minutes left to actually finish our conversation, which is great, because anyhow, so I think one of the things that's really become an inspiration from this, and what I think was the important message that I wanted to leave, everyone who's seeing this really for the first time happening, is we started this process thinking about using AI to give people creative superpowers, right? We want to not have AI take creativity away. We want AI to give people superpowers, AI superpowers, creative and fun things. And we did that starting from music. And what we've done now is pivoted towards the brain control interface and being able to make this wireless system happen. But you can ask, like, creativity, it's great. It's a part of self-expression. It makes the things that, you know, it's a very human thing to be able to express yourself and to have this form of communication. But what's even more inspiring, and I want to just show one thing as well, what's even more inspiring is what could we do with this type of technology? We talk about AI taking people's jobs away. What I see with this and our collaboration together is we're giving new opportunities for employment to people that perhaps have not been able to be employed because of maybe having a disability or not being able to be as mobile as others. So now imagine that as this technology develops, this is literally just the beginning of making these things happen. We could see employment becoming something because we need AI as, you know, AI in most of these systems today need a human in the loop, right? So if you can think about AI being something that is providing the opportunity to do something, you know, let's say it's a dark factory, it's all automated, but there needs to be people to supervise it. There needs to be people to do some of the work. And just today, literally through this process, I found out about a very special place that, sorry, let that build, a very special place in Japan where this is already happening. I literally just found about it today. So this is an avatar robot cafe. But what's interesting in this case is that the robots are fully managing things, but there are people making these robots work. And the robots are serving customers. The robots are serving customers, but they're actually they're employing people that are not able to leave their beds, perhaps, or leave their home to actually have gainful employment. And so I think this is a great, perfect use case example of the opportunity that could present itself with this type of technology as this progresses in the future. So I think that's a really amazing and inspiring opportunity to think about how AI is going to completely open up a new opportunity, a new workforce for people that might not have been able to be employed in the past. Anyhow, so thank you very much for having us. Really been amazing to be a part of AI Engineer. Thank you, Jackie, for making the brain interface happen. And any closing words?
I think we all needed a break from all the fear and money chasing with something a little bit positive.
Thanks very much. Thank you, everyone. Thank you, AI Engineer. Appreciate it. Thanks. Do we want to help you go off the stage this way?
All right, that was an amazing presentation. I think especially in the doom and gloom of AI, like that offers like so much hope. So we've looked at how you can use BCI, and for the next presentation, we're going to have Arvin from Bifrost, where they built synthetic worlds to train models. They've been working with some of the largest robotics companies in the world, helping them do things all the way to landing robots on Mars. They're backed by Sequoia and also the CIA Secret Venture Fund. One really cool fact is that the previous robot company and Bifrost are both Singaporeans, companies that were started, incubated, and really born in Singapore. And with that, really excited to have Arvin take the stage.
Awesome. Sadly, I do not have any cool robot demos for you guys, but that was pretty awesome. Hey guys, I'm Arvind, CTO and co-founder over at Bifrost. And today, I'll be sharing a little bit about the state of robotics, right? I'm sure you guys would have seen a whole bunch of cool videos online of robots dancing at like Chinese New Year, doing backflips and all these kinds of cool stuff. But on the other hand, you also see robots doing a lot of weird, clunky things where they're running into mirrors and just causing a lot of havoc, right? And sadly, this is what we consider the robotics development gap, right? Essentially what's happening is you're getting really, really good performance in the lab, right? It can do all these crazy things, but when you actually deploy them into the real world, what you find is that the performance of these models drop very, very severely, right? So why exactly does this deployment gap actually exist, right? So what you guys are seeing on screen, I promise there won't be a lot of graphs today, but they're like 2 graphs. This is the first one. What you guys are seeing on the x-axis is just all the different types of scenarios, right? And this is just your training data, your testing data, and your deployment data. And on the y-axis is just like the number of scenarios in your training data, right? So when you go out, you collect a whole bunch of training data. This is typically like what a distribution would look like. Of course, this is simplified. And then you have your test distribution, right? So you have a training data set, you have your test data set. There's some overlap, but there's some parts where they don't overlap. And then when you actually deploy your robot, what you find is like the types of environments and all the different types of conditions that it actually encounters in the real world, it's actually very different from the things that happen in the lab. In the lab, everything is very clean, very organized, but in the real world, there's so much dynamic chaos. There's like people walking into the scene, there's reflection from mirrors, there's glare in the camera. All these are what we consider out of distribution scenarios. And this is where robots fail, right? So, most people will say like, hey, let's just throw more data at it, like, the bitter pill lesson. There's more data, it should be better. But the reality is, a lot of the data that you actually collect from robotic systems, they're actually considered empty calories, right? Because they're not adding any new additional signal. A lot of the times, you're collecting the same scenario over and over and over. Think a self-driving car driving on a highway. You don't need more highway scenarios. What you need is more edge case scenarios. It's like a cow crossing a complicated intersection, a plastic bag that's right in front of the rear view mirror as you're backing into a car park, right? These are the kinds of things that you actually want, right? So in reality, when you want to be able to test these systems, you don't just need one small distribution or one small type of tests. You need to be able to go in and like get all these different types of distributions and cover as much of the scenarios as possible. So like every kind of lighting condition, every type of different spatial layout of the scenario, right? But getting this is really, really hard. And if you can do it, you can prevent failures from happening in the field. This becomes extremely tricky because now we are entering the age of generalist policies. Robots that are promising the ability to do anything and everything. Everything from packing your dishwasher, to folding your laundry, to even doing things in medical healthcare and science. And now, when you want to validate these systems, it becomes even more tricky, right? So in the field, we have a very simple way of like giving them like essentially like a reliability score. And this is the thing that most people care about when they think about deploying robots is, what is my true reliability when I deploy these systems into the real world? And reliability really just is, like you can take a success rate, which is, if I do the task 100 times, how many times am I getting it right? And you're also doing it across all the different scenarios that you want to be able to ship your robot for, right? So if you want to be able to handle like 1,000 different scenarios, you need to do that 1,000 times 1,000, and it scales very, very quickly, right? And all these companies are now racing. They are racing towards how can I achieve reliability faster than the competitors, faster than the market, and they're trying to figure out what's like the scaling law in reliability itself, right? So the first way they test robots is pretty straightforward. I'm sure you heard some talks where they will manually stage stuff. They will get humans, they will get robots, and they do everything in real time, right? They set up the scene manually, and they actually get the robot to do the thing. But in this case, the number of scenarios that you can actually test for is bottlenecked by humans, robot, and time, right? So when we actually put that on a graph, this is a different graph, but on the bottom axis, you're seeing compute, and on the other axis, you're seeing reliability. every time you do an inference, you're spending some compute, but you're still bottlenecked by how many humans you have, how many robots you have, and how much real-world time you have. As a result, you're still scaling linearly, right? But then folks come along and like, okay, I'm just going to sample a few different test cases, and I can get some additional new tests. It's good, but not great, because you can't get a lot of distributions because it's still manually doing a lot of stuff. And then folks say, okay, what if we remove humans from the evaluation cycle, right? So now folks are using things like Gemini. So Gemini Robotics, you can look at a scene, and it can give you qualitative feedback on like, hey, did it actually complete the task successfully? How far away is it? And they also have things where you can auto-reset the scene using another large vision language model, or vision action model as well, right? So they've removed humans, but you're still bottlenecked by how many robots you have and how much time you need, right? So it becomes a bit slightly faster, because now you can spend a little bit more compute and speed it up, and you don't have to be reliant on humans as much, but you're still scaling linearly, right? And what this means is you can just do slightly a few more tests. And then, of course, when we build bridges in the real world, we test it in simulation first, and then we build the bridge, and we do all that simulation for like mechanics and like tension and stuff. Why not do the same for robotics? So in robotics, there's a thing called sim-to-rail gap, which is when you do things in simulation, they don't always line up with reality, right? And this is like a big problem that the industry is trying to solve. And surprisingly enough, in the last year, we have a lot of new ways to solve this. And the biggest one that we are working on is actually using the real world to generate the simulator itself, right? So what that actually looks like is you can take in real data, right? So you take in real data into the system, and you can generate things from that real data, and then you can re-simulate the world from that, right? So this whole idea of you are generating a simulator specific for your domain and your thing every single time, right? And it's not just objects. You can generate entire worlds for your specific domain. For example, if you're like off-road self-driving car and you're operating in the California desert, you can very quickly generate that entire world and train in that simulation. Right, so this is how you begin to close that sim-to-real gap. And what this allows you to do is it allows you to copy the distribution of your actual test set and have a simulated version of it. And this is already valuable because you can now do closed-loop testing with this distribution. But how do we go even further, right? This is not great coverage, right? So let's just take one specific scenario. So like this is an example of the type of data we generate. Here it's like a boat is driving to a crowded marina. The glare is in the screen, is in the camera, and everything's a bit chaotic, right? But this is just one specific scenario. How do you scale this up to more scenarios, right? So what we can actually do is we can go into the simulator, and we can parameter sweep across all the different operational conditions. And it's almost as if you're seeing 1,000 different realities very, very quickly, and you're testing the model against all these different realities simultaneously, right? And from there, you can expand it even further, right? So it's not just a n times n test. You can scale it up to a lot of different domains and criteria. And the cool part about this is that you can test your AI model against it. And you can immediately see where your AI model will be failing even before you have shipped your robot into production. And the whole idea here is simple, right? Fail fast in simulation and use those failures and direct them for real-world testing. So you're not testing on every single thing, but you're testing very specifically on the places where you failed in simulation. This way you spend less capital, you're more optimized and efficient with the resources that you do have as well. And we're just limited by real-world time as well. Right, so we go from this to this, because now we can cover a much, much wider domain. And there's a term called like domain randomization, but basically you're covering a much wider domain than real data could ever possibly cover. And it's a very good way to do these tests. So everyone, I'm sure, would have seen this thing called like the data flywheel. It's become a meme at this point where every company is like, yes, we have a data flywheel. But a flywheel doesn't actually capture the most important thing. And the most important thing is you actually need to refine this data. The data needs to be super high quality. You need to figure out a way where you're finding the most valuable things, and you're also being able to drive what you should collect in the real world as well, right? At Bifrost, we help some of the world's most demanding customers do this at scale. And we are essentially taking all of this and we are simulating it in your browser. So we have a world, you can simulate the world, and you can break your AI model inside of it. Thank you, folks.
That was an amazing talk, especially talking about like a data refinery, trying to basically make sure that your data like covers all the different edge cases. So I'm really excited next to have Julia Kim from OpenGraph Labs talking about how they built an in-house stack where they've ensured that you can sync the data collection across different multi-modalities. And this is really difficult because even microseconds of drift when you're collecting data for training robots can end up being really damaging when you actually take this and you train your models. So really excited to see how that goes. Well, we sorted out a bunch of these technical difficulties. I'm wondering like how have you guys been finding like today's conference? I think personally for me, it's been like absolutely like stunning. Like I was really blown away just now when like Justin demoed the ability to paint, just using like a brain control interface. Like I never thought that was possible because I've only been playing a lot with agents, right? I see like text in, text out, like oh my god, like we're gonna just everyone's jobs are gonna be automated away, and it's really cool and inspiring to see like AI being used for good. And so I think like that's been something that's been really exciting to see, just the sheer diversity of like opinions and projects that people are like working in.
We probably need to create AI solutions for presentations maybe at some point.
I think so.
We can do that next year. So a bit of a fun fact, a lot of the stuff we actually used for the conference, we did actually build ourselves as a team. Using a lot of the tools that the speakers and sponsors have built. So we'll take that as a note. Oh, okay. I think we're back. Yeah.
Oh, we got to drag it a bit more.
Drag it? Yeah, it's extend. So.
We had it just now.
Oh, it's back. It's back.
There we go.
Woo! Yeah. Okay. Good.
Yeah, thank you.
All the best.
Hi, good afternoon, everyone. Good afternoon, everyone. My name is Julia, co-founder and CEO of OpenGraph Labs. Today I want to talk about how our everyday human experiences can actually become useful training data for next humanoids. So, how many of you have heard the term egocentric data? Yeah, I can see a few. Or maybe you've seen this viral video recently at apps. Factory workers are wearing the cameras on the hats while they're working. So over the last year, something very strange has been happening in the field. Hundreds of companies have started collecting the human behavior data at scale. People filming their first point of view cameras doing their daily task and actually get incentivized for doing that. So why are we doing this? So why did humans suddenly become the core data sets for robotics? So this is because we just got the proof that it actually works. NVIDIA's recent ego scale research showed that scaling human egocentric data actually helps the robot training. So they do use the egocentric video as a pre-training data set for their model and fine-tune on a human-robot alignment data set also with a few teleopted robot-only data. And the robot can actually do the task like folding a shirt with a one-shot transfer. And as the same way the language model scaled with putting more data, they also show that it also can be workable for AI, physical AI too. So it showed a significant scaling law. Not just because it was proved to be useful for pre-training, but actually, to be honest, the egocentric human videos are fundamentally very important with two aspects. First, we are now building the human-level capable robots. That means that same form factor, they look like us, and similar degrees of the freedoms. And that means that we are trying to minimize the embodiment gap between the human and the humanoids. And it's actually getting closed very fast. And as the gap closes, the human behavior actually can be directly transferable to the robot, which is the most direct supervision signal possible in the world. And secondly, the egocentric data is captured in the real world, as it actually is. The physical world, as we all know, is continuous, is dynamic, and physically grounded. So every data we got from the egocentric data is actually very, very high fidelity data, and it includes the much more information that any robot could ever learn from. But then, are we really done now? So we can just have more egocentric video data and we can solve all the problem? So simply collecting enough human video data, there is some bet, will robot eventually achieve the human level physical intelligence or not? Well, I do think that this actually depends on which future you are building towards. And that future defines the level of intelligence we might need for robots. So one future is robot as a utility. So tools in the warehouses, arms in the factories, machines that do the task, but they don't share the space with us. And the other future, robots that actually live with us, they fold our laundry at our home, and that also help our parents to companion our parents, and they hand us the glass of water, and which means that they actually share our words. And if we want them to live with us, they need to be physically intelligent. So they need to learn the word the same way how we did. So then let's go back to something very fundamental. Think about how did we actually first learn the word? When we were babies, we grasp the things, press the things, and drop the things, and touch the things, pull the things. Sometimes, or actually many times, we actually put something in our mouths to taste it. We learn the word by interacting with it. And we learn through the actions and feedbacks, through the touching the word and observing how it actually responds after my actions. And this is what we call the sensory motor learning. So the nature question follows that if human sensory motor learning itself is what forms our physical intelligence, then what if we could do the same thing to robots? We let the robot learn the same way that we learn as a babies. So again, this is the same baby from the last slide. It's actually producing and generating all of these sensory motor signals at once. Vision, touch, proprioception, audio, action, and feedback loops. And through those interactions, the baby gradually learns the structure of the physical world. So the question becomes now, if we could capture all of this data and use as a training data set for robotics, we can let the robot exactly mimic like us and learning everything on top of here. And yes, I truly believe in the future, and we can achieve this by sensorizing the humans. Today, many parts of the human sensory motor loop are already becoming very measurable. We already have the vision system captured through the egocentric cameras. We can also reconstruct the motion information directly from the video, and also proprioception, like a 3D hand pose, wrist pose, and trajectories, body motion reconstructions. Those are also can be reconstructed from the video. And audio is also very naturally captured through the camera system. So now it's very obvious that to see that only one critical modality now we are missing largely is the touch. And for physical interaction, as we all know, touch may be the most important signals that we should collect from the real world. So one reason we still have very little touch data today is that many other human signals are already capturable and interpretable from first-person vision alone, so the egocentric video. So with egocentric cameras, we can already infer motion trajectories, hand pose, body movement, action structure, and even proprioception. And honestly, this is probably the moment to thank decades of the progress in the camera hardware system and the entire ecosystem built on top of the standardized RGB system. Because once the world converged around the RGB cameras, computer vision became scalable. And now we are right now waiting for that exact moment for the touch, because the touch never had that moment yet. So we have to follow how the vision system improved. How vision scaled because they were converged around the one thing, the camera, and the RGB pixels. We also need a unified hardware stack that everyone could build on for touch data, and also build a data infrastructure which share the same format of the data. And this is why we exist. OpenGraph Labs is here to build the standard for touch, the missing piece of the sensory motor system, so that with this, and we can finally leap forward in robot learning. We enable this with two main layers. First, the highly scalable hardware that produces the high-fidelity context signals from the fingertips. And secondly, on tactile encoder, which is an interpreter built on top of that hardware, ingesting the tactile signals and turning them into meanings. So with a high scalable hardware, we are able to capture scalable data set, and on those data set, we are now able to build a meaningful encoder, tactile encoder. And so we've just started building a complete pipeline for capturing the full human sensory motor loop, making it trainable for the first time. Thousands of people, millions of interactions, every moment of contact between the human and the physical interaction can be now captured, digitized, and ready to be taught for the next generation of the robotics. Let's train the humanoids by sensorizing the humans. Thank you.
That was sick, talking about scaling out human data collection for touch. Now, a huge part of actually collecting data is that we actually need to scale out the data operations, right? We don't just need to collect the data, we need to ensure that we have the operators, we have that entire infrastructure and logistics handle. And so we have Suveen from Cortex, where they talk a lot about how they do this at scale with robotic and other forms of data.
Hi everyone, I'm Suveen. I'm from Cortex AI and I'm a founding engineer there. Today I'll be speaking about some of the cool things we got these robots to do, some of the challenges we faced, and some of the lessons we learned. Here you can see some of the robots that we work with. We mainly work with bimanual robots doing manipulation tasks, and we also work with mobile robots doing tasks in more realistic environments like convenience stores. And you might wonder how these robots got so smart. Even in this clip, you can see it's pouring the last drop of milk to the cup. Actually, these learning systems, they just take pixels in and they output actions. Usually, we have a top camera and wrist cameras. We also passed in the joints data of the robot, a simple language instruction. Then the model will predict some actions. we execute actions on the robot, you go to the next state, and the loop continues. This diagram is actually a really good way to think about the modern robot learning stack. You have camera views and joins as data. Software is powering data collection, training, inference. Hardware is arms and cameras. Models are what policies that we run. And to test if these policies are working, you need evaluation. And to make this happen again and again, you need a good operations layer. Robotics is often regarded as a hardware problem or a model problem, but it is also a huge data and operations problem. Recently, we worked with Allen Institute for AI on their Molmo Act 2 paper, and we collected over 700 hours of bimanual YAM data for their data set, and it is the largest open bimanual data set to date. And we collect our data through teleoperation. Here you can see my colleague. He's controlling what we call leader arms, and the follower arms will copy the motion. And even though it looks fun, it's actually very hard. The main reason is human intuition. It does not transfer really well to a new embodiment. You know how to grab a cup with your hand, but when you have to think through a robot arm, it's really hard. But it's a learnable skill. And not just that, there's a lot more to be done before you start collecting data. Even the simplest task of folding a towel, you can fold it in 2, you can fold it in 3. You have to come up with a task strategy. After that, you have to practice the motion. Then you have to make sure the data collected is consistent across episodes and across different operators as well. When we started scaling these data operations to hundreds of hours, we realized some small workflow changes we added, they started to compound. Initially, we had the friction of waiting for 2 or 3 minutes for each episode to be encoded. Then we moved the encoding process to the end of the session. Then suddenly, the whole encoding duration is much longer. Now we had to wait for a good 30, 40 minutes before we start the next session. Then what we did was we made a small code change. We disconnected all the hardware, so you can run a new session while the previous episodes are being encoded. And what ended up happening was data collection and encoding and uploading processes, they became completely decoupled. Another thing I want to talk about is how breadth matters in robotics. By breadth, what I mean is being knowledgeable across different layers in the stack and being able to operate up and down in the robotics stack. The reason I'm saying is I've realized the problem space and the solution space might not be in the same layer in most of the times. And the more intuitiveness you have across the layers, it's much easier for you to solve problems faster. Let me explain this with a few examples. So when we started running policies on these robot arms, there was a task where the robot had to grab a jar, and the grippers broke, and you can see the clip, the grippers flying off. And I thought, OK, maybe the model learned something wrong, or I could just lower the gripper's force from code. But my colleague, he said, OK, let's just design our own gripper. We were working with third-party hardware, but we could still innovate on top of that. And this is a good example of a hardware solution for a problem which I thought is in software. Similarly, whoever worked with these cameras, they get disconnected often, and you unplug it, then plug it back in, then it starts working magically. Then one of these times, one of our operators tilted the camera accidentally, and the top camera view was off. So all the data we collected that day, we had to throw away because it was not in the correct view. And we were trying to make sure the camera mount is more rigid, but I vibe coded a script, a tool, to check if the top camera view is good. So what we did was every session, we take 2 or 3 minutes at the start, then we check if the camera view is correct. Then we can make sure the data we collect is actually good. So this is a good example of a software solution for a problem that we thought is in hardware. That's why moving across the stack and thinking from all these layers actually helps a lot. I also want to talk about why evaluations in robotics is hard. Similar to software, you can evaluate robots in simulation, and you can parallelize that. But real world is where things get messy. For example, lighting could change. There could be distractors. There could be actuator and camera noise. So you have to account for all those things. Recently, when we worked with when we work on Molmo Act 2, we ran thousands of real-world evaluation rollouts across 5 policies, and that taught us like how hard of a problem this is. So when you run real-world evaluations, this could happen when it's a failure, and it would happen again. In robotics, after you run every rollout, you have to reset the environment manually. Not like in software, you can run parallelly. You have to manually go and clean it up if it makes a mess. And I've done this hundreds of times, and I can guarantee you it's not fun. Then we realized it's very expensive to do this all the time, but that is the gold standard as of now. Another hard thing about evaluation is when a robot fails to do something, it's really hard to figure out where it fails. Let me explain with a few examples. It could be the data. Maybe different operators use different strategies. Maybe I folded it in 2. Someone else folded the towel in 3. Maybe it's a training setup. The adaptation you wanted. For example, LoRa versus full fine-tuning. Then it could be the setup. I've had scenarios where I tried to load a model, and some part of the model got initialized with random weights, and the model is like going haywire. And it could be the wrong action chunk size as well, compared to the size that you used in training. And maybe the evaluation setup itself could be wrong. Maybe you're trying to evaluate in distribution, but the placement of the object is slightly off. Lastly, I want to talk about safety. This clip is something I accidentally recorded. You can see the joints doing a 90-degree in less than half a second. And if someone else's hands were there, they would have gotten hurt. We really talk a lot about robot safety when it's deployed, but I think there's a lot of safety concerns when it's developing as well. I can say, like in data collection, if the leader arm suddenly dies, which happens sometimes, the whole weight might be on the data operator. In evaluations, we had cases where we are testing a task which involves test tubes, and one of the robots, they broke the test tube, and you have like glass pieces going around. And stale action cues that might lead to sudden arm movements, which is also a safety concern. And there's much more like this. I also want to talk about running AI-written code on robots, because especially AI coding tools are becoming mainstream. To give context, one scenario that we use AI coding tools for robots is basically when we are using LayRobot. We are a huge fan of LayRobot from Hugging Face. So when we want to adapt that library to robot arms that we work with, there's a lot of scaffolding, a lot of interface work that we need to be done. So we use AI to do that and move faster. But when we try to run it, we run it like it can fail. We do the normal software checks, fundamentals, normal PR reviews. Then we try to check in simulation, and we try to test in logs. You can send the actions to the robot but not execute them, just look at the logs first. Then when you want to test it on the actual robot, you can just move one joint at a time. You can slow the speed down. Yeah, these are some of the things that we follow. Yeah, one thing I want to emphasize is that you don't have to be an expert in every layer of the stack, but if you have more knowledge about different layers, it's really easy to solve problems and move faster. That's it from me. Thank you.
Okay, everybody. That is the conclusion. Thank you, Suveen, by the way. Thank you so much. This is the conclusion of the first half of our afternoon for AIE. You guys have done great, being so engaged throughout 9 to 6 p.m. of like programming for the last 2 days. We're in the home stretch with more really cool talks that are coming up after the break. A lot of the most cracked startups around the world are going to be sharing what they are actually building. A lot of them are actually my Twitter friends that I've known for a while, and I got to invite them and meet them in person, which is also very cool. So please do stay for that. And while this break is happening, I want to give a little bit of context to my friend there in green called Keziah. Just wave. So Kazaya is someone who has a day job just like the rest of us working in consulting, but she is also a mindfulness coach and wants to find a way to be able to bring more people into that kind of practice, especially in spaces where there's just so much going on that a lot of us can feel things like overwhelm, anxiety, and just want to find a systematic way to be able to take a pause and just be able to kind of slow things down a little bit. And that is why we wanted to create a little bit more of a curated experience for the breaks versus putting up AIE logo and some music and let you guys have coffee, right? We want to put thought into every minute of the programming, so that's why we brought her on. But I also want to share another story about how this all got started, because I think it's very much in the spirit of AI engineer and this changing definition of what a builder and engineer is. Kazaya actually, with no background in coding, actually vibe coded this entire experience. She found GitHub repositories that helped create the particle visualizer on the screen that you're going to see. And she did that all in the last 4 weeks. I mean, I think we kind of pilled her on AI, and then she just went ahead and decided to build it. So I couldn't be more happier seeing people who are in all different kinds of spaces, industries, being able to be empowered with these tools and just create these amazing things, right? And all of this is possible to be able to connect things like meditation and mindfulness to an actual tech experience that we get to be able to show on stage today. So do kind of enjoy the next 15 minutes or so, to kind of slow things down and get that little less reserve of energy before we finish off the day. Thank you.
with our programming really quick, and while our next speaker, Jay, sets up, it's going to be an incredible talk. I've been looking forward to it. I spoke to Jay a little bit behind the scenes, and this is a talk about humans, about the human side of AI, where if you may work in a team and people are wanting to get in on AI, they're wanting to level up, they're wanting to design for other humans. Oftentimes, we end up with generic prompts and generic results, and we may not even know how to really get the most out of it. And so this talk from Jay comes to us previously from Canva, ex-Canva, is going to talk to us about that, and I'm very excited about it. So if you're ready, if you're feeling restored, is he ready? He's not yet ready? No? He answered me. He just said no. That's so nice. I can kind of see no. While they get ready, how are you feeling? You good? Show me by applause level. Okay, that's nice. Very good. That's good. I'm happy. It's a good conference. And it's sad that it's almost coming to an end. If you want more, even after the end, to say, "Aw." You don't want more? I don't think we won't do it next year. How's that? I'm joking. I'm joking. It's fine. They're freaking out backstage. Can he say that? I don't know. We gave him a mic. This is going to take a while, huh? This is the worst part about being an MC. Now I've got to think about entertaining you all. But that's easy, right? Hey, thanks. He said, what's your name, sir? Ari? Art?
Test.
His name is Art? Jesus, the guy's a piece of art. You ready?
I think we're ready, man. Let's
we're
go.
Ready. Your biggest round of
Singapore,
applause.
let's go, baby. What's going on? Wake up. Come on, baby. I'm Jay. I used to be at Canva. I used to work at Grab. How you doing? Today I'll be talking about prompts don't have opinions. You do. So for context, right, I'm really tired of the bullshit that's being put out there. Prompting ain't ish, but slop and tricks. So I have my notes on my phone. If I'm looking at my phone, it's not that I'm looking at an agent, but I'm looking at my notes. So I'm tired of these design influencers, these leaders, these people that have positions and high power that talk about the design process, yet they haven't done anything or shipped to millions of users. Like Jon Snow, they know nothing. So take it from me and the people here who have actually built something for millions of people. And let's talk about this. Oops. So historically, right, I think there's a parallel between AI and actual products that have been built. So General Mills, a baking company in the States, in 1947, they released a cake mix. And people weren't really vibing with that in general. And when they added an extra step, just adding an egg to that instant mix, people were invested. They felt like they were creating, which is so interesting, right? Because it's the same with AI. I think for anybody that's designed for AI in general, people create value when AI outputs it and helps them, right? And it's called the IKEA effect. People are going to be invested when AI is actually collaborating and acting as a partner. And it's fascinating with products that you've seen out there, whether it's Canva, Google, Figma in general, you let people have the choice to either use AI or edit or generate with you. Some people, obviously a little bit hesitant. You see it with them not trying to use tokens, but it's fascinating, right? Oh, it's gone out. Is it because? All right, awesome, amazing, cool. We're back, I hope. Keep it active. Oh, we're down.
When something like this happens, just give him a huge round of applause to not make it awkward. There we go.
It happens, no worries. So I'm gonna keep going. We're good? Awesome. So how do I work with AI, and how do most people work with AI? For me, as a designer, I use it as my intern, not my art director. So you've probably seen this video on LinkedIn. It's fascinating, right? People are token maxing and using all their tokens. It's sloppy. And it's the same with Claude Code in general, right? You use up all your tokens, you get upset. You're like, oh, dang, you lose all my credits. It's expensive. Why would I want to build? So I guess I would ask most people, right? Would you delegate decision-making to a human expert or AI? I guess when you're designing for real people, and I encourage people to talk to people outside of the tech bubble that you're in, because average people are hesitant to use AI. So if you frame it in a way where people are actually spending less time to think about things, then people are more inclined to potentially use AI in general, which is fascinating, right? And they did a study on this. People are more inclined to use AI when you frame it as a loss of time and speed in general. And we did this, right? So for me, I built Canvas Sheets, AI-powered spreadsheet, and it's fascinating to me when there are other competitors out there that still use this hashtag error, and it doesn't really communicate what's actually wrong. And if you talk to normal people that use spreadsheets on a daily basis, they're overwhelmed by this, right? So at Canva, we tried to make it easy for someone to use formula, and we give them and talk to them as a human being to give them a suggested fix, which is fascinating in itself, right? And it's the same with the voice assistant stuff that I've done as experiments as well. AI builds the happy path, as you've seen. Humans break it. They don't care, right? And you can't prompt for environments, whether you're outside, dealing with road noise, babies crying, right? And it's unfortunate, because I think a lot of people, if you've built for voice, it's so expensive to go on the wrong path. And if you've ever done it before, it's just hard to do in general. So AI can't solve everything. So I encourage you to think outside of the data set, right? I think this graph you've probably seen a lot. So when you're designing, if you're an entrepreneur or even designer or creative or dev, think about what is the driving innovative competitor advantage that you have. And who drives that? Design. Design has always driven this value to have an advantage on competitors in general. So James Dyson is also a good example of this, right? He's prototyped 5,100 vacuum prototypes, if you read about his story. And he didn't get a call until one person took a chance on him in general, right? The same with Apple Keyboard. A lot of people hate it, but you have to remember, they had to think about the smart shortcuts, the things that people would say, different countries, different words come up as well. And the team, I'm sure, went to Steve Jobs and iterative continuously on this just to get to the spot where it is now, right? And they have to consider, right, who they're designing for, the world, these new add-on additions as well. So designed outside the data set, right? So I feel like, and it's related to what Josh Newton talked about earlier, AI speeds up the loop. It doesn't replace design, craft, or judgment in general. So for me, right, I teamed up with a designer at Canva. Oops, oh no. Again. Classic. All right, cool. Hey, chill, we got this. So when I was at Canva, I designed columns and layouts. Shout out to my boy Simon Lin in Taiwan, who's a legend, who also helped with this. And these are complicated interactions, right? Not everyone's going to get this. So when we went to ground, talked to real users with real prototypes, we had to think outside of the data set. So AI can't solve complex interactions, complex products. You still need to talk to real people and actually test with things that AI can't potentially generate or think about. So it's the same when we're working in workshops as well. We actually build code templates. What does that mean? Well, we build code templates of our products, and it helps people get into Cursor, get into Claude, and actually build ideas during workshops, brainstorming, and it empowers everyone, right? We as designers should not gatekeep in general. We should empower everyone to bring their ideas, build their ideas through AI so we can prompt and actually test this on the ground, which is really important. So it's the same with smart homes and voice as well. It's very fascinating to see where Huawei is going with the future as they look into smart homes, think about voice and being contextual, because AI, again, can't be reactive. It has to learn. It has to be trained. So how do you think about this and have a smart system that adapts to normal people's behavior? So lastly, build the world that you want to actually live in, designers and devs and folks that are here, especially entrepreneurs, right? Because people are investing in experiences, and design is going to be that lever that pulls things forward, right? And CTO at SpiceJet India, he even talks about it. AI is very expensive right now, but the overhead of hiring people is cheaper, which is a fascinating quote, especially in the age of AI. So final hot thoughts and hot takes before I end today. Mute the trash on AI design on social media, because there's a lot of bullshit out there, to be honest. Talk to people outside of your networks and bubbles, because the average person is actually pretty scared of AI right now. And of course, it's out. It's fine. Users don't care if your product is better, right? They don't care if they have a cool feature that's better than your competitor. You need to actually design for these people and their needs and be contextual. And finally, to the design leaders out here in this region and to the world, I think you have to give space and time for people to actually adapt to AI. I've heard too many stories about designers that have actually been called out for not designing enough screens, being bullied by these poor design leadership because they don't know how to use AI, right? I got told that my work doesn't matter, but guess what? I designed a product that went to millions, so I don't know what they're talking about. So to be honest, right, I think it's important to empower your team. So last point that's not up on here, Christina Koch, she went to Artemis spaceship, obviously, around the moon. She talks about finding your crew. So I encourage you to find your crew, your networks here. Feel empowered, feel connected to the network that you're adapting and working with in AI, because it's important, because in the world that we want to be in, you don't want to be anti-AI. You need to be AI fluent, just be anti-bullshit. Thank you.
Woo, give it up! Be anti-bullshit. How many of you are anti-bullshit? I tell you what, I am. Wow, you like bullshit, the rest of you, huh? Anyway, please give it up. We have a co-MC. Check this out. It's Usman, everybody. Woo! That's right, Usman. Less than half my age. I won't tell you what that is. And he's so active in the local community here building. What's the last thing you built, bro?
The last thing I built was like a, religious app,
yeah.
Right? Like how you built one.
Yeah.
Mine is for Muslims all around the world, and how you can track your prayers and like all of the different surahs in the Quran, which is our holy book,
Yeah.
similar to your Bible.
Dude, that's so cool. And you built this?
Yeah, with Google AI Studio.
Let's go with Google AI Studio. Give it up. Like a builder. How old are you?
I'm 13.
He's 13! What? That's the future. One last question while they set up. What's the experience like building with AI Studio? Like, are you just prompting things? Are you writing code? Like, what's the...
Well, of course, in the beginning, right, I couldn't vibe code at all. It took me probably a year or two to really figure things out.
Yeah.
And I've come to a conclusion that vibe coding is not that hard. You just need to put in the hours.
That's right. You just need to put in the hours. Fantastic. So you're introducing the next speaker. Is that right?
Yeah.
Let's do it. Give it up, everybody!
All right, so now we have Alyx Lee, who has come all the way from San Francisco to Singapore. And he's come to introduce how AI needs design systems. Currently, the users, like the AI Studio and all that stuff, the designs are horrible. I'm gonna be honest right now. We want designs that actually match the user's brands. Give it up for Alyx Lee.
Oh, you need the mic? Sorry, guys. It's like, how is he supposed to do the talk without the mic? Alyx. One more time, everybody, for Alyx Lee.
Thank you. Thank you, everyone. Okay, perfect. The slides are here. Yeah, I'm Alyx, one of the founding engineers at Magic Patterns. Actually, just want to get a quick poll. Has anyone actually heard of Magic Patterns before? Raise your hand. Oh, actually, there's a couple of you. Super cool. For those who don't know us, Magic Patterns is an AI design tool that gets you from idea to production in a matter of minutes. We've been used by over 2,000 product teams, KPMG, RAMP, et cetera. But I mainly work on design systems. And so, in the world of AI, it's been much easier to build new features and new functionalities. But the hard thing we still have is consistency. And so I'm here to tell you why design systems have not only been needed even more, but are crucial in the AI world today. And so before I begin, let's talk about some history about why design systems are even needed in the first place. So before everything, the world, or the web, was the Wild West. Every page was different. It looked like your MySpace page with different widgets everywhere, different buttons. Designers had to re-implement, engineers had to re-implement, and there wasn't really any shared systems in place. And so to restructure this chaos, we have design systems. It's a shared language that your product teams can use. You have your tokens, which represent your colors, typography, your spacing. And thanks to Brad Frost's atomic design, we have a great hierarchy and nomenclature for components. We have your atoms, the buttons, labels, inputs. We have the molecules composed of those atoms, maybe your form modules or your search bar. And then we have the organism level components and templates to create larger things like your sidebar or your dashboard layout. And so the promise was simple. We had consistency, speed, and scale with the thanks to design systems. But maybe things were a little too consistent. Maybe, instead of, it took a lot longer to add a new button into the design system. There's bureaucracy now. You have to ask the team, can I add this new thing into this layout? And so we weren't thinking about things from first principles. It was not about how do we solve the user's problem from the ground up, but it was more, how do we use the tools in our design system or components in our tool shed to solve that problem? And that rigidity was not that helpful. And so the industry took a step back. Design systems can be a little too enforcing. And so let's think of things more as a framework rather than a set of rules. Instead, this way, you can have that creativity, but still have those guardrails in place to get your consistency in your brand, whether it's your typography, colors, logo, images, and set like that. And so finally, we were at peace. We have a way to build creatively, but also with guardrails in place, and nothing disruptive ever affected the tech world again, right? Man, I feel like in even the last 6 months, my workflow has completely changed. I'm sure for every one of you, I don't even write code anymore. I just ask the agent to write it for me. I'm sure for design, product management, everything has changed as well. And I think it's interesting, right? The cost of implementation has now become basically free, especially if your company is already paying for those Opus 4.7 tokens, right? And so the questions change from, can we build this? How long does it take to build? To, do we even want this? Do we need to do something we want to add? We want to maintain this. Does this new feature use the components in my design system? Is this a new feature aligned to my brand? And so with that, we have all this chaos that AI has created for us, and we go back to why design systems were created in the first place. And specifically, we need those guardrails. And so this is what the AI is, in the world of AI, without that context, you specifically have things that are not necessarily to your brand, right? Things get hallucinated. You might have components that are hallucinated. You might have colors that are not to your brand guidelines. And overall, you really need those foundations and context to make things work. It's not just your Figma mocks. It's not just your storybook. Not even like a design.md. We really need context to align our agents to build things that align to our brand. And so we came up with a solution on our end, which we call the AI native design system. Obviously, there's not that much difference to a normal design system, but the key things are now that we have two pillars that this design system relies on: your documentation and your code. You have your system level rules, your tokens, like I mentioned, your color, typography, spacing, and then your components, but specifically backed with code. Because the more code aligned your design system is, the more close it is to what your users are actually seeing. And this also allows the agent to understand the props, the variants, the way in which to use those components directly. And so what does a real world example of this look like? Here's one of our customers, Headway. Headway is a mental health platform that helps people find licensed therapists. And they already had a design system, and so we helped sync it for them. We took their documentation and their code and created the same structure that I mentioned before. Storybook, as a source of documentation, lends itself to system-level rules and component-level rules based on stories. And then their actual code ingested either as an NPM module or synced with GitHub for tokens and, like I mentioned, those components. And it's crazy because I can't show this in a live demo because it might take too much time, but the differences are stark. I generated these ahead of time, but with the same generic prompt of build me a dashboard, you get something completely different. Without a design system, you get something that works with your UI, right? Or it's a nice generic SaaS dashboard, but does not fit with maybe your brand or your product. Same prompt, with that design system context, this matches really closely to what Headway's brand looks like, right? We have our logo, we have our components, colors, typography, all matching in place. And now we're actually able to ship really close, high-fidelity code, even with more simple prompts. And now this completely also changes what that design to engineering handoff looks like. Right? In the old world, I had this Figma mock. As an engineer, I would have to look at it and check my storybook, see which components that aligns to, make sure the color tokens are correct, right? And it was very hard, and I had to build everything from scratch. But now we're not even working with designs anymore. We're working with code-backed prototypes. And because these prototypes are using my actual design system components, I can hook it up via an MCP to something like Claude Code, Cursor, Codex, and just be like, oh, prototype tool, design tool, give me this design, make a new feature out of it. And those same underlying fundamentals, both code bases should be using my same design system components, and I should be able to get something at a much higher fidelity. But because those prototypes are also code-backed, I can do it the other way around. I might have a feature that's not necessarily in mocks yet, or in the world of vibe coding, people are always producing new features. And what I can do now is just say, take this piece of code, take this page, and convert it into a prototype that I can easily iterate on. And now because of this MCP round trip, I now have high fidelity transfer on both directions. And so as agents evolve, so will our workflows. But I think the one really hard thing we've not been able to match yet is craft. AI alone will not replace craft, because without context, you're not going to have the intention, the touch, kind of the humanness that makes great products the way they are today. But design systems are here to add that context. And so in the past, design systems used to help us build with craft. But today, they help our agents understand what craft looks like. So I hope this helps understand why design systems have become ever so important in this AI world. Thank you.
Thank you so much, Alyx, and coming all the way from the US. The next speaker, woo! Yeah. Cool. Next speaker is going to be Sabina from Magic Path, not Magic Patterns. I did sort of tell these guys that, you know, they exist and they'll go after each other, but I thought that'd be kind of fun. But yes. Yeah, so I thought it'd be fun to tell a little story as well about Sabina. She actually studied chemistry, I believe. Is that correct? Yeah, but now she's a design.
Is that like Breaking Bad?
Like Breaking Bad?
Like Walter White?
This is Singapore. We can't say stuff like that.
Oh, sorry.
It's okay. But anyways, but that's cool. I think, again, you can kind of study anything and then become anything. And what did you study?
Nothing. I studied nothing. I have 0 degrees. I'm uneducated.
Yeah. So sometimes, guys, you can just do things. No one's stopping you. Just if you're a chemistry person, you can design. Right. So that is a little quick background about Sabina. Woo!
Hello, my name is Sabina. I came all the way from New York City just to talk to you guys. I'm so excited to be here. And I am a designer at Magic Path. Not patterns, path. Light mode, dark mode, we're light mode. So it's funny, I actually hosted a workshop, if any of you guys were there 2 days ago, hello again. And I completely redid my talk this morning because I realized, oh my God, I'm talking to like capital E engineers. So this is for you. If you saw on the schedule, my talk was should designers insert May 2026 design trends here? And that was penned in March because I was like, Sherry, this space is moving so fast, like God knows what, right? Like I don't even think skills were prevalent before I submitted this talk. So that evolved. I didn't do that. Should designers code? Should fish swim? That didn't work. Should designers design? This is actually a good point. I will come back to it, but I think if you're a designer right now, who's also touching code against their will? Eh? Yeah, okay. And then I realized, wait, I'm not talking to the right crowd. Should engineers design? Yes. And so this talk is going to be for you guys, nerds. For me, engineering is really scary because div blocks are scary, but if you think of div blocks, it's flexbox. And if you think of flexbox, it's auto layout. So in like 90 seconds, I'm going to teach you everything you need to know to take my job. I hope you take my job, right? I'm tired. So if you see a font that looks like this and you're like, that's very clean, very easy to read, very human, right? I prompted that this morning. Like, this is called sans serif. It's very approachable, very human. You probably see on every developer site. Modal, linear, Claude, they have their own thing. They're expensive. But Inter is a very good, reliable thing. And people usually just play around with the tracking and the kerning. If you ever see that A versus A, that's just like an expect element. You can change it out, right? If you see this font, you're like, wow, I'm technical now. I'm seeing numbers. I'm seeing something that's very scientific. This is called a mono font, blank mono. Geist mono is probably what you need to know. It's very like, oh my gosh, if I go on my website, like tech, right? That's awesome. If you see this font and the difference, attention is all you need. LaTeX is in it, Times New Roman, anything that's kind of serious. Anthropic answering my question of should I drink 5 shots of tequila before this? Very authoritative, very professional. This is called serif. And if you want to know in 3 seconds why we have a difference, serif is when back in the Roman or Greek ages, people would draw like kind of what they were going to like stencil out. And these little marks are from actually like the paintbrushes of people drawing. So that's literally where it's from. Now you know. Okay. If you see something like this, shaders, interactive things, if you see, wow, like how the hell does that happen? I don't know WebGL. Yeah, this is shaders. All you need to know is that you can go to unicorn.studio, get that done. If you want to actually know the math behind it, go to my friend Maxime's blog. He works at Linear. He's fantastic. And that's everything you need to know. So let's see what else. No gatekeeping here. You're like, wow, I'm on a hero page. Here's MagicPath's website, which you will all see soon. Here's Cursor's websites. How on earth did they do these hero animations? Guess what, buddy? Yeah, that's right. You just take the code base, you throw in an animation thing, and you make a new branch, and you say, hey, make it awesome, make it pop. Usually, people have a recording of their product on here, but I advocate for this because you kind of want to speed things up. There's like kind of a etiquette when it comes to making people wait through your AI-generated whatever. And it's just faster, and you can do a lot of really cool things. Like if you see my prompts, I'm just like, make it pop, make it bigger, like make it in 10 seconds, whatever. Okay, also, I'm not gatekeeping, designers too, this is for you. If you ever see something on a website and you're like, how the hell did I do that? You right-click it, you go to inspect element, and you dig around until you find the computed layout, and you copy that into MagicPath, which you'll see soon. And yeah, this is all to say that I think it's really interesting. Engineers have taste, right? Writing good code requires some sort of like finessing, and I think design has been such a black box for engineers that they don't realize, like, no, you can have taste with this kind of stuff too. Like, everything you just saw, like, that's 2026 designers in a nutshell. Like, shit. I didn't go over instrument stands, but. Okay, so something I want to kind of segue into is how are we kind of defining design and work today? Design today, there's a lot of, there's a weird pattern that we've kind of, behavior that we've encouraged of you iterate, refresh the page, iterate, refresh the page. You're kind of stuck in this single viewport, and if you want to see a version, you kind of have to like do this awkward dance of like pressing the back button or whatever, and like you don't really think, you kind of like iterate until it's like good enough, but you don't really pause and reflect and think about, oh wow, like maybe there's something good from this iteration versus this iteration, right? You're just kind of moving forward and not being introspective, which apparently is not masculine. So, given how hard it is to predict the, what does that say? The future of design, like I work, at MagicPath, and I see a lot of design tools that are like, oh, you got to export it as this dot whatever file, like, oh, you have to natively make it in there. My thesis is like, I don't know how the hell you guys are designing. It doesn't matter. I want to be able to give you guys the best tool possible to kind of meet you wherever you're at, whether you're designing like in a half-baked Next.js app, if it's in a Figma file, if it's in like your head, if it's in your teammate's head, it doesn't matter because, yeah, I mean, creativity comes from anywhere, and I don't want to be the person to tell you where it comes from. So I was talking to Sherry. She actually invited me to this talk back in March, and I was like, hey, like, I don't know what I'm gonna give a talk on, and literally this is what I told her, like, I made these slides the day of, so it's not out of laziness, it's out of accuracy, so yeah. Okay, this is a quote I think everyone should remember. I think this is kind of like the whole thesis of this conference. I'm just gonna read it out loud. John Collison, who is like one of the Collison brothers, part of Stripe, he says, as you become an adult, you realize that things around you weren't just always there, people made them happen. But only recently have I started to internalize how much tenacity everything requires. That hotel, that park, that railway, the world is a museum of passion projects. And I say this to say, some people just throw skill MD files and they're like, put the fries in the bag, whatever. But I think there's a beauty of like kind of understanding, like, wait, before I just like park this skill MD file I found on Twitter in my chatbot, what's in it? Like, do I want every single thing? Like, do I even, like, yes, it's Airbnb's design system, but do I want every single thing? No, you kind of want to finesse things, right? It's similar to, like, whenever, like, someone gives you, like, a PR that was obviously not looked at, like, they can't explain every single line of code. Not that they have to, but, like, dealing with someone else's AI crap doesn't spark joy. I think everyone can agree on that. Let's see. Okay. This is all to say, like, I'm saying this all from the heart, and, as a designer, before this, I did an AI design startup where I tried teaching people design. So, there is no corporate shilling hat on here. But now, there is. Wait. Damn, I wish I was smoother. If you want to go fast, go alone. If you want to go far, you should use Magic Path, and you should use it with your team, use it with your enterprise. Multi-agents, we just released it 2 days ago. So there's me, Chloe Park, if any of you guys know her, she's fantastic. So you can not only design in Magic Path, 1, on a canvas, which I think is the right way to go, 2, with multiple agents, whether it's the side chat bar, and 3, with your actual enterprise team. So get the marketer, get the CEO in, like, put too many cooks in the kitchen, see what comes out, you know what I mean? The cool thing is that, I have been seeing all the love for Cursor and all the love for Codex going on here. I'm such in awe. And the great thing is that you can actually use Magic Path with your existing tools. So I give a workshop. I use Claude Code, but you could use Codex. You can use whatever. Like, I think I saw someone with like the Amazon IDE. What is that called? Kimi? Or, anyway, you can hook up Magic Path to these different agents. Say, hey, like, if you have like a bunch of, pro subscription credits, like use that up on Magic Path. Don't feel like you have to buy more credits. Like, again, we're trying to meet you where you're at. My boss, Pietro, who is such a trip. If any of you guys know Pietro, he's like such a crazy guy. But he made this really awesome video, and like, where he just shows using Codex, you can make these really amazing designs. And I think like this next generation of design is just going to be about, we have the tech, we have to communicate to people that, no, this is how you can actually achieve like engineers designing and designers learning how to work better with engineers. So we have all the tech, it's just like being able to, you got to put it in people's face and be like, hey, use this. Design from everywhere. I actually had someone say like, oh, I wish I could design with Magic Path from my phone. I would never do that because I think that's too much cognitive overload. But if you want to hook it up to Telegram, WhatsApp, whatever, you can. Like, let your design bake and then go check on it later. So making that aware. So the cool thing, again, is closing the loop between design and code. I don't have it on here. Oh, no, I do. But basically, you can have a Magic Path design, put it in your code base, finesse it. Even if you do edits to the local file, you can put it back in Magic Path. So you always have a clean file. And again, these all have live links. So you can send it over Slack, send it over iMessage, I don't know, whatever. And yeah, so this is kind of just like a, I wish it was bigger, but this is just me trolling around my file. Like, again, because it's a paintbrush, I want you to make art, I want you to make projects, things that might never be shipped, but at least you told yourself you like spread everything out and like really thought about it, right? Because I think in the future we need to do things that make our brains wrinkle a little more. I think mine's like, like inflating. So, this is just me playing around with art projects. Like I bought a Japanese texture pack off Twitter, and like I hooked it up to my local my external agent, and then it put really awesome things in Magic Path. And I can see that being used for like landing page or some other creative endeavor. Okay, so the last thing I wanted to say is, oh shoot, I'm over. This is my incredible team. Nothing Great is Built Alone Part 2. We are primarily based in New York City. If you're ever there, come say hi. We're in downtown Manhattan. It is such a blast. And okay, so take a picture of this, because guess what? All the slides are on there, as well as recommended readings, The Myth of the Paperless Office. There are some blogs, that, like Maxime's blog is there. There are some really good resources there for you guys. I also have every single slide. It's not totally accurate, but it's up there. My email and Twitter, please tweet about this. If you actually make something and you DM it to me, or if you DM me in general or send me an email, like I would love to like personally onboard you and help your team get set up. And yeah, we can host your design system. I actually think that's the biggest question I've gotten. They're like, oh, can I transfer my design system to here? Yes. I think that's it.
Woo! Thank you, Sabina. Huge round of applause for Sabina, everybody. Keep it going. Yes, get the mic, young man. Look, how many of you design images with like ChatGPT or Claude or some, yeah, many, okay, this is like 10% of the room. I think many of you don't do it because one, it's kind of, like we kind of know what slop looks like, or it makes mistakes. 6 fingers, right? Anyone see Katy Perry at the Met Gala? You know what I mean? It's cool art. Anyway, image generation, either for brand assets like logos, business cards, things like that, has always been somewhat of a challenge because we know what slop looks like. But also, where'd you go? Oh, there you are. Did you get a mic? Go grab it, bro. No, they don't need it yet. We'll get it. It's fine. Anyway, this is BTS. Anyway, so here's the deal. When you get, and I'm invested in this now. Hang on. Oh, let me just. Can we use this to introduce her, and then we'll give you the mic. Thanks. Anyway, so when you get an image from an AI model, you get one image. It's like a flat image, But if you're a graphic designer, you work with layers. You know this, right? Like you have like a background and a foreground and all kinds of layers. Well, how cool would it be if AI could do that for you? Give you like a Figma-ready thing with all the layers that you can use. And that is what I'm getting ready to hear about. I'm very excited. Who's the next speaker?
Priya.
Introduce her, bro.
Yeah, I know.
It's okay, he's new, but we're training.
Okay, so now our next speaker is going to be Priya, who also came from San Francisco to Singapore, which is a 17.5-hour flight. And she's going to be talking about how AI can become your design partner and help you create some really cool stuff, like similar to Canva, but better.
I don't know. Anyway, that's free. Give her the mic. Fantastic. Give it up for Priya, everybody.
Good evening. Thank you so much for that intro. I feel like you explained a lot of the things that I was going to talk about. My talk is, I'm the co-founder and CEO of Leica, and we're building the infrastructure to train and evaluate creative AI models. And what that really means is I spend all day yelling at image generation and video generation models because they don't understand our prompts, and we are working on building the infrastructure to get them to be better at it. And we want to avoid the problem of death by prompting. I think he asked this question, how many here have used ChatGPT or Nano Banana to generate slides, presentations, social media posters, and I didn't see any hands go up. Are you all lying? Okay, now I see more hands go up. So obviously, most of you use ChatGPT or Nano Banana to generate images. And I'm sure I'll share like what I was doing today, and most of you might empathize with what I was going through. This is like Devil Wears Prada, a poster, and I asked Gemini to replace the image mask with a woman with blonde hair. And then this is what it gave me. That's okay. I still had some patience left in me. And then I prompted again, and this is what it gave me. And then it continued to get weirder. This is what I ended up with. And now I completely lost my shit. So I I thought, okay, this is not going to work. So this is like progressively worse results that I saw. So what we do at Leica is a little bit different. So if this is the image, and this is the same prompt I gave, change the image mask to fill it with a woman with blonde hair and green eyes. It isolates everything into layers, and then it fills that layer with that exact image. The level of localized edits you can make is crazy if you have layers exposed, and you're able to delegate each layer. You can also move the text around. You can change anything that you want here. And you might be asking, why is this small? Well, I guess like the reason why we're able to do it is some of the companies that are doing image generation or video generation, they output MP4s or PNGs, and they are frozen file formats. And the layers are not exposed, and with every prompt, the design state is reset. And text is not a very interesting input medium because many people don't know how to verbalize what they want. So there's a lot of loss in translation. And there's no human AI multiplayer experience today because of that. And the way we have solved it is really to do this layer-level editability. And layer-level editability is not just for humans to move things around, but there might be other specialized models that you could use for different layers. It could be for text generation, SVG generation, photo generation. You don't always need to use one giant model for everything. And you might be asking, why should a startup tackle this? Why haven't the big labs already solved this problem? And the honest answer there is there is no data. With code, there's tons of like GitHub repositories. LLMs have gotten really good at text processing, whereas with graphic design, you just have these 3 giant companies. They're all walled gardens. Figma, Canva, and Adobe hold billions of editing traces and data that none of the labs have access to, or no one in the community have access to. So when we as a startup decided to tackle this problem head on, we thought from first principles and also decided to tackle the problem of like, what is the missing gap in the market? And that is data. So we went ahead and collected over 1.5 million layered graphic design composition. So what that looks like is some of this has been open source, so you can actually go and check it out. This is like a fun explorer that we built where we have put out data from across so many different design categories, 50+ categories, from Instagram to business presentations to posters. And each data point has several rich annotations on what the image looks like, what are the crops like, what is the positions of it, and if there are semantic and logic groups, then you can actually see which elements need to be grouped together. So you can teach an AI model how to do reflow of content, or if an aspect ratio needs to be changed, it really knows how to plan the layout. All of these things, all the frontier models today suck at. And you can play around with this data, and parts of this have been open source, so you can also give a lot of these configuration files as skills for a Claude agent, and it performs a lot better. And you can also train models or build eval on top of it. So the way we approach this problem is you can get one-shot outputs today from ton of generative AI models, and some of the results are really, really impressive. But when you hear comments like AI lacks taste, what that really means is designers obsess over details. Somebody is thinking about what the corner radius of a rectangle needs to be. What should the crop type be? What should the distance from the margin be for a text box? And thousands of these small, tiny decisions is what elevates a design. And AI models don't quite understand how to think about some of these tiny decisions. And every small misstep here makes that output very hollow and sloppy. So the way we've approached it is really to isolate everything into layers, and each layer can be shaped very differently with proprietary data from an enterprise or other data collected from elsewhere. And the layer-level data is going to be very helpful because in an enterprise, people don't have unlimited tokens to spend, especially in marketing functions. Let's say in e-commerce, you have to generate banners that align with a certain brand guidelines across so many different countries. Let's say in Southeast Asia where there's like a ton of languages, and you just want to change the text or specific graphics, but retain all the other elements as is. You just want to be able to manipulate those layers. Or there are instances where you want to combine camera-generated imagery with some parts of human-written copy and fill the other pixels with something that's AI-generated. And you should also be able to combine a constellation of models, because as more and more models come out, you probably want to delegate different aspects of design to different models, and this architecture allows for it. Because today, if you want to one-shot everything, that is an engineer's idea of how a model should function for creatives, whereas creativity is just inherently incremental and iterative. You walk a few steps backward, then sideways, and then you probably decide you want to scrape the design and start over, and the current models do not allow for that. We also came up with a multi-signal reward-based learning system where design is easy to game if you just use human preferences. And especially when you work with brands which have different expressions of taste, you want to be able to come up with part of rewards that are human-based preferences and augment that with certain objective rewards that measure whether the output is valid and meets certain design principles. And then we have two models. One is an AI judge that is able to increasingly update itself on its rubrics so it can get better at discriminating good from bad, and then use that updated AI judge to retrain your generator that can continue to get better, because design has a shelf life, and you constantly want to expose really good examples and train your model to be up to speed. And also build an architecture where you move beyond text-based prompting so that you can capture different types of interactions that can be part of the training loop. This is not the reality today. I never smile when I'm working on evaluating any of the image generation models. But if there's anything you want to take away from this talk, it's that my slides were all inconsistent and all over the place, and that's how AI models are today. No matter what the Twitter hype or LinkedIn hype is, models are very poor at layout planning, getting visual consistency at scale without human intervention, and editability, especially layer-level editability, is extremely, extremely difficult. So if you're interested, you could scan the QR code. We have the Hugging Face link, GitHub link, if you want to use the data set that we have open sourced, and we have also put out a graphic design bench. You can use that to train your Claude agent, or you could also try to use that as eval if you have internal models that you're training, or reach out if you're interested in this space. Thank you.
Woo! Y'all are such a wonderful audience, always clapping for your speakers when they do a great talk, which is all the time. Great, one more round of applause for Priya, everybody. So good, so good. Our next speaker is so cool. He has an amazing story that you're going to hear in just a minute as we introduce him. I'm not even going to introduce him. I think he's a pro now. Give it up for your other MC, everybody. Usman.
Thank you. All right, so now we're going to be introducing our next speaker, who's come yet again all the way from San Francisco to Singapore. And that's a 17.5-hour flight, by the way. Anyway, he's come a long way throughout his journey, where he came from zero to hero. He used to live in a hacker house, specifically the closet, and and he was a college, no, not college, high school dropout at 12. And now his company, what was your company? Now his company, Hyperspell, has come such a long way that it has raised over $6.7 million, not 6.7.
All right. Hey, give it up for the announcer, everyone. Let's go. You did an amazing job. All right, how are we all doing? Final day of AI Engineer. Let's finish strong and make it happen. Hey everyone, my name is Connor Brennan Burke. I flew all the way here from San Francisco, 17-hour flight. I am incredibly jet lagged right now, but we're gonna push through it. Woo, let's go. All right, so we at Hyperspell build company brains, and what I'm gonna tell you today is how to build a company brain. That's right, how to make it so that agents actually understand how your company works. And this doesn't work. All right. There we go. All right. So I think this is a theme we've heard quite a bit today from different speakers. Your agents, to put it bluntly, are clueless geniuses, right? They're like this, savant, PhD, slightly autistic intern that is absolutely brilliant, but doesn't know anything about your company. Every single day for them is like the first day at work. They blindly follow whatever they read. They're kind of naive. They'll take instructions and just go with it. And so you need humans to watch over them. The problem and the thing that gets us to AGI is not better models. The models are already brilliant. It's getting the right context. Your agents are clueless geniuses, and the lack of context is the reason that they don't yet get work done reliably. All right. And so the question is, how do you solve this? So the obvious answer is connectors, right? We've all done this. We've said, all right, I'm going to give my OpenClaw access to my Slack, my Drive, and my Notion. I'm going to use connectors in Anthropic and Claude and ChatGPT. But the problem with this is, again, as we've said, agents are kind of naive. Anything they read, they assume is true. But it turns out that documents themselves are not actually often true. So they'll find a doc, they'll miss the correction, they'll find an old version that's out of date. If there's two different sources, they'll conflict with each other, and whichever one they find first, they'll interpret it as true. There might be the same person mentioned in Slack and Gmail and Notion. They don't realize it's the same person. They think it's 5 different Lisas instead of one Lisa. And there's also no recency, right? You find old, deprecated, out-of-date documents, and they try to operate off of that. So connectors give access, they don't give understanding. So everybody here, I know not everyone here is working yet, but the folks who have, how often have you gone in and started a new job and read a document and been like, oh, okay, this is our strategy or this is the process, and then you go do it and you talk to somebody and it's like, oh no, that's out of date, that's no longer relevant, you gotta talk to Bob instead, and Bob knows all of it, and like, talk to this person. How many people has that happened to? Okay, almost every single person here, right? And so the thing about this is that by giving connectors to agents, we are assuming that truth is in documents, but that's not how things actually work. So the source of truth, as we call it, is rarely true. It turns out that the moment information is created, it starts to become out of date. Documents themselves are a lagging indicator. You might have a reorg or a process change or a customer exception or a new deploy. And so reality gets far away from the doc, and it requires human beings to update docs to make them true. And so how companies actually operate is you have the extremely messy reality where there's Slack threads and meetings and emails and exceptions and all these things happening. And then you have this document. So people try to record stuff, but we're all not great at updating documents or recording them. And then you have what's actually true. And so often, as we just said, the way to get to what is actually true is by asking someone, right? You ask your boss, you ask the person who's been there for like 5 years, who has all the context. And so human beings are good at understanding this. You know not to just blindly trust any document you get in any process. You ask the person. But agents don't know to do that. Anything they read, they assume is true. And this is why you can't just let them run across your organization. If we want to deploy agents at scale, we need to give them a source of truth. So how do you solve that? You create a company brain. So every single organization needs one single source of truth for agents, one company brain. Now, what is that? It's not just connectors. It's not just RAG across sources. It is one source of truth that has confidence in it, that understands who created this document, that brings in threads together from the email and the Slack and the Notion and the messy meeting, that surfaces conflicts and identifies, okay, there's 2 different sources that say different things. How do we resolve between them? It figures out what reason. And it creates one source of truth that agents can actually trust. What does that give you? It gives you better answers. It gives you aligned agents. It gives you durable knowledge. It makes your organization ready to deploy AI. The reason that so many enterprise AI deployments fail is they try to deploy agents, and agents read the documents, and there is no company brain for them to operate off of. This is the thing that we need to make AI actually work. Now, the other nuance here is we assume that context is human-generated, but that is not true anymore. So traditionally, you have people in meetings and Slack and docs and emails, But now you have miscontext, right? You have the meetings you have with humans. You also have all of your prompts to your agents. You also have your OpenClaw memory. You also have the traces and reasoning. And that is context too. The loop that you go with your Claude code to get to the final output, all that context is useful. And if you don't put that into the brain, you're missing a huge source of context to get to the final output. And so we are all moving from organizations that are mostly human to mixed to, in a few years, the majority of context is actually going to be created by agents, and all of it needs to be in the brain. Now, there are different types of knowledge inside of companies that you need to put in this brain. There are stable facts, so things like legal identities, your org chart, your brand colors. Then there's process knowledge. How do we do onboarding? How do we do deal review? How do we respond to incidents? There's also tacit wisdom, things that are only in people's heads. And so remembering, okay, how to close this customer, or what's a better sales strategy, or this particular test is going to be flaky, or this integration doesn't work well. There's all have this tacit knowledge. It's very rarely written down, and it's very rarely in a single source of truth that you can make work. And then finally, you have stateful reality. So you have open deals, active incidents, today's blockers. And the company brain needs to have every single one of these and store them all differently. In order to get to a source of truth, you need to know how quickly things are evolving and what that central place is. And so the way to actually build this is we found from our experience working with everything from tiny startups to mass and Fortune 500 customers is that you want to start by ingesting all the data, and so pull in all the sources of truth. Again, your Slack, your Gmail, your Notion, your GitHub. More and more now, we have meeting recorders as well. You also have your agent traces, right? Agent-generated context. Now, for example, Meta's starting to do this, and Meta is even logging keystrokes. Some people have recorders of their screens. You need to embed all of that. The next thing you need to do is create a context graph. What a context graph is it's a single graph entity that finds every single fact in the organization, understands when it was true, who authored it, how confident are we in it, and embeds that all in one place. But the thing is, context graphs and graph databases in general are not great UX for agents. Agents are not post-trained on them. They don't natively have an understanding of how graph databases work. And so actually the best way to represent this for agents is a file system. And so you create a file system with, for example, data at the company level. Who are the people in your company? Who are the prospects? Who are the customers? You have your decisions. You have events. Below that, you have files for each team, and then you have each individual. And the great thing is, because file systems are universal, you can use them with Claude Code, you can use them with Cursor, you can use it with OpenClaw, NanoClaw, internal agents, or even your own personal agents. Now let's talk through how the brain gets built. The first step is context capture, so you have all these messy sources. You need to ingest all the historical data, but you also need to get it real time. Something like Slack has real-time context, and if you miss that as it's happening, then your agents won't have up-to-date information. The second thing is normalizing it. So we talked about that understanding the Lisa in your emails the same as the Lisa in Slack, getting to one single entity, deduplicating it, structuring it. The next thing is synthesizing. So sometimes data conflicts, and when data conflicts, you need to actually bring that to humans to say, okay, we have this trade-off, which one do we choose? And then finally, you serve it to the agents and have a single source of truth, get the agents the right context at the right time so they can get work done. The hard part is actually not search, it's synthesis. It's bringing all this information together. Is anyone here familiar with Karpathy's second brain idea? Okay, does anybody have a second brain already? And has anyone here used Obsidian as a source of personal truth or second brain? So this is exactly that, but for your entire company, your whole team, every single person in your organization, and every agent in your organization. Now, what this enables is you get to a point where the company starts learning from itself. Every single action that you take creates context. The humans execute, the agents execute, work gets done, new context gets created. All of those traces then are synthesized and put into the brain, and then future execution gets better. Imagine where every single Claude Code instance can now take those learnings and those new takeaways and share them with the entire organization. Every salesperson, if they learn a better way to sell, that's instantly shared with everyone. What this enables is companies that improve recursively over time. Traditionally, we've had people context drain, where people walk out the door and then take their context with them. Now you can get organizations that self-improve, that get better, and every single person, every single agent constantly makes it better without adding another meeting. So we are Hyperspell. We believe every company needs a brain. We build it for you. We are complex infrastructure for AI agents. If this is a problem that you want to solve, you should find me afterwards, send me an email, or find me on Twitter. Thanks, everybody.
Wow. Just wow. Such a genius, bro.
Let's go, man. Give it up for this guy.
I can't believe just an ordinary guy like him could make a masterpiece like that. I believe all of everyone's brands or companies deserve a big brain like his. Please welcome our next speaker, who is Heng Hong Lee, and he has come to show all of us that we can all ship fast with code, and how like you can do something as good as him. Thank you. And please give it up for Heng Hong.
All right, thank you, Usman. That was great. Right, thank you everybody for coming. Right, today I'm going to talk about the 3 primitives that we need to ship fast with cloud agents. Right, everybody wants to ship fast, and I was telling Usman behind that we should like multiply ourselves. Right, how can we multiply everybody? And right now, so like we are Lightsprint. We are a current YC company. We are 3 Singapore founders, and we are 3 curious Singapore founders. We are looking to figure out what the nature of work is going to be in the AI age, right? The nature of work is changing really fast. With like, we 3 of us, we have a bunch of experience doing product, doing engineering, and we're trying to figure out what that means, right? So right now, we're building cloud agent environments, right? We're helping teams build their environments up so that their whole team can ship, make changes to code base and existing code bases reliably, quickly, and safely. Right, what is cloud agent? Right, this slide you probably know everybody's talking about cloud agents today, and yesterday and the day before. So quick one, most cloud agents are mostly from a managed environment. See, they are like coming out of the cloud basically, and the servers that's set up, usually set up by the company. Right, they are also non-interactive, so you fire them off, and then they go around and they build something, and they come back with what they built. Works in the background. Sometimes they're called background agents. Some people confuse cloud agents and background agents. They're the same thing. They just work in the background. A quick kind of like primer, bring everybody where kind of how we got here. Right, we started with the agent inside the computer helping us type cursor. I was an early cursor user. That was super fun, like Command K and everything. And then we had coding agents, Claude Code, cursor again, right? Everybody is inside our computer. It works when we work. It stops, unfortunately, when we stop. But now, today, like cloud agents, basically, they are everywhere. They work for us all the time if you know how to control them. And so today, we're talking about that. The promise is great. Like cloud agents hope to reshape your organization. They want to kind of build out like your backlog, finish your backlog basically, like, they can build anything, anybody can kind of like put together stuff. And the last thing is like similar to what Hyperspell is doing, like, the promise is that they're gonna learn your organization and help you make operations better. The best of these companies are already using cloud agents. So they get a 3 to 5x like improvement, and sometimes even more. Some of the startups that we're talking to are using them very effectively, and a lot of people are seeing that they like the number of PRs that are merged, just created coding agent created PRs, are rising incredibly fast. Okay, so now how to make cloud agents work for you instead of against you, right? So a lot of times, you might not give the cloud agents the right context. And so we want to make sure that, you want to make sure that you give the right agent the right context, and you want to do, make sure to give them the right plan and context. The other thing that you want to do is to make sure that you know where the agent is at any point in time. right? So you want to make sure that you have the the agents doing the work that you're asking them to do, and you are able to check where the agents get stuck, or are they currently stuck, or are they still working? The last piece is, as an engineer, I feel like it's super important. Like, if my whole team is going to ship code to me, I need to review them. And if I need to review them, then I need to spin up a coding environment for that. And then I need to make sure that that works. And the worst is it doesn't work, and then I have to go back and tell them that it doesn't work, and they need to rebuild the PR, which I could just do by myself. Right, so at Lightsprint, we're thinking of it in 3 primitives. You need to plan properly, so to make sure the agent has the best stuff. You need to orchestrate. You need to make sure that you know where the agents are. And you need to preview. So I'm going to jump real quick into our app. And so I feel like I've talked a lot, but I haven't shown anything. So right now I'm going to introduce you our application. This is the middle. Yeah, so this is the Lightsprint platform. And so the Lightsprint platform is basically a workbench for your team to collaborate. Right, so you can see that it's just a bunch of Kanban boards and a lot of tasks and stuff like that. And then yes, plans at the side, you can see. So basically what's happening here is that we are basically helping to create tasks. So we put the prompt in the task format. And so it actually is grounded by the code-based context and basically able to quickly enrich your tasks with a lot of information so that the coding agent can get launched. So we support a whole bunch of coding agents. We have Cursor, we have Anthropic, Codex, and these are just harnesses under our system. And basically we have our Lightsprint Cloud Agent, which is also a harness around that harness, right? Once you launch the Cloud Agent, you can basically click through to dive into the code base, into the code inside. So what you're seeing now is plan mode, right? We want to change this screen. It's kind of boring. It's not AI. It's just basically a list of your recent tasks and your recent plans, right? So let's kind of use our plan mode right now. So we fire our plan mode. We support right now GStack and our own Lightsprint plan mode. Right, so we're using our current Lightsprint plan mode. And basically what it does is that the idea here is that we want to create a multiple choice with recommended and with other. And that's really our favorite use case, right? Everybody loves choices and everybody loves the AI coming up with choices for them. Right, but we also love visual, right? We love to see the mock. So we also made the AI restricted the AI to kind of say, please make a good experience for the user by showing them something visual, right? So we allow the user to pick different options, even make more options, right? Say, okay, please give me 2 other new options. And then those 2 options will just be added along, and then you can pick from those as well, right? So we didn't really do much to tell the agent not to do things, but we just basically gave them a set of guiding principles. So what you get at the end after you've made all the selections, you actually get a full-fledged in-app preview of how your feature is going to look like. And it's kind of interactive sometimes, depends on what the AI chooses. And then here you can also make changes to the colors in our case. And after that, we're going to generate a full spec that we'll just send it over to the coding agent, right? It's going to put it on our board, and then we're going to send it, and then we'll check back in maybe 20 minutes later to kind of get that sorted out, right? So now it's picking the agent and shipping it off. Yeah, and a few moments later. So now it's done, and so now we can actually go into the preview part of our system, right? So that's really a big thing for me. It's able to look and click through the app, and this is basically once set up for any software factory out there. If they don't have a preview mode, you have to ask them, hey, how can my guys preview the app that I have created a PR for? Because that's super important, because nobody hates a PR to review more than the one that doesn't work, right? So we leave it for all the whole team members able to preview the app before we send it over. So we have been using Lightsprint at Lightsprint, and we've achieved a lot of success, having a lot of fun doing things in parallel, and also kind of doing things on local-host. So we are mostly cloud agents. So if something is like a mobile bug or a small issue that people talk to us about, we'll put that on the board, and then we'll fire off a cloud agent to do it. Right. So Lightsprint will build cloud agent first. Right. We have planned. We think that people should plan with a plan, and you can use our visual plan wizard. Right. They should orchestrate and they should preview, and that's super important. Right. So here are my socials and Lightsprint links. So feel free to take a screenshot and use them. And thank you so much for attending this talk.
Woo! Thank you. Hanghong is such a cool product. I was watching the demo back there, and I was like, whoa, I can be a full-on product manager now, right? That's so cool. Thank you so much. You know what I've noticed over the past few talks? I've noticed a consistent color scheme. Have you noticed this too? Right? It's all Claude, no? Anyway, no disrespect. Everybody's got this orange thing going on, and I'm just like, whoa, it's kind of interesting. It's a little bit derivative. Anyway, our next talk, I'm excited about this one because, hey, can we get a round of applause for the organizers, actually? They did such a good job. They did such a good job. Really, really. Agrim, Sherry, everybody did such a great job because you may not know this, but the talks are structured in such a way that they lead into one another. Okay, and it's so cool. There's a natural order here. So the previous talk was about the project management side, and the next talk is also about that. There's maybe a hot take here, which Louis, our next speaker, will clarify. But the hot take is, in the future, we will likely just plan and orchestrate agents that write and ship code. So the job of writing and shipping code moves, and we just become planners and orchestrators, and that's kind of the thing. Louis is going to tell us a story also about his previous business that tried to get traction but couldn't. And I'll say this, W stands for win, and L stands for lesson. And so he's going to have some lessons learned here. Please, your biggest round of applause for Louis.
All right. How are we doing, Singapore? Woo! Let's fucking go! It is 5 p.m. on a Sunday. Let's keep the energy high. Okay, last thing standing between you and a cold beer, maybe. Okay, I'm Louis. I, until very recently, was the co-founder of a startup called Vibe Kanban. I also run an AI community in London called AI Tinkerers, so if you're ever in London, come along to an event, you'll have fun. And what I want to talk today about is why I was building this startup and why I shut it down, how basically the job of software engineering is quickly becoming essentially plan and review code that is generated by AI, and I guess, I don't know how many people in the room are kind of interested. Who is like a startup founder or is going to found a startup at some point in their lives, probably? Okay, good. Well, I will try and talk about like some of the reasons why we ended up shutting the company down and like maybe what could be gleaned and learned from that as well at the end. So very quickly, I'll tell you about what it is we were building. So you got to go back to ancient history. It is May 2025. And my desktop starts looking a bit like this. I've got like loads of tabs open, Claude Code has just dropped, and I'm trying to juggle running multiple agents in parallel. And I started thinking, this is kind of a completely new way of doing my job. And what is going to happen when accuracy goes to 100% and I no longer actually need to babysit what the agent is doing? And I started imagining what that interface would look like. And essentially, it's like all of the parts of software engineering without the code writing part. And if you think about a lot of the software that we have, IDEs, debuggers, UIs for like testing, network requests, things like that, most of the software that we use is actually for writing code. And so if you eliminate that part of the job and you're just left with the planning part and the reviewing part, you could come up with a radically different UI for that. So we started building Vibe Kanban, and it's kind of in the name, basically. It is a Kanban board where you create tickets, kind of similar to how you would do in Jira. But the difference is you can click on any of those tickets, click a play button, and then you will have an option to run it in Codex, in Claude Code, or 6 other different agents. And once something has finished running, you then get a nice interface to review that work. So one of the ways is reviewing the code, obviously. Another way is testing something, if it's a, a website or an app or something like that. So this is all ancient history, seems really obvious now. It wasn't very obvious in June 2025, and a lot of what we were doing at the time was kind of pioneering new ideas. There's a bunch of stuff that we shipped that we then deleted from the app that I'm not showing, so it took some experimentation to get here. So why did we do this? Well, it is because everything is becoming planning and review. If you think about how you might budget your time for the different tasks involved in software engineering, before the GitHub Copilot moment in 2021, most of our time was spent in an IDE kind of scrutinizing code, looking at code to some degree. And what's happened over time is that that has shrunk as a percentage of total work that we do. So you get the Copilot moment, and then suddenly autocomplete is completing a lot of code. And then you get ChatGPT, and you're able to paste in code and get another function out and paste it back in, or you no longer need to go to Stack Overflow. It's kind of making it a lot faster to iterate. Then you get Cursor in 2024, and it's almost like you're still looking at the code, but you've got this kind of chat on the side. And then eventually get to kind of where we are today, which is Claude Code, where, to be honest, I think there's a lot of vibe coding going on. You almost don't even need to look at what's going on. And so I guess it kind of poses an interesting question of do we get all of that time that we used to spend writing code back, or has it just shifted work to other parts of the development process? I think the answer is probably a bit of both. I think it has sped up the overall job of software engineering, but at the same time, I am now spending a hell of a lot of time more planning and reviewing the work that I have to do. It depends. And so one of the ways in which, and this is kind of more of a practical way to think about how this framework of planning and reviewing is useful, is I think you can actually speed up your work with agents if you figure out how to get them to be really accurate. And one of the ways to get the accuracy of coding agents up is to spend more time planning. So what do I mean by that? I mean, the most basic version of this is the Codex or Claude Code plan mode. So just use it. I use it for absolutely everything. The complicated version of that is use a framework. So there's lots of great spec-driven development frameworks out there, which I'm sure there's been talks on. And you can do this interrogation method where you get it to ask you questions about the task that you're working on exhaustively until every possible question that you could have about a task has been answered. But the key thing is you're basically spending more time in planning before you ask an agent to do something. The consequence of that is that most times your agent will complete the work accurately, and it'll need maybe 1 revision, 2 revisions. The other way, and this is something that I think we're all a little bit guilty of, is you don't spend a lot of time planning, and you suffer the consequences of needing to do a lot of reviewing. So, how often do we just throw in a kind of loosely defined feature and, complain when the model gives us something back that is half-baked or is just completely missing the point? And so you're more likely to go back and forth with the model more times if you spend less time planning. I think the other dimension to this is actually the type of work, and this isn't something I've really seen talked about too much. It's kind of a half-baked thought, but if you think about the types of engineering work, feature development is just radically different from migrations. And so these different workflows around spending a lot of time planning versus, and maybe if you're doing that, you're able to run more than one agent at the same time versus a review-heavy, more human-in-the-loop flow where you're not running things at the same time. That probably favors more front-end work. So, it's difficult sometimes actually to express all of the requirements for a complex front-end feature. There's a lot of interaction involved. There's a lot of visual, things that need to be communicated. Versus back-end, where you're describing logic, and it's much easier to kind of find a common language, I find, when you're describing back-end logic, and therefore, the planning and running multiple things in parallel tends to work a bit better for me in those situations. So TLDR, basically, if you spend 5 minutes planning, you will probably save yourself a lot of time reviewing, and I recommend always, pushing the slider that way whenever you have the chance. Okay, and then we can use history to kind of figure out where things are going. So GitHub Copilot would run for a few seconds before giving you a result. The original version of Cursor 2024 would work for, more than that, 30 seconds before yielding a result. And we're at Claude Code, where it's kind of running for like 5 minutes before giving me a result on average. And so the reason that's happening is because there's increased tool use. So we've got agents giving you a response, agents running a type checker, then giving you a response, agents running a type checker, then using Playwright, then giving you a response. And you can extrapolate that, as more and more jobs are brought into the loop, basically the time that coding agents are taking is increasing. And so we're at this interesting point in the history of coding agents where we're about to go really quite far beyond what is comfortable to sit there and watch. What are you going to do when a coding agent runs for 20 minutes? You're not going to sit there and watch your terminal, twiddling your thumbs. I mean, you might procrastinate and end up on Twitter or something like that, but I don't think that's a good use of my time, and it gets boring very quickly. So, if I had to predict, I would say a year from now, we're probably looking at, these things running for half an hour, and we'll need to find ways to parallelize this a lot more. Okay. And I think I'm almost out of time, so I'm going to wrap up with some quick observations. I think basically the work that is emerging is managerial. So if your job on a team of software engineers was to write a lot of code and not do a lot of review and not do a lot of architecture and all the other things that maybe would be associated with more senior or tech lead roles, all of the other stuff is basically going away, the code writing part, and what will remain are all the kind of traditionally managerial functions. And yeah, I mean, we should be building experiences and interfaces that maximize the focus of the developer. So things that keep them focused on what is important, e.g. planning and review. Right, I'm going to have to wrap there because I'm out of time, but thank you very much. And it's great to be here. Thanks, Singapore.
Woo! Keep it going for Louis, everybody! That was an incredible talk. I am a manager now. We'll give it to the next speaker. I'm a manager now. Hey, how we doing? How we feeling in here? What? Why are you even here, man? Go sleep or anyway. He wants to do something.
All right, so let's play a little game. Can you guess what our next speaker... Wait, no. What? I didn't mean what, bro.
Can you guess?
No. Can you guess where our next speaker flew in from? Shout out your answer, by the way. Your options are Singapore. I mean, like, he stayed in Singapore, of course. And then Sri Lanka, or, yet again, San Francisco. Shout out your answer. Come on.
SF! She said it. Where is it?
San Francisco.
Hey, we're on a San Francisco train. Yeah, give it up for San Francisco, everybody.
Way too many people from San Francisco, bro.
That's where it happens, brother.
I mean,
AI
yeah, it's where dreams
Fair.
are made.
Yeah, yeah. What a great quiz. Thank you. Thank you so much.
You're welcome.
Give it up for your co-MC, everybody. Usman. Our next talk comes to us from Harsha, who works at Interface. It's an AI research lab, and he's going to talk to us about how they train specialized coding models with a new architecture beyond the transformer. So your biggest round of applause for Harsha.
Thank you, thank you. Great intro, by the way. Good evening, everyone. My name is Harsha. I'm the co-founder and CTO at Interface. We are a research lab that is reinventing transformers. Today, I want to talk about how we managed to build a new architecture for deterministic developer tasks. Now, it is no mystery that in the past 2 decades, AI has gone from being a rigid machine learning model to a larger scale generalizable intelligence, which you can use today for AI workflows. We've gone from building structured fine-tuned models to today prompting that allows you to build agents. More specifically, think about this. Early 2010s to 2015s, you're a bank. You want to do OCR. How would you go about it? You would have to purchase or procure large data sets. Not only that, get a talented team to build that model, deploy, and then maintain it. This could easily cost you about a few hundred to even millions of dollars. Thanks to invention of large language models, we are able to do that with prompts. However, there's still a problem of hallucination. Though models like GPT are now massively multi-model, and we are seeing it with Gemini, they still hallucinate. This happens because of context drift. When you want it to behave deterministically for large inputs of data, you see hallucinations happen. We at Interface are solving this exact problem by designing a new architecture that we trained. So we bring the rigidity of a machine learning model and the flexibility of a large language model. So how do we go about this? You use machine learning models as strong encoders for very specific tasks. And then you use large language models to create the decoding phase of it. Today, I want to showcase a few things as to what this model can do. I want to quickly showcase 3 things. I'm going to talk about it. I'm just going to quickly run it so that we have time to talk about it. So first thing, this is a real document. I want to extract data from it. Not only the text, but I also want to detect the faces on it, and also calculate its age to verify it. So we ran interface for this. This is what interface gave us. Not only did it extract the text, it gave you the bounding boxes of where it saw the text in the image, the actual pixel coordinates. It got both the faces right, and more importantly, it managed to calculate the age correctly. That's right. Now let me show you one of the specific model providers or OCR providers that also does OCR. That is Reducto. A lot of you might have heard about it. Reducto did extract the text correctly, but it failed to do the other parts of it. Detect where the text is and calculate the age. Now this happens because of a stronger encoder. Let's go to the next one. We want to scrape this particular LinkedIn page. Surprised that Gary doesn't follow me yet, but okay. So we want to extract Gary's experience. LinkedIn can be a pain to scrape because of the blockers and bot checks they have. I want to extract his experience beyond this button. Now that's going to be interesting. So let's see what interface did. Not only did it give us what it saw on the first page, but it goes all the way back to his internship. We are able to do this because of our own model, which is able to scrape LinkedIn. And lastly, I want to go about a PDF, a dense PDF. Sorry. So I just have to run this again. So on this screen, you're seeing a dense PDF that is supposedly a research paper for this particular model. We want to extract this entire text and translate it to Hindi, and also count the number of characters in this PDF. As it runs, I want to go back to the presentation because that's going to take time, and then talk about it. So now that we saw the demo as to interface can do, I want to talk about how we managed to do it. I want to talk about what we actually trained. How did we do OCR? Before that, I want to showcase where we stand as well. On your screen, this is OLM OCR bench, which tells you how good a model is at handling complex documents, not only from research papers, but also complex handwriting for massively multilingual OCR. We are number 1. When compared to even specialized models like Chandra OCR, or even specific providers like Reducto. This is the example that you saw, and this is the output that you saw. What is happening under the hood is that this image is fed as input to the encoder that we trained, which is a CNN stack, that tells you the text regions. Each of these text regions becomes the location of crop. So you crop the image from where the text is, use that to give it to the decoder to generate the output. Now, this gives you confidence scores, this gives you bounding boxes, and metadata that you can actually trust beyond just simple text. We can go a step forward and feed that information to a larger model, which is a decoder that we also have conditioned upon to extract structured output. That's where the age aspect came from. You get the information, and then you condition on top of it. That is OCR. Now I want to go to object detection. How did we manage to detect faces? Now that is object detection with natural language. YOLO models are great, but they only detect specific objects that they are trained for. We are number one for natural language object detection, meaning you pass in a prompt. Let's take this room. I give a picture of what I'm seeing in front of me, and I say, detect everybody who's wearing a black t-shirt. Interface would be able to do this. That's a complicated thing to do. How are we able to do that? So you take the same image, you have a text encoder, which is encoding the text aspect, understanding what the user wants. You have an image encoder, which is understanding or representing the image in positional aspects, and then creating a contrastive segmentation, meaning it is pulling pixels which are closer to each other, allowing you to detect the objects accurately. If you use that information a step further, you can now segment those pixels. Same thing, image encoder, prompt encoder, and then you have a mask decoder that will classify all pixels to give you a latent mask. ASR, multimodality is a huge thing. Not a lot of models support speech out of the box, and I want to talk about it today. We are one of the fastest models when it comes to ASR, and we also have the lowest VER, word error rate. So how do we do it? So when you give a long form audio, we first detect wherever the speech is happening, and then crop those audio clips. So we get the chunks. And then use those chunks to extract acoustic features for an encoder which is also trained to extract embeddings for speech features. Now these embeddings are used to cluster. Clustering allows us to segment features into groups. And that gives us diarization output. So now you know which audio is by which speaker. But the text comes from the encoding part again, where you convert the audio into a spectrogram. A spectrogram is basically a visual representation of audio. And then you use that as a frame to generate or classify text. So whatever the pronunciation is, that would particularly be classified into text. So before going to the next thing, let's see what interface gave for translation. So for this, you can see that interface not only managed to extract all the text and translate it to Hindi, but it also stayed relevant and safe where it's not supposed to. Like, it did not translate addresses, it did not translate author names, and it also correctly calculated the number of characters. Now, we put this against Claude 4.7 Opus to see what Claude would do. We gave it 3 tries, and that's why I went back to this. Claude failed all 3 times. It did because of a timeout. But even if it were able to, and if it is a long horizon task, there's a problem with multilinguality, especially with South Asian languages. Let's go back. So we saw 3 things: vision, audio, and text. While working with these 3 encoders, we trained these adapters to work with the same decoder. So you would get accurate data, but you know where that data is being extracted from. You could solve multimodality this way. Today, I'm super excited to showcase our numbers as to 3 modalities that I was just talking about. We compared interface to models that you would traditionally use in production, and these models are economical and can do the tasks in one shot. But we are comparing them for deterministic tasks. Tasks where there is only one output. If you're looking at an image, my name cannot magically change. It's going to be still Harsha. Johan and I and my team have been researching about how do we build task-specific models for about a year now. We did the same things. We picked small language models, we procured large data sets for a lot of money, and we kept running into the same problem of determinism. Models hallucinate. That's where we thought we have to go back to the board, redesign the architecture, and rethink it. We observed that data is not the bottleneck, the architecture is, and that is what interface is supposed to solve. Lastly, it's been such a pleasure to speak in such an amazing audience and such a beautiful country. Thank you.
Interface! Honestly, those benchmarks were so impressive. Thank you. That was incredible. What fantastic benchmarks. What's up, Usman?
Hello.
How's it going?
Great.
How's it going, everybody? You know, I swear to God, you as an audience, you make me feel like Michael Scott. You watch The Office, you know what I mean? I'm just here, "Woo, am I entertaining you?" And you're like, no, I'm ready to go home. Don't be ready to go home. It's not time yet, okay? I need you to like be inspired. Are you inspired? That's better. That's better. Usman, what's up next?
Well, now we have some guy named Harishi. Fun fact.
He's so awesome.
This time, he's actually based in Singapore.
Woo! Singapore tech!
We love Singapore!
We love Singapore!
Yeah.
That's it.
And,
Energy over. Continue, please.
Okay. His app is actually based on how his personal mistakes with AI, and especially coding. I'm pretty sure all of my vibe coders here can relate as to how much mistakes or errors or bugs we've all come through and pushed.
Look at this
through to
wallpaper too, by the way.
Oh, wow.
Right? That wallpaper is how you know it's going to be a banger. It's so cool. You ready, Hershey? You are good to go. Hey, everyone, again, your biggest round of applause for Hershey!
All right, guys. Okay. So that actually was a custom version of Bliss that we made from a talk that I gave at the Unconference called How to Leave Greenfield. So if you don't know Bliss, at least you know Greenfield. So this is Welcome to No Country for All Code, right? And it's a working title. I think everyone keeps changing titles all the time. So it's not a talk about coding agents. It isn't a talk about agents for coding. It's a talk about building agents inside large existing systems, right? With old code, organizations, and data. Because that's what we end up doing, which is about repairing over rebuilding, update over create, about old code and organizations over new. And it turns out if you start from those base priors, a bunch of different primitives fall out, right? You prefer simpler, reusable units of work instead of trying to one-shot context windows, right? You remove things from context instead of adding things. And you separate control flow from prompts and prompts from code. And you calibrate for behavior instead of stepwise success and failure. And you build cost-aware systems that separate build and runtime so you can percolate resources effectively. And turns out if you do all of those things well, you get to ship outcomes. And you get to do things once and have them stay done. You get to fix things that break and have them stay fixed. And you get to vibe when you want to, right? Which makes it so much more fun. So that's the bulk of the talk. I'm just going to spend some time explaining that. But if that's good, we can go right into it. So before this, I spent a few years in electronics and software, and where the bottleneck was like always data. And it was getting it into a shape where it can be useful for a decision. And after sort of thinking about it for a decade, I started Southbridge with that conviction that 3.5 Turbo was this unlock, right? That last unit of general intelligence that we needed, and we could build the rest. Since then, we've built connectors for data systems that self-heal, regenerate. We've built ETL systems for healthcare, financial, energy. We're beginning to solve ingest, I think as a species, but also as a company, ingest as a horizontal category, right? Whether that's for new customers, new data sets, or even user-uploaded data. And everything that we've done since we got founded was in service of solving that first mile problem for data with AI. But the problem with starting with data, though, is like your difficulty from day one is turned up to 11, right? Because you start in the critical path, and your work needs to be long horizon from day one and like reliable as a baseline. A full run on even small data, which is like a gigabyte, right? Verifying formats, validation, resolving entities, all take like millions of operations, and those errors stack up. Context windows, if you remember Gemini going from 2 mil to 1 mil, actually started going backwards, right? But even if they went like 100x, we would still have way more data in like a day than what you can process. But then again, the most important sort of biggest killer of data companies that I've seen is diversity, right? Data as a stack as a whole is very, very diverse, both in the macro and also the micro. Like in the micro, humans, us as a species, turn everything we can into a canvas. Documents, Excel sheets, PDFs. Like internally, we have the joke that the merge cell button in Excel was one of the greatest crimes against humanity. And in the macro, though, companies really are unique, TM snowflakes, because you've got different stacks, programs, SOPs, security boundaries, even the same database, like little Postgres, viewed through different intranets and permission systems looks like completely different systems. But one important separation that I want to make here is between online and offline agentic systems, right? And it's a useful way to think about these things. Like online versus offline is things with a human in front of them and things without, right? And as much as like we want to stroke our egos, most real systems have far larger offline components than online ones, especially all the ones that we've worked on, right? You only really need an active, latency-sensitive human in the loop if you build things fresh every single time. Like if you can build reliable systems that ossify over time and record your preferences, like all of that work can move offline to run overnight on local models for cheaper, and that agents can function like appliances and can do a job repeatably thousands of times, right? You fill your dishwasher at night before you go to bed. The next one is that we still believe that coding agents are going to become the base substrate for agentic work, right? Not because all agentic work is coding, right? In fact, I think we'll saturate on coding very, very soon. But because the coding agent loop is becoming the thing with the most amount of resources, the most RL, the most deployment pressure, and it's got universal primitives, read, write, edit, shell, right? And in the same way that V8 and browsers became the substrate for a crazy amount of software that wasn't actually websites, coding agent harnesses, we believe, will become the engine layer for a lot of agentic work. OK, so that's enough about the general structure of things. What did we actually learn, right? The first thing was to stop pushing one-shot, right? Single-shot performance, I think, can be crazy fun to push when you're building things. And like, same here. Like, complex instructions, long plans, giant scales. I think Sabina was talking about fries and more fries in the bag, compaction. But repeatable work, which is where we said, runs counter to all of those instincts, right? It just is not how you want to build if you want self-driving agents, right? Because the first thing you want to do is break things into small atomic pieces. And in Hankweef, which is this runtime that we use and we've used for a long time and sort of recently open sourced, those small little boxes are called codons, right? You chain those to then get the behavior that you want, and you make them reusable and composable. And if you break it down this way, it makes it so much easier to reason about long runs, which ends up becoming the bottleneck. Your ability to reason about what happens at hour 20 or hour 25, like you, the human, ends up becoming the bottleneck to you building complex software, right? The next thing is to remove things from context, right? I'm still surprised at how few harnesses, systems, just frameworks out there have a way to remove things from context, right? Like the default behavior we've always had is to have boundaries that delete context and archive what you don't need, right? Preventing this thing that internally we've come to call world line rot, which is, Ted Lasso says, be goldfish, ends up being a good thing. The next one there is to just separate components by type. Like as an industry, we keep having to relearn this, right? Back when I was in college, we had von Neumann Harvard architectures with like code and data separations becoming a thing. And then later on, we had PHP and like CGI, and it took us another 4 years to learn that you had to separate model, view, and controller. And agentically, same story, right? If you want to build reliable systems, you want to keep these 5 things as separate as possible, like data, prompts, control, and the rest, right? And in the last year, we've worked with a lot of people. We've touched a massive amount of information. We've read millions of words of AI-generated results. Like I said, that's our superpower, which is that we read the outputs. We read the outputs for you, and we read everything that comes out of these things. 9 times out of 10, if something breaks, it's because there was a wrong abstraction shared between you and the agent, or because something was left in context that just did not need to be there. So going into a bit more of our things, right? Like we usually build on the principle that the best part is no part, right? So simple tools, sequence work, like we talked about, and you only add things if you absolutely have to. So I hope it's not a surprise when I say that we've never actually needed parallel agents, right? A single primary agentic thread for us in the line of work that we do for reliability has way too many benefits to give up, right? So many programming languages, Python, JavaScript, a lot of them will agree, and we'll look at some of the benefits on our side in a second. But for our version of the event loop, that little hack is what we call sentinels. So we initially designed those things to monitor long agentic runs, but they've become our most powerful primitive. So sentinels are LLM calls that trigger on some combination of events from the primary loop, right? They trigger, template their context, and then write the result to a file. A sentinel could wake up every 50 tool calls, summarize what happened, and then go back to sleep, right? But turns out they're amazing at catching behavior without creating so much complexity that you have to troubleshoot the eval system. So laziness, mocking, bad data hygiene, file writes, shell errors. You define the pattern that you want in something reusable that we call a sentinel, and then you fix it in the main thread, right? Way more than hooks. This is far, far better for us for coalescing behavior. So I'll do one more, just one more, which is budgets, right? Long horizon systems on our side just need to be cost aware on every axis that matters, right? But if you do everything that I said so far, you can make a declarative budgeting system, which is really the best kind. Like SQL, you can express what you have, and the system figures out the gap in between, right? In fast-moving spaces like AI, where models, harnesses, implementation details change all the time, declarative actually wins because it keeps you from needing to rewrite things. So we've got all of the different axes, money, tokens, time, data access even in the right time. You express at build time how those should be distributed, and at runtime, you actually know what resources you have, so you can solve for the two things, right? So finally, if you do all of these things, you can ship outcomes instead of building tools, right? And I say this to a room full of people, me included, who care a lot about the craft, who care about the tooling, right? But most people, they don't care how their dishwasher works. They don't care how their car injects fuel. They want clean dishes. They want to get where they're going. So our North Star has always been to deploy systems that ship the outcome, right? Which might be getting a customer onboarded as quickly as possible, validating research hypotheses, cutting integration time, right? Or just doing all of that without embedding what we call Achilles guns into your data. And for that, agents need to become infrastructure. They need to become boring, repeatable, predictable. And so that is really just the goal for us, right? To build things that get to become legacy. It's only in code that really legacy is a bad word. So in some ways, you're trying to bring that back. So lots of things that couldn't go into the talk, but you can go here for the long version. Thank you, guys.
Woo! Oh, Rishi, thank you so much. That was such a great talk. You know, I got to talk to Rishi backstage, and I was already prepared. Wow, what an incredible talk. One more round of applause for Rishi, everybody. Oh, my goodness. Incredible. Our next talk is another exciting one. I went backstage and asked him, I said, hey, what's your talk about? And he said 3 words. He literally just said 3 words and nothing more. No more words were spoken, Henry. The words were MCP versus CLI. That's the talk. And I'm really excited about, how many of you use MCP on the daily? Almost everybody. Wow, what do you use it for? You, over there with the glasses, what do you use it for? Debugging production? Awesome. That's actually a good use case. We, internally where I work, we use a project management tool called Monday. Anyone use Monday here? Monday.com? I'm not going to say anything. Anyway, they have a UI, like a web UI, but they also have an MCP server, which is so amazing, because I can be working on something in Cursor, my preferred IDE, not Spawn, and I have the Monday MCP server inside, and I can just say, I'm going to this conference, add it to Monday, in the agent, and it just does that. And it's so cool. So I'm a huge fan of Team MCP, but of course, CLIs also have reason to exist. I mean, Claude Code is a CLI agent, a coding agent, with an MCP client functionality, right? And so how does this land? Well, we're going to find out. Henry's just setting up here, and in a minute, we're going to hear about MCP versus CLI, which may not even be a versus. It could be an MCP and CLI. Do you think CLI is kind of going out of style? Anyone? No? Yeah, of course not. Because if we don't use it, agents will use it. I think it's a fantastic user interface. I'm slowly running out of things to say. Oh, good. Look at that. Hey, listen, we're almost at the end of the conference. This is going to be a great talk. Give your biggest round of applause for Henry Mao. No?
We have a bit more.
That's okay. Oh, you got to extend. Choose extend display. I'm tech support now. There we. Is it ready? No? Almost? Okay, no. See, what they're doing is they're extending, but he hasn't dragged the window. This is now commentary, everybody. That's what. I love it. Thank you. Oh, pity. You know, this is the. You know what you call this? You call this pity applause. Thank you, I need it. Put a coin in my hat too while you're at it. There we go. It was extended, they dragged it. Okay, let's try this again. Your biggest round of applause, Henry Mao.
Thanks for the introduction. My name is Henry. Hey everyone, I'm the co-founder of Smithery. Today I'll be talking about the ecosystem of MCPs, CLIs, what we've seen here from Smittery, and how that relates to giving your agents more agency. So a little backstory. At my previous startup, Jenny AI, we built an AI academic co-pilot for academic researchers. And one thing that really bothered me when I was watching users use our product was that they would often have multiple windows open. They would be using different apps along with ChatGPT, and they would waste a lot of time copying and pasting between these apps and their AI of choice. And this is a broader problem that affects every single knowledge worker. Whether you're hopping between terminals, between your coding agents, or jumping between your CRM and Google Docs, we are stuck in a sort of copy and paste hell because humans were essentially acting as the adapter layer for AI. You were in the loop, prompting the model for every single read and write access to different services. And prompting is really the tax that you pay when models can't access your data or take action on your behalf safely. And that tax is pretty expensive. So I started Smittery about a year ago to tackle this problem. MCP just came into the scene, and I saw it as a way to help bridge the gap between agents and services. So we started Smittery as an open MCP registry, and we attracted a community of thousands of developers who published their MCP servers on us. We built a gateway that aggregated these services and unified authentication so that agents can conveniently access all your APIs grouped as a single toolbox. We currently process about 100,000 tool calls a day for our users. But our journey wasn't smooth at all. If we're being honest, MCP had a lot of hype after launch, but also had a lot of issues. The protocol was definitely ambitious. It tried to build a standard while agents were figuring out how to call tools well. And it had to change its spec rapidly in early 2025. The implementations of MCP clients and servers were poor, and that led to a lot of frustration with users. So by the end of 2025, I think a lot of people started proclaiming that MCP is basically dead, just as fast as it exploded. In fact, at least 5 people in this conference, I think over the last 2 days, have asked me the same question, is MCP dead? And we're going to get to the bottom of this, because many of the criticisms that people have raised are valid. The main reason why people had bad experiences with MCP was that most harnesses back in 2025 had a very naive approach of adding tools into the model context. They simply dumped every single tool into the context window, like this diagram on the right side. And imagine you're browsing the web with Chrome, but imagine if Chrome did not render HTML at all. It just dumped raw HTML and CSS to you and asked you to figure out what to click. And that's what we were basically doing to models. A harness was dumping all the tools to the model and expecting it to do well. It gave the model information overload, and instead of rendering a usable interaction layer. So this wasted a lot of tokens, it caused context rot, and it degraded model performance significantly. And to make things worse, many MCP servers built back in 2025 were poorly implemented and basically watered down versions of their official APIs. A lot of them didn't implement proper authentication, and developers would handcraft these prompts basically in the tool descriptions to try to prompt inject weaker models. These were all anti-patterns that coupled task-specific behavior, which should really belong to a skill, into a tool description. So the lack of a good developer experience eventually led people to look for alternatives. Coding agents got good at Bash, so the natural question people asked was, why not just use the CLI? The CLI had many benefits. First, the CLI had progressive disclosure built right into it. It had pipes, so you can compose different subcommands together, and it's built on a mature Unix stack. But there is a hidden category error we're making here, where we're comparing CLI to MCP. MCP stands for Model Context Protocol. So it's a protocol, not an interface. And comparing it to a CLI is a bit like comparing apples to oranges. And this diagram hopefully can explain it a little bit better. Because a protocol's job, like REST and GraphQL, is to define a standard of how to communicate, not necessarily to define how tools are rendered to the model. What was missing was a good harness that renders MCP well to the agent. And we refer to this as native MCP rendering. The good news is, as of early this year, in 2026, major harnesses like Claude and Codex have finally built proper ways to render MCPs. So we wanted to test this at Smittery. how do modern harnesses actually perform when they use their native MCP renderer versus Bash and CLI? So here's the experimental setup we did. We ran a benchmark on 3 core APIs, GitHub, Linear, and a Singapore bus API. We chose these APIs because they represented a diverse set of API styles and also training data contamination. We also chose 3 different models listed here. And the main thing we changed was the interface we provided to the agent. So we either installed all these APIs as MCP servers on the agent harnesses, or we provided a CLI to their Bash interface. Our goal here is to measure accuracy and token efficiency. So here's a question for the audience. Just a raise of hands, how many of you think that native MCP did better than CLI? OK, we got some people. How many of you think CLI did better than MCP? OK, there's more people. And how many of you think it doesn't matter, like it's just a tie? OK, we got some people here too. So to our surprise, native MCP actually won in both accuracy and token efficiency, which really busted the myth that we've been living with in the last year. And that's mainly because the model harnesses have updated themselves and became more efficient. But what I was more interested in here is, what are the principles of agent experience design that really matters? Like, what can we do to make CLI better? Or what are the principles of a harness that actually makes MCP work so well? So we did some ablation experiments by changing the construction of our CLI to see if we can match native MCP's performance. So we did an experiment where we added descriptions, better descriptions to the CLI, and we also did some experiments where we added a search functionality to the CLI. And what we found was these 2 things mattered the most out of a bunch of different things we tried. First is self-documentation. So if you provide agents with discoverable, well-described tools, it will perform better. And the second thing is search. If you provide agents with the ability to search through subcommands in a CLI or tools with an MCP, it performs significantly better because this reduces the number of steps it needs to find the tool for the job. So if you apply these 2 principles to your CLI, you can mostly close the gap in performance against native MCP. Full experimental details are on our blog. So at this point, you might be thinking, well, I don't really care about token cost. My company's paying for it. Or models will get cheaper. The results are close enough. I'm just going to use a CLI. And you're not wrong, right? If you're an engineer running things locally, you should probably just use a CLI. I'm not being sponsored by MCP, by the way. We ran this benchmark after Smittery launched our CLI offering, so we can work with both. But I do want to give MCP some credit where it's due. For one, CLI works if you want to set up a sandbox, but with a good harness, MCP works just out of the box. So these are use cases where you actually want to run a cloud agent that is sandbox-free. The reason you might want to do this is because it will be more lightweight and have lower latency for lightweight tasks that are unrelated to coding. So portability is one advantage of the MCP. Another benefit is that MCP puts the responsibility of context engineering on the harness. So that means if Claude Code updates and improves its harness and how it interprets tools, your tools will improve as well. But there's one more benefit of MCP that's a little bit more subtle. It matters once you want to move towards a world where agents have more agency, and that is permissioning. Because the major weakness of CLI that we've found is that it's usually way too broadly scoped because it's made for developers. And it has a huge attack surface when you want to run it with little supervision. CLIs give the keys to your kingdom. So whenever you're running a CLI agent in the background in a long-running job, you're kind of stuck with 2 terrible choices. You either make it ask for approval, which doesn't really scale, or like most of you out here who are probably guilty of this, you're going to dangerously skip permissions. And the one thing MCP has here is that it defines an opinionated small surface. So it makes it easier for you to secure it. This choke point allows us to apply policies and guardrails to your agent. So for example, if you're using Smittery's gateway, we provide a policy DSL so you can enforce fine-grained permissions on what your agents can or cannot do. So this primitive gives you peace of mind as we graduate agents to full autonomy. So to answer the question, is MCP dead? I don't think so. But that's also not the point of this talk. MCP and CLI, in my opinion, both have their purpose. And it's a principle behind agent experience, security, and authentication that are here to stay. MCP might no longer be in the zeitgeist, and that's fine, because the best thing that can happen to a protocol is that it becomes boring, like HTTP. Boring enough so that we can move on to solving more ambitious problems and push towards a world where agents are driven by outcomes, not prompts, where agents can fully graduate from a chatbot to a coworker. That is how we move from humans in every single loop to humans being on the loop. Thank you. Woo! Come chat with me later outside if you're interested in wiring up your agent.
Yes, chat with Henry. One more round of applause, everybody. Henry Mao! We go from humans in the loop to humans on the loop. Honestly, I'm ready for that. Look, listen, our next speaker, I've been told, I've just met him today, but I've been told he is, and I quote verbatim, the most cracked engineer in all of Singapore. You hear that? Look, I'm not even qualified to introduce him. So I need help. Ivan! Give it up for Ivan, everybody.
So Raj, I've had the pleasure of knowing Raj for quite a while now, and it's absolutely incredible what he pulls off. We had a hackathon once. He came in and said, oh, I'm going to build a way for agents to collaborate. And so he finished it, and we said, oh, what else are you doing the weekend? He said, oh, there's a Mistral hackathon. What are you doing then? He's like, oh, I really built a tool to help me build my submission for the next hackathon. And then he won our Gemini hackathon, and he almost won the Mistral hackathon. And then he said, oh, I've been hearing about this Kimi 2.5 thinking. It's pretty cool. And I said, oh, that's nice. So what did he do next? He post-trained it himself and ended up beating it and using it as his main agent. Raj is absolutely incredible, and honestly, I'm excited to hear what he has.
Thanks, Ivan, for that lore drop. But yeah, I am Raj, and today I'll be talking about my journey in creating evolutionary harnesses, as well as evolutionary algorithms in general. So a little bit about how I got to this. Initially, it was a paper that me and my friend were working on. We were thinking of how do we create diffusion models from scratch, and we were creating specifically like a medical diffusion model for chest x-rays. And while we were working on it, we realized that there was very little data to begin with. And as we were going through different papers, we stumbled upon one paper that talked about models having like human notions of interestingness. And that paper basically used like a language model as a judge for an open-ended like RL curricula. And it exposed me to the whole world of open-endedness and algorithms. And that was my first time using that. And I think the next question that like naturally came out from that was essentially like, if we claim that agents can be open-ended and that they keep producing novelty forever, how does that look like in our own like ecosystem, in our own biology? And I think the sun is a very good answer at that. Basically, for like energy particles that come from the sun, they basically come on Earth and they get emitted back into space as well as higher entropic like photons. And the gradient that basically enables this is all of life itself. Life is the thing that creates more entropy. And it's a very particular kind of entropy that took 3 billion years or even more to create and generate. And the question then was like, how can we map this towards some similar like systems, like agents itself? So that was what I tried to do, whereby it was like, what if sun itself is compute? The DNA that has evolved these smaller single cellular organisms into the complex beings like us, that write code, that engage with code, that can think, that can react to things and create more entropy, that is basically the trajectory that these agents have. And the selection bias itself is the harness, which basically evolves as models have been evolving. A very interesting paper that I read after that was basically a paper that showcased a single agent that slowly improved itself over time. It was called OmniEpic, whereby you had different environments, and the agent started out being very specialized in a single environment, and as time progressed, it started becoming more and more general. That generality of that agent made it perform tasks that were that showcased emergent behaviors, and that was a very interesting like feedback loop that then led to the creation of another paper that that same author wrote, in which the code itself was, when they replaced that to become the code, it actually illustrated a significant improvement in performance, whereby the agent, like, from just performing at like 20% in SweetBench, it went up all the way to basically 50%. And that was when I realized that if you could evolve the environments that you place these agents in, and you evolve the tools, both are the things that you could have a lever on, and that could eventually improve the overall agent's performance. And if you look at the trajectory of everything, like, we've had models that are way better than the harnesses that we have. Every company is trying to create custom harnesses. I don't think that's the right way to go about things. What if you could then instead have self-evolving harnesses? There have been papers on that, like meta harnesses, RLMs, and a bunch of other literature. And the next step to that will be the agents themselves. What if you could somehow keep that memory state somewhere else and evolve that agent? What follows next will be things like world models, not physical world models, but world models that interact within a code-like environment or various code-like environments that could be very differentiated. And something that I talked to my friend who worked on a pretty interesting world model paper was that what will be more interesting will be seeing how the architecture of agents within these world models look like. They may be novel and not handcrafted. It may not use the same techniques that we do, but that's something that will be interesting to see. And we are seeing that nowadays as well, whereby initially the scale at which models initially grew up, it took us a really long time to saturate MMLU and the other benchmarks, but every few weeks you see a new SOTA model coming out. And that's not because we have better or just better quality data. It's because training loops have gotten faster and models are just closing the loop themselves to a degree. And my point is that scaling laws still hold to a degree. They will hold and continue holding as long as humans are more interesting than the agents or the harnesses themselves. This could come in the form of like different architectures, which are not handcrafted. They don't necessarily have to be human-made. And this is something that I believe will just remain. What I found out in my journey so far also has been that when creating the bigger meta harness that I made, what improved model performances generally was the trajectory. It was never really the weights. It's similar to how like the DNA just remain, like, and the way that we exhibit its characteristics change. The artifact worth studying is the path and the reasoning traces and why a model did something, and not the end state, if that makes sense. And another thing that I learned while building CodeGraph was that iteration loops are very important to this. The most successful life forms are ones that like just adapt really fast, those who die really fast. And if you can close that loop faster, it just lets you do more things. And that can come in many forms. A great example of that is language. What language are you writing your code in? I think for me, a lot of my work right now has been around or written in Zig or Rust, but I realized that eventually, like when you want to create better and better tools, languages that have smaller comp times actually end up creating better tools, and you can create better tests for these tools, even if that language is not memory safe. I do believe that eventually, maybe this year or next, almost every company would start writing some sort of their own meta agentic language. And whatever happens, these models would keep getting better and better, and they don't have to be human readable. So these are just a few tools I built for myself that I've been using internally, like Muonri, which is just a faster rip grab that enables my agents to get more context. The exact lines of code are retrieved. CodeDB, this is fully open source as well. It's a trigram search for my own harnesses as well, whereby agents get the exact lines of code that they need to change so that they don't have like context rot. NanoBrew was then created because once you start putting these agents up in the sandboxes, you realize that one way to get coding environments set up, you could snapshot it. The other thing is you could just keep pulling like apt gets and getting the packages and dependencies that you need. But I was like, what if you make that faster as well? so that you can resolve that environment. And that's how NanoBrew was born, which is significantly faster than apt-get and Homebrew itself. And this was also another parallel tool that I realized I had to create for my agent to be better at like just navigating the internet. Something like agent browser, but also using lesser tokens by using the A11Y like extensions that CDP or Chrome exposes to people. And this actually improved the agent's ability to browse the internet at scale. Finally, back to the whole evolutionary loop, like DevSwarm was made, whereby in DevSwarm, what was orchestrated was basically a set of tools or models that can change their shape. So you could have like maybe a few Opus context windows coupled with a few ChatGPT windows with a whole multi-agentic framework. And the source of truth would be something more rigid, like Terminal Bench or like a Sui Bench. And as more people started using this, I started getting more telemetric data on what works and what does not. So quick side is that all of these like lie into some sort of a fitness function, which in a coding agent, the harness rewrites every single time. And finally, the harness, which was CodeGraph. CodeGraph was Soda on Terminal Bench for a while, but it's no longer Soda. And it was essentially just made from that very fact that it was a self-evolving harness that just got better and better with different models as time went by. And it created its own tools. All of that work is also open source. The trajectories are also open source, but I've not released this like at scale yet. But you can for sure check it out as it's still a work in progress. So yeah, what I ended up building out was just one harness, but the tools that came along with it were also some sort of an evolutionary loop for myself, whereby all of these 5 items essentially made the harness better. And with that, yeah, I guess thanks for coming to AIE this year. And yeah, I just feel like this year will be one of the few years where you keep seeing the bitter lessoning. Yeah, thank you.
Oh, woo! Jesus, I feel like I should like just bow down right here. Oh my God, what a talk. Thank you. Give it one more huge round of applause for Raj. Man, my mind is blown. My mind is absolutely blown. Will you come set up while I like wrap a bit? Bro, we got to collide on stage. You know what I mean? Oh my gosh, that was insane. Like, what a talk. Look, yeah, they're going nuts over here. I don't know, all of you are asleep. But like, that's it. What's your name? Daryl. Oh, that's right. I see you. Yeah, the lights. Listen, I was literally looking for one of those open source projects that he shared. I was stuck without it. He has saved my whole idea. That is crazy. And he's so young and he built this thing. I'm genuinely. Can we have another meditation session so I can meditate on that? You know what I mean? My gosh. Raj, incredible. We've come to the end of the conference. Oh, womp womp. Yeah, oh, Swix is here. Yeah, it's very sad. It's very sad. But we must pay our respects. Nobody died. We must pay some attention and some homage to Agrim, the final talk. He has won the most hackathons in Singapore, I was told. He's somebody who came up in this ecosystem, who grew up in this ecosystem, and who is doing his part through the conference and the team and the volunteers to really bring it home and make AI continue to grow in traction and vision here in Singapore. And so the brains behind the conference, the heart behind the conference, I've spent the day with him walking around, and it's very clear to see everyone knows him, everyone loves him. Let's show him how much we know him and love him. A big round of applause for Agrim Singh!
Test. Hello, everyone. This is the last talk of the day, so we're going to keep it nice and fresh. And it's about how to vibe a conference in under 3 months. This story goes back to July of 2025. Rachel, Sherry, and I were getting lunch, and I think just general disdain about the state of affairs in Singapore around AI events. A lot of talk, not real builder-friendly moments happening, and we hadn't really started doing any events at this point. But we felt like the culmination of whatever we do eventually will lead to us doing a conference. And I sent a message at that point saying, I think we're going to YOLO our way into running the biggest conference in town. I didn't think it would happen, but I guess looking at this weekend, it kind of worked out, right? But obviously, you can't YOLO this, right? Like, it's big to think that, okay, we can pack 1,000 people into an auditorium and like give them all the AI stuff that we can find. But you got to test the audience out. Is it because the ecosystem doesn't respond, or is it, the ecosystem's super responsive, but the events don't serve them? So we tried doing a few things. A week after that message was sent, we ran a meetup for Cursor. At that point, we were like, well, maybe it's one of the first developer meetups of that scale with AI tools in question. Maybe 100 people will show up, maybe 200 people will show up. I think we ended up with 900 signups, and we eventually let 500 people through the door. And that was pretty crazy to me at that point. Fast forward a few months later, we thought, okay, let's do a hackathon, since hackathons used to be pretty big when I was coming up in the scene. And we thought, okay, let's do a 24-hour hackathon, see how many people will sign up. Maybe people will come, maybe people won't come. 1,200 people signed up. We let about 500 people in. And people flew in from as far as maybe the Netherlands, all around the region. And that kind of gave us a lot of confidence as to maybe it's not the events themselves, but people do need a space to be. So 90 days ago, we met Swix. And we told Swix we're going to run AIE Singapore. And I think he wanted to laugh at us at that point, because he was like, are you guys serious? Like, I can't help you as much. I have other AIEs to also run. Have you guys run a conference before? Will people pay? How are you planning to do any of this? And I think our response generally was, yeah, I think we'll figure it out. And that has kind of been the motto behind the entire event. So if there are any rough edges around it, I do apologize, but we did try to figure it out. And that's kind of how this went. And all of this sort of centered around high intent. We had intent that we want to make this the best builder-friendly event that we could. We wanted to make sure that people in the room had intent that they want to be here. Tickets are not cheap, I understand. But we wanted to make sure that people who actually want to be here are here. We wanted to make sure that the speakers who want to be here are here, so we flew them out. We wanted to make sure the sponsors who want to be here are here, and they gladly sponsored the conference and got involved with this. So everything was culminating in a way where everyone who actually wants to be in this room today or through the weekend was here. We did not give out free tickets. There were a lot of people who were waiting that things might happen. They might find themselves a free ticket like maybe at other conferences. That wasn't really the case here. So all of you are in this room because you paid for it and you really wanted to be here. So big shout of, round of applause for you guys. And you guys kept showing up. Like, the rooms were full all day, and it's like 6 p.m. and you guys are still here. So clearly something was working in the quality of the talks, the things that are happening, that you wanted to be here all day, every day. Talks being full regularly. Every speaker has told me they've had a great time on stage because the crowd has been super receptive to everything they wanted to share without really knowing whether Singapore is the same kind of audience as what they would expect in San Francisco, for instance, or London, for instance. And it's been super heartening to see full rooms every single day. But the thing is that you can't just copy conferences from overseas and bring them into Singapore, right? It would have been very easy for us to be like, let's just take AIE World Fair and then copy paste it into Singapore. But Singapore is a different audience. Singapore has different kinds of people. Singapore has different kinds of expectations from conferences. If this was a research-heavy conference, maybe we lose half of you. If this conference is too easy, maybe it doesn't feel like you're getting the rigor that you expect from an AI engineer conference. So finding that balance is a very uniquely Singapore thing. Additionally, you kind of have to make this conference your own, because if you're not going to copy something wholesale, what is your contribution to what programming looks like? Sherry had, I think, about 21 versions of speaker lineups. How do you categorize speakers together? How do you make sure that if you're listening to OpenClaw related talks, you're hearing a few at the same time, because you then get to sort of see perspectives across few speakers and then come to your own judgments. Maybe earlier today you heard Magic Path and Magic Pattern sort of follow each other. Similar names, similar domains, very different approaches to how they think about product. And this allows you to sort of get your own opinions on how things work. But additionally, we wanted to add our own flavor to AIE events. Everyone here had a ticket to the workshops. This is usually not a default at other AIEs, but we think that if you're going to do a builder-first event for the first time in Singapore, you need people to build. Like, this is not a thought leadership event. This is not a fireside chat panel about the future of AI event. This is a builders event. And if you're not building at least one of those days, then we've kind of defeated the purpose of all of this. So workshops were part of it. We added some decompression sessions because we feel like AI anxiety, token anxiety is such an given these days, given how quickly things are moving, that people need a way to understand their relationships with AI and find a way to decompress amidst 30+ talks every single day. That part is important. Obviously, in true Singapore style, we want to make sure you guys have a good time, so we threw a massive party last night where Geoff Huntley and I ended up DJing before we had a headliner DJ come through. But that's, again, some things that we think, if you're going to do an event in Singapore, we have to do it the way we like to do things here. But obviously, as much as the talks are great, the programming is great, the whole point of running an event like this is the hallway collisions that happen, people you meet in the expo, people you get to talk to. You had the main teams from most of the sponsors here in person. You had the speakers that you could meet at any given point of time, whether you're getting a coffee, whether you're having lunch, whether you wanted to just meet them because they're sitting around you attending talks as well. Giving access to speakers, giving access to teams is something that's very rare in Singapore. If you go to any conferences, whether they be for AI or other things, you'd mainly see a marketing person sitting there telling you about the brand, exchanging name cards, and that's about it. That's not quite the experience when you're trying to meet companies. Some of them have never been in Singapore. Some of them have never set foot in any of these conferences. So creating those moments outside the theater was really important to us, and I believe that a lot of you got the opportunity to go around the expo, meet the team. Some of them have flown 17+ hours to be here. Some of them have never been to Singapore before. So creating that experience for us was really, really important, and we hope that like AIE allowed you to get that over the weekend. But the important thing here is not just about the people in the room already. It's about how do we position the next generation to also benefit from this. As I mentioned, tickets are expensive, but we shouldn't gatekeep opportunities from kids who are coming up in the scene, in university, in school, through extenuating financial circumstances to access conferences of this ilk, because they will be the ones building. So we provided scholarships. There was some information about this outside, but essentially we had one of our sponsors, who was supposed to be a big organization that we've heard of, pull out 2 days before we were supposed to announce the scholarships. And that was pretty gut-wrenching to us because we wanted the kids to be involved. So Rachel, Sherry, and I had decided that we will pay out of our own pockets and do this. But a lot of builders in the scene, in their own personal capacities, decided to chip in, and we could bring 20 students in. 20 students who got to meet the speakers, hang out with them, learn from them, and maybe have that opportunity of a lifetime that they wouldn't have in any situation. We have some students side stage. We'd love to have them on stage. So could we have them on, please? So we found these students through all the hackathons we've organized, all the events we've done. These guys show up for every event we do. And obviously, all our events are free by design because we want them in the room. But this is the pinnacle of opportunities that we could have provided. And these are obviously 4 of like 20 people we sponsored. And you might have seen them around. They've been the ones doing all the recaps on Twitter, posting about it, writing about their experiences, meeting all the people who have flown in. And this was an incredible thing, at least, that we could have done to make sure that the kids enjoy this. So thanks again, guys. I do want to shout out the people who did chip in. Ian, Patrick Kelly from Arize. Arize is actually a sponsor for this conference, but Patrick decided to chip in his own money to support the kids on top of it. Neil Chang, Ivan Leo, Kaspar, Suken from Iterative, Zane, myself, Sherry, Rachel, a lot of anonymous builders who chipped in to sponsor 20 students. So again, a big round of applause for everyone. So we've heard this quite a lot of times, especially in Singapore. There's no scene here, nothing is happening. I think I need to fly to SF to attend a conference. But I think at the end of the weekend, I want everyone to feel that you guys are the scene. You guys showed up. regularly, every talk, every workshop, around the expo, at like 8:30 yesterday, 9 a.m. today, through the rain, through whatever conditions could have stopped you. You guys showed up for all the side events we organized in the lead up to this. Every event was oversubscribed. Every event had hundreds of people showing up, even if you didn't know the companies, even if you didn't know who was going, just because you knew that there was something bigger going on that you could be a part of. And I want that to be something that you guys remember, because this is something that goes beyond just AI Singapore. This is what's going to build the AI builder scene in the country for years to come. And that's why this isn't an isolated moment. I hope you guys keep showing up. I hope you guys keep building. I hope you've made friends over the weekend that you'll stay in touch with. I hope you go and build at hackathons, maybe start some stuff together. I hope you post about it. I hope you don't look for permission to share the work that you're doing, because this is how people get to know that Singapore is a city where action's happening, that it's not only SF where things are happening, it's not only London where things are happening, but Singapore, not just in Asia, but in the world, is a city to be reckoned with. And on that note, I really want to thank all the speakers who came, the sponsors, our main sponsors, diamond sponsors and platinum sponsors, OpenAI, ZAI, Google DeepMind, Cursor, Arize, the volunteers who didn't sleep, the team that held it together, the 1,000 of you who came. I want to call the team up, both the organizing team and the volunteers up on stage, because these guys have been the backbone for the entire weekend, running without a hitch. These guys made sure you guys got fed. These guys made sure you guys got your badges and access sorted out. These guys made sure that you didn't see the stuff that was slipping through the cracks, just so that you guys could have the best conference experience possible. We're not done yet, hold on. So obviously, like in true Marvel movie fashion, you know, AI engineer will return. We have a sign-up sheet for people who are interested. We'll send out some early tickets and like information as we figure things out, I guess. But we do want to make sure that we have your intent recorded so that if and when we announce in the near future, you guys are the first ones to know, because you guys took a chance on us. For guys who you've never heard from, for a conference that's never been in this part of the world, to take a chance and show up for the first edition in numbers and regularly is something that we cannot take for granted, and we are really, really, really grateful that you took a chance on us. So thank you so much again.
Can we get some music in here?
Yeah, we do another photo. We don't have enough photo. Where's Swix? Swix, come up. Swix is the man behind AI Engineer globally. He's also Singaporean, if you heard yesterday. And him letting us do this is why this is happening. So thank you, Swix. Swix, please.